Hey guys, welcome to yet another session by Scalar, and in this particular session we're going to look into big data A to Z. So before we move on with this particular session, please make sure to subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. If you have any queries, leave a comment down below and we would love to help you out. So now, without any further delays, let's just look into what exactly will be taught in this particular session. To start with, we'll be giving you a simple introduction to what big data is. Once that is done, we'll be looking into more concepts in big data, and then what are the 5 V's of big data. Then we'll have a quick tech talk on how exactly big data is basically impacting decisions in companies. So that will be a quick discussion we'll be looking into. Once that discussion is done, we'll be going into more deep concepts in big data. And after that, we'll be looking into what are the different types of data and file formats. Then we'll be looking into commodity hardware, distributed systems, and all that in big data. Once that is done, we'll move on with Hadoop. We'll be looking into Hadoop and its features. Then we'll be looking into MapReduce. And after that, we'll be looking into Yarn, which is a really important component of Hadoop. And once that is all done, finally, we'll be looking into a demo, which will help you even better to understand Hadoop and everything around it. So without any further delays, let's begin with the session.
Hey everyone, my name is Shashank Mishra and I'm working as a data engineer, and previously I was working for Amazon. And for me, it's been almost 4.5 years in this IT industry, and from the very beginning I'm working closely with the big data domain, solve different problems, different use cases for different business verticals like aviation, pharmaceuticals, fintech, and employer services, and many more. So I think we have met previously as well. If you haven't checked those videos where I talked about cloud computing and AWS, you can visit those previous videos and you can get to know more about the cloud computing and AWS. But in today's session, we will be focusing more on the big data side. So this session, that's why, is going to be really important. Nowadays, we all know how much data is important in this industry. Every business unit, every enterprise is actually using this data for their decisions. So this is really important. And nowadays in the IT industry, lots of job openings in this big data domain, be it the data engineer, be it the data scientist, AI, ML related positions, data analyst, business analyst, BI engineer, multiple positions, and very booming domain. Right nowadays, if you only think that software engineering profile is something where you can make your career, and they are the only job profiles where you can make the good compensation and companies are paying really well. So in this current century, like, different companies are heavily dependent on the big data side, and that's why, I mean, this field is going a lot. And I mean, that was the main reason even I started my career as a software engineer, and after some time I took a move into this data engineering because I found it worth, right? I mean, very crazy profile, and you will definitely love this entire big data ecosystem when we will be talking about the fundamentals. So that's why this session will be long, but we will try to cover lots of important things. Not will be jumping on some advanced part or any jargon words. We will try to cover things step by step, like covering all the fundamentals, important things, like very minor things related to big data, so that you are able to connect the dot, and as a beginner and as a noob, you can actually understand what is the big data, what are different terminologies, and even at the end, probably we will also talk about the very important and the very first distributed computation framework, that was the Apache Hadoop. And also we will be doing some hands-on like the hello world program of Hadoop. So yeah, this is going to be really amazing. So if you want us to keep bringing such kind of content, then make sure to like this video and also subscribe the channel, so that you are just updated with all the latest and some really crazy content which are like planned, and you don't want to miss anything. So make sure to like this video for better reach, and comments your and in the comment section put down your opinions as well, your thoughts as well. If you know something about the big data and what next you want from our side, put it in the comment section. And yeah, don't forget to subscribe. So let's quickly jump on to the main agenda, where we are going to start with the big data. All right, so big data fundamentals, that's the topic for today's session. So even in that one, first we will be talking about why data is the new oil of industry. This is the most important topic to begin with. like whenever somebody asks you that, hey, can you just tell me about the importance of big data, like every single person and every other person is talking about, okay, data is important, we are talking about data science profile, AI ML related things, but why actually data is important? So when this topic came into the picture, there were a lot of theories about it, and where some intellectuals, some industry professional talked about the importance of data, right? Even like few 20, 30, 40 years back. So we will also talk about that one, like why it is really important. I will actually just show you the importance of big data with some valid points, and I will also explain it so that you can also relate with it, why data is the new oil of the IT industry. So the first point here, data is an essential resource that powers the information economy in much the way that oil has fueled the industrial economy, right? So when the discovery of raw oil or these petroleum things related happened, that actually gave some revolution to this industrial economy, right? Your vehicles, factories, air travel, like sea travel, everything. Like it gave a new revolution to that, and obviously the business was heavily dependent on that transportation, right, and or that industrialization. So the same way nowadays data is doing the like exact thing which oil is doing for the industrial economy. So data is doing the same thing for the information economy. Nowadays we all know information is really important, right? Why it is actually important, I will just describe it in the technical terminology as well. So nowadays every single enterprise want to take the data driven business decisions. Data driven means you are just talking about based on the facts, you are talking about on the insights, right? That you are just not showing any, or you are not randomly predicting anything, okay, tomorrow will something will happen or blah blah, right? It will be based on the facts, meaningful insights based on the previous history, right? So the whatever decisions we are going to take next, that will be dependent on the data driven things, okay? So since our decisions are heavily impacted with the data, that means they are the data driven business decisions. So the very good example is for an example, we can take the example of Amazon e-commerce platform, right? So what happens, right? Even let's say if you are a new business, okay, and you want to start with some unique idea, you will land into the market actually, okay? So first thing, what will you do? You will not randomly just select the location, or you won't randomly just open your shop there and start selling your thing, right? First you will do some analysis, right? Okay, what is actually needed in that location, right? How many people will buy my product, right? What is the age categorization, how frequently and when people used to come out from their houses and purchases the thing, and what is the impact of new offers, new discounts, right? This is pure analytical related things, and that will definitely help your business to grow, right? If you don't know your mistakes and the areas where you actually need to focus, then probably you are not going to grow in your business, and that's where the analytics plays a very very important role. So when you have this data, your customer, let's say data, your business related data, if you have this data, you can actually visualize it, you can plot some things, you can plot some meaningful insights out of it. That for an example, let's say you like Amazon e-commerce platform, right? There was a Diwali sale came, right? And obviously till 2 3 4 days they will start collecting the data, whatever transaction happened on their platform, and after that they can actually look, right? Okay, what are the geographical areas where the sales was quite less, and how they will get to know it? Just because of that data, whatever data they have collected in during that period, right? They can actually look at these geographics. Okay, this person is coming from, let's say, Uttar Pradesh, this person is coming from the Bangalore, right? So that's how at least they can see like state wise where our sales is impacted. So they will actually target those areas much, they will try to put their extra efforts. So how this is happening? Based on the information. That's why it is the data, raw data and the raw oil are very very similar to each other. Next point is information can be extracted from the data just as energy can be extracted from the oil. So here the end product or the end thing by the raw oil is the energy, and the raw data, what is the end product? That is the information, right? Data at the end, it will give you some meaningful information. In the beginning it will be in the complete raw form, right? Unnecessary things will be there and unfiltered and complete junk, complete raw data. But at the end you can make it meaningful. So in between some process will happen, right? Like getting meaningful information from the raw data, in between you will be doing something. Same way, if you have the raw oil, you cannot use it directly, right? You cannot just put it in your vehicle and start driving. You cannot do it. You need that end product which is useful for your vehicle. That is like your petrol, diesel, something like that. So in order to get that, there will be some process in between, right? Refining process. There will be different stages of refining where we will be getting different petroleums, even like gasolines, different gases, other things, right? So we will keep on getting it. The same process we follow to get the energy from the raw oil. In the same way we get the information from the raw data. Now the traditional oil powered the transportation era. In the same way, the data as the new oil also powering the emerging transportation options like driverless car. I hope you guys now imagining the Tesla, Elon Musk, and hyperloops, which are based on advanced synthesis of data in form of algorithms and cognitive knowledge without use of fossil fuel. So obviously transportation, like traditional, if you talk about the traditional transportation, it is completely dependent on this oil, right? The petrol, diesel, CNGs, it is completely dependent. And when that discovery happened, it gave again new revolution to the traditional transportation. But nowadays we know about these driverless cars like Tesla and these things. So how they are actually functioning based on the artificial intelligence, based on the machine learning algorithm, right? They are using this data and their systems, right, are learning by their own using the advanced algorithms, and those algorithms are heavily dependent on the data, the processing, the analysis. So same way, I mean, the data is also giving a new revolution to the emerging transportation, which is very unique, which is very good, I mean, right? You can even imagine the next coming 30-40 years, like what will be the situation. Probably if everything goes really well, you never know, we can just get away from these oil related things, right? Probably we will be directly on these driverless cars or driverless things. But yeah, this thing will take time, but this is definitely giving a new revolution to the emerging transportation. Now traditional oil is finite, data availability seems infinite. That is also true. We keep on hearing these things like probably the next world war will happen, probably because of the water or because of the oil. Okay, and that's true. Because the availability of oil, at least till now, whatever we know, availability of traditional oil is finite. We have very limited resources of these petroleums and everything. But data is infinite. Every day, whatever you are doing, that will actually create a new activity, and that will be treated as a new record, new set of data. So data is infinite. That is true. You can imagine it. It is completely attached, and it is part of our day-to-day activities. Whatever we are doing, you are watching some videos, you are even watching this video, right? That is what? That is actually a data. And you are doing some transactions, you are buying something, you are ordering some food. So everything is data. Data is just everywhere, 24/7 around us. Now next point is data flows like oil, but we must drill down into data to extract value from it. Data promises a plethora of new uses, diagnosis of diseases, direction of traffic patterns, etc. Just as oil has produced useful plastics, petrochemicals, lubricants, gasoline, and home heating. So I will describe this point, how what actually does it mean. So when we have the raw oil, right, if we pass through with different refining stages, we will be getting different products, right? So those different refining stages is actually, you can treat them a different logic or different way to process the raw oil. That's why we are getting a different products, the petrochemicals, plastic, lubricants, and gasolines. In the same fashion, when we talk about the data, so even nowadays data is being used in different sectors, be it the entertainment, be it the healthcare, be it the e-commerce, be it the aviation. Everywhere data is being used, and probably the way of processing can be same, but those business rules will be different, right? And that's why here you can see, right, a plethora of new use cases. If you have data, you can definitely use it. If you are keeping it in at some place and you are just not even bothering about it, that's not gonna help you at all. So in every sector, you can just see the uses of the data, how or the way our healthcare has improved just because of the data analysis, right? The cancer detection related things and some very major and severe disease related things, scannings and everything, and automatic traffic directions, and automatic challans, right? And everything that is quite unique and heavily dependent on the data related things, right? So that's why different domains, different use cases, different business rules will always lead us to the different use cases, and same happens with the raw oil as well. Now the last point is, like oil, data is only useful after refinery. That is also true. I mean, if you have raw data, if you have raw oil, you cannot use it. That is completely useless if you are not refining it. And that in technical terms, in big data, refining means the transformation. We will talk about it in the later slides, but that's the actual meaning of the data. And I think after discussing these points, you can totally understand why everybody keep on saying that data is the new oil of the IT industry, just because of these points. So now we will talk about the important things. What is big data? There are some technical aspects, right, which we need to understand before moving into the big data related things and doing some hands-on. So we will try to understand what is big data in technical terms. So big data gets generated in multi-terabyte quantities. It changes fast and comes in varieties of forms that are difficult to manage and process using RDBMS or other traditional technologies. So big data, even its name suggests, right, the data is going to be very huge. We know different measurement units of data, let's say kilobytes, MBs and GBs, then terabytes, petabyte, hexabyte, so on. Even I don't know. So that's how big data is. You can even think that the volume would be quite big. That's why, like, generated in multi-terabyte quantities, right? Even if you have like just 1 KB file, you cannot call it it's a big data. It is data, but you cannot call it as a big data because obviously the volume would be quite big. And it changes fast, right? It comes in a very faster pace. I will also talk about the different properties, right? So don't worry about that. If you are not able to understand what does this fast and comes in varieties means, I will definitely talk about it. But yeah, the pace would be quite rapid, pace would be quite fast, and sometimes even you will get the kind of data which you cannot even read, which you cannot even understand. That's why variation or variety comes into the picture. And definitely it cannot be managed by the traditional databases. So if you are a beginner, and if let's say you are a college student, then you might have like study those DBMS related subject, MySQL and Oracle SQL, these things, right? So they are typical traditional RDBMS, right, where data will be stored in the form of tables and rows and columns, right? So if we talk about the big data, that huge volume, that huge massive scale of data cannot be handled by these traditional databases. Big data solution provides the tool, methodologies and technologies that are used to capture, store, search and analyze the data in seconds to find relationship and insights for innovation and competitive gain that were previously unavailable. And so here, whenever we talk about big data, we just not talk about its definition, we completely talk about the solution. So whenever we talk about a big data solution, it will contain different things. Like there will be some tools which will help to process the data. There will be some methodologies, some techniques, some frameworks which will help us to bring the data from point A to point B, then process it, applying the business rules, then making it available for further consumption. And once it is available in the downstream system, there will be end users who can use it to build their reportings and like to get that meaningful insight. So in big data solution, that's what actually mean. It will like help us to figure out what is the relation between different data sets and how we can actually get the innovative and information out of it. Next is the 80% of data getting generated today is unstructured and cannot be handled by our traditional technologies. That is also true. But what is unstructured data? Don't worry about it. I will talk about this one in the next slide. But that is one type of data you can just understand, and 80% of the time we will be getting this kind of data. And again, from the first line we can understand these massive scale of data cannot be handled by the traditional databases. So this is a very simple and very basic example where you can see, right, the big data is in the middle, and you can see, right, different domains, different use cases, like communication, basically the telecom, right, or wherever, not only telecom but things if you are on the internet and that communication is happening, so data is present there. Data and big data solutions are impacting the retail sector as well, right? Your groceries, your like clothings, your food, everything, right? Retail sector, it is impacting a lot. Vehicles, like again, driverless cars we were talking about, and automation, wherever we talk about things related to the automobiles, and you will definitely see the use of data, because automation will be there and smart sensing will be there. So everything is completely depend on the big data. Industrialization, definitely, I mean, that is true. Big data will be there, and it is also impacting this sector. Healthcare and medical, I mean, this sector has improved a lot because of the data, and this is helping a lot to grow and to improve the medical and health facilities based on the different data of the patients, and like advanced algorithms, which is actually helping to build some unique tools and unique things, which is just like helping the healthcare sector to minimize that severity of diseases, and figure out things on a very early stage so that they can cure it. So now we will talk about the next point, amazing facts about the big data. Yes, this is interesting. You will definitely love it when you will see the things in the form of stats, right? Probably some unimaginable facts. So according to the 2015 IDG Enterprise Big Data Research Study, business will spend an average of $7.4 million on data related initiatives in 2016. So this is the older data, and this is the fact related to 2015-16. But now you can even like just double, triple, and 4 times this number, 7.4 into 5 something. That much amount of money companies and different enterprises are spending on this big data analysis in their companies, and that is true. That's a complete fact. Everyday data is growing in a massive scale, and again, every enterprise, every company just want to utilize that data so that they can improve their growth, they can compete with other competitors, because data is the only thing which can help them to grow in their business. Next is the bad data or poor quality data costs organization as much as 10-20% of their revenue. That is also true. So garbage in, garbage out, that happens, that's true. So if you have data, if you have not analyzed it quite well, and probably you're gonna miss everything. I mean, that will actually impact your growth, that will actually impact your revenues if you are not utilizing the data in a proper way, and if there were some mistakes to get the exact facts, exact insights, or exact meaningful information. Third point is a 10% increase in data accessibility by a Fortune 1000 company would give that company approximately $65% million more in annual net income. Yes. So 10% increase in data accessibility, right? The data accessibility is very easy, and these Fortune 1000 companies, right, would give that company approximately like 65 million more in annual net income. That's a big number, and that's how you can even understand the data is actually impacting the different industries, different companies. Next point is big data will drive $48.6 billion in annual spending by 2019. So this is a cumulative fact, that's a cumulative amount, like in the IT industry, that much amount will be spent for the data analysis. It will contain everything, the resources, the like manpower and everything, right? It will include everything. That much amount will be spent for the annual spending, that is. Next is The data production will be 44 times greater in 2020 than it was in 2009. Individuals create more than 70% of the digital universe, but enterprises are responsible for storing and managing 80% of it. And that is true. So we are on social media, right? We whatever activities we are doing, that is actually a record, that is actually some entity, and that can be something which can be really meaningful for the companies. That's why these companies are actually capturing our activities, whatever we are doing on their platform. They will keep that information. That's why it is written like 70% of data is just because of the digital universe, because of the ease of the internet, the ease of the access, everything. So that's why like this 44 times, like in 2009, if 100 unit of data was getting produced, so 44 times like 4,400, that is a very massive scale. And why that huge amount of factor 44 times? That is because of the digitalization, right? Again, the access over the internet and access over the different platforms, these things. So this is the main reason that data is growing very fast on daily basis. And like in next coming years, like after 10 years, that 44 may turn into the 100, 200, because new innovations are coming. And every new innovation will come with new facts, new ways of generating the data, so that scale may go really high, and exponentially it will increase. Next, it is estimated that Walmart collects more than 2.5 petabytes of data every hour 2.5 petabytes of data. That's really big from its customer transaction, because we all know Walmart is a e-commerce platform. There will be multiple customers who will be buying something from their platform, and they will be making some transactions. So that cumulative volume of data becomes like 2.5 petabyte in 1 hour. And in peak hours, right, if we talk about some festival seasons or everything, that scale 2.5 may even turn to be like 10 petabyte per hour. So that will also depend on the peak as well. A petabyte is 1 quadrillion bytes, or the equivalent of about 20 million filing cabinets worth of the text. So that is in terms of the technicality, but this is the main and important point. 2.5 petabytes of data every hour, but in the peak it may even go up to 8 or 10 petabytes as well. A 2015 report by Capgemini found that 56% of companies expect to increase their spending on big data in the next 3 years. So you can even understand, like, these facts are speaking why companies are so much concerned about the big data, why they actually want their data to be analyzed. That is the main reason, because data driven business decisions. There will be a shortage of talent necessary for organizations to take advantage of big data. By 2018, the US alone could face shortage of like 140k to 190k skilled workers with deep analytical skills, as well as 1.5 million managers and analysts with the know-how to use big data analytics to make effective decisions. So now you can even understand why in the beginning I was talking about this big data domain is grooming a lot, right? New opportunities every day, every single company, be it the startups, be it the mid-sized companies, and be it the top-notch product-based companies, they are hiring a lot, because yes, this is the new domain, hot topic of the industry, right? Companies need a data analyst, business analyst to like generate those meaningful insights. They need data scientists, they need machine learning engineers to work on complex algorithm, so that they can innovate those ideas, they can bring some new things on the platform which will help to grow their business. They need data engineers to work as a frontliner, so that they can bring the massive scale of data from some point X to Y, and just applying those business rules, creating those scalable pipelines, handling that massive scale of data. Lots of good opportunities. If you are someone who is still in a dilemma, or let's say watching that big data probably is not a very good domain to start with, probably you are still in a myth, these facts will totally clear your mind that yes, this is something which you can look forward as a career profile. Hey everyone, so in last 10-15 years, everybody is talking about big data. And this is true, like every second person is just talking about data, because we all know I mean, just 10-15 years back, the profile which was really hot in the market, that was software engineering, web development, right? But now in the industry, if you are part of it, you are closely following it, you definitely know that everybody is talking about data. They used to talk about profiles, right? Even the job profiles prior to the big data, we were talking about software engineering only. Now even there are hot job profiles in the market. Let's say data engineering, data scientist, machine learning engineering, and data analyst, business analyst, and many more. So people are talking about it. That's why big data is something which is basically growing in the market, and also has become the hot topic in the industry in terms of the job, in terms of the compensation, in terms of the growth in the tech side. So data is the future of tech itself, and today that's what we will be talking about. First, we will try to understand what's the big data on a higher level, and after that, how this big data thing is actually helping the industries and helping different companies to take their decisions and basically to improve their business. And after that, we'll talk about some 2-3 very unique case studies to let you know that how big data has helped those kind of enterprises, and how those enterprises are actually using big data, leveraging big data in order to solve some complex problems and even improving their businesses. So first, let me tell you what is big data actually. So probably with the name big data, you might be thinking big data would be something which is quite big, right? We also know the normal data. So first, let me tell you the impact of data in our day-to-day activities. So how you can actually relate, data is everywhere nowadays. I mean, it's part of your day-to-day activities. Whatever you are doing, data is involved there. You are wearing smartwatch, data is there. You are using your mobile phone, data is there. You are even using your Wi-Fi's networks, data is there. You are listening music, data is there. You are ordering food, data is there. And that's why it has become really important for everyone to understand data really well, because this phrase is really popular nowadays. Data is the new oil of the industry, and that's definitely true. So talking about the big data, it's not a plain word, or there isn't any kind of very straightforward definition which you can say yes, this is the particular definition which describes the big data, right? Okay, so 3 V's are there which actually defines the big data. First is volume. So what do we mean by the volume? It's definitely the amount of data we are processing nowadays. And let me tell you, right, in this past of 10 years, data volume is growing like a crazy speed. I mean, we would have known about the KBs, MBs, GBs. Now the data volume is basically like terabytes, petabytes, hexabytes, gigabytes, right? It's enormous, right? The data volume every day, it is growing like a crazy speed. And why it is happening? Because of the ease of the internet access. Nowadays, internet is something which is playing a very important role in the growth of this massive amount of data. And volume, you can even understand. Let's take an example of social media websites, right? Facebook, Instagrams, WhatsApp, whatever is happening there, that is data. Every single activity is data. You like something, right? You, let's say, liked some of the post, so those likes will be counted. You actually see those numbers increasing. Somebody liked, somebody commented. So whatever they have written, that is a data, right? And those platforms are capturing it and doing analysis on top of it, and that's what it is actually helping them to grow. So volume is basically the storage or the amount of data in terms of the measurable units, let's say KBs, MBs, GBs, terabytes, petabytes. Second is the velocity. Velocity is basically speed of the data. So the velocity, what you can say, basically the speed in which data is actually growing. And that's what nowadays, let's say the bank transaction, you transfer some money via the UPI, okay? So that is happening in a very real time. Even it will take just fraction of seconds to complete the transaction. And there would be another processing as well, the batch processing, where data will first collect till some threshold value, and after that we will be processing it. So here nowadays, in this era of internet, obviously things are quite in the real time. Whatever is happening, we can see its impact, we can see its value. That is something which is actually a very important factor of the data volume. In a more real time way you are capturing the data, the more amount of data you are capturing as well. So these are the two things. Third is the variety. So variety also very, very important, right? The different kinds of data we are processing. Okay, so earlier probably what we would have thought, like let's say just go back 10-20 years, right? What we would have thought only, let's say textual matter, right? PDFs, okay, books, whatever text is written there, that is the only data. No, data is not like that. Nowadays the definition of data has changed a lot, and in terms of the big data, if I say, so variety is something, basically the different types of data we are processing. So in big data we have three things. First is the structured data. Structured data is very clean, like row, columns. Okay, so for an example, you can say, let's say you have a data of students, they will have some, let's say, columns, student ID, student name. So this is kind of very structured way. You know how this structure will look like. Just treat it like an Excel sheet, right? So this is the one way. Second way is basically a complete unstructured data. A best example is your audio files, right? Your video files. And why we are calling them as a unstructured data? Because when you will try to open it, you cannot read it. Let's say audio file, you can definitely listen it, but you cannot actually read it. And in contrast, when we talk about the structured data, it is like human readable. You can actually read it, what that data means. And third, we let's say talk about the semi-structured data. So it is a hybrid version where you can somehow identify what is the data, but it is not completely structured, very flexible. Sometimes you can add some attributes, you can even remove. So the very good example is JSON, XML. These are the file formats which basically are the type of semi-structured data. So this is something, right? In a cumulative definition, these three properties are very important to understand big data. And now we'll move on to the next part, like how the big data is actually helping different companies to take their decisions and to improve their businesses. So honestly speaking, big data can help any company in 5 different ways. So first, making better business decisions. Second, understanding your customers. Third, delivering smart services and products. Fourth, improving business operations. Fifth, generating income. So let's talk about all these 5 ways one by one. So first is basically making better business decision. So what does it mean and how big data is helping in that part? So let's take an example. Let's say you are an e-commerce website which is selling some products, but in order to improve in your business, if you don't have the past data points, if you don't have any sort of historical data so that you can compare how much earnings you did in last quarter and how much you have earned in this quarter, and if you don't know about those percentage of profits, losses, and many other matrices, useful matrices, then probably you won't be able to understand whether you are moving in a right direction in your business or moving in a wrong direction in your business. So that's why those important matrices, that historical data computation and those historical data comparison can help these companies to take their business decisions really well. And second point, we will talk about understanding your customers. So nowadays every company which is basically product and customer oriented, so be it the food delivery services, let's say, be it any e-commerce platform, be it the any kind of let's say OTT platform, they are definitely customer centric. And why customer centric? Because everything is dependent on them, and if they are not able to understand their customer really well, probably they are not going to survive in the market. For these kind of companies which are product and customer centric, they will definitely capture all the activities done by their customers on their platform. And this is the really important part for these companies, because based on those things they can definitely identify what is the actual need of this and that customer, and that is basically behavioral understanding of customers, and this is really important for the product based companies. And third is basically delivering smart services and products. So when, let's say, you understand your customers really well, so always for the better retention of the customers and better loyalty, you will always try to deliver smart things, right, which is basically liked by different customers, and you will try to innovate on that. You will try to add different flavors on top of that, because now you have understood your customer, what is his and her taste, and what kind of behavior he is doing, right? Based on the complex AI ML algorithms, you can take those decisions and recommend some really, really good products, really, really smart services, which can be really useful for the customer, and it will add more in your revenue and more in the company growth. Fourth is basically improving the business operations. Now if again we go back to like 20-30 years back, then most of the things were obviously dependent on the manual side, be it the manufacturing, be it the factories, whatever, right? Like so many big plants, let's say automobile machineries, heavy machineries, okay. Obviously this part data has changed a lot of the things in this section, be it the transportation, be it the automobile sector, and be it the business operations, and how it is improved because of the automation, robotics. And what is that? It is definitely again the data. These machines are something which learns from the data, they identify the patterns, they become so smart that they can do the things really fast, they can identify things quickly. And that's what automation and robotics is, and very, very important in the kind of domains where which are actually dependent on the supply chain, right? Because whenever there will be a huge demand, they need to develop the things, they need to create the things in a very quick span of time. If they are completely depend on the manual efforts, then obviously they will lose their customers, and they will lose their revenues as well. So the last point will be generating an income, and this point is obviously dependent on the above four which I have mentioned. Because if everything is sorted, your operations is doing good, you know your customers really well, you are delivering smart services product, you are taking smart decisions, business decisions, then these four factors cumulative will generate a great source of income, great revenue, great growth factor in any of the enterprise and business. So these were some 5 important ways where companies are using big data to improve their businesses and their growth. So now I'll be sharing some interesting case studies related to big data by different companies. And first is definitely Netflix, your favorite, my favorite as well, the best OTT platform. So how this Netflix is actually leveraging the big data part, and how you can see the actual use of big data there. Let's suppose you are the first consumer of the Netflix. For the very first time you logged onto their platform, you took the subscription, and you are someone who loves, let's say, action movies, right? Action web series. And for the very first time you just watch any random action movie on their platform, right? You watched it, let's say 30-40 minutes, and then paused it. Then you tried to explore any other let's say action movie, right? And you again, let's say, watched it for next 60-65 minutes, and you kept on doing it. And let's assume you really liked some of the action movies so much, so that you again came back to their platform and like just rewatch those movies. So what all things Netflix would have tried to capture, right? Not only one metrics, there are a couple of things, because you did a lot of activities on their platform, and this is the actual data for the Netflix. So next time, probably after 3-4 days, when you will again log in onto their platform, you might see, oh wow, there are some wonderful suggestions of new action movies. But did you try to think that how Netflix knows that you only like action movies so much, and they are giving you so many suggestions? And that's happened because of the your activities on their platform, right? So how this is happening, again based on some complex AI ML algorithms, they are trying to build some really cool recommendation engine. This is the keyword, recommendation, because Netflix itself recommending newly launched action movies, or basically let's say some top rated action movies to you, because they know your taste, they understand their customers really well. And that's how the Netflix is like doing more and more customization, and probably giving some of the best services to their customers. And how this was actually happening, again let me just repeat, you did some activities, they were capturing everything, how many times you played a movie, what kind of movies you watched, how many ratings you given to those sort of movies, right? So everything will be captured by the Netflix, and as a cumulative result for every individual customer. And when you just add this data, it becomes enormous, because across the globe people are just accessing Netflix for different kind of things. And you can understand, right? Every person has a different taste of music, movies, and Netflix is actually doing it in a custom way, right? Because it understands every customer's behavior based on their activities. So somebody may like, let's say, thriller or drama, and somebody may like the action. So every individual person is getting smart recommendation of movies, web series based on their activities and based on their interest. So here you can see the actual use of the data. And now second interesting use case, I'll talk about the ride hailing service. So whenever you want to travel right from point A to point B, and let's say you are in a metro city, definitely you will look for a cab option if you don't own any kind of vehicle. So whenever we talk about the ride hailing services, the very common name and the popular name is the Uber. So how Uber is actually leveraging, and they are leveraging it in a very, very smart way, right? So again, under the hood, Uber is also leveraging those complex AI ML algorithms in order to understand their customer, and most important, the supply chain and demand related thing. So if any of you is a customer of these kind of cab services like Uber, so obviously you would have traveled also. And if you can even remember some of your worst cases, let's say you are like stuck in your office because it was raining really, really heavily. All right. So what will happen at that time, because lots of people will be there in that tech park, who are desperately trying to reach their home because it's heavily raining there. And at this moment, when you would have tried to book cab from Uber, definitely you will see a sudden increase in the fare prices for the same distance which you were traveling on daily basis. So that's how even the Uber is leveraging those data points, because they know their supply and demands, they know based on the geographic locations, right? And that is the point where Uber is taking best advantage of the peak hours, because out of 20 people, obviously 2, 3, 4, 5 people will be there who are willing to pay 250 or 300 instead of 100, because they want to reach their homes as soon as possible. And that is the reason. And now I would like to talk about third interesting case study, which is actually related to the aviation sector. And this case study is actually really close to my career experience as well, because I have worked in the aviation sector as well. And that's like, again, as a data engineer, so I have solved the complex big data related problem for the aviation sector. And this project was basically for one of the leading US airlines company. So what challenge they were facing, basically they wanted us to build a kind of solution which gives a 360 view of a customer's itinerary, right? Because whenever, let's say, a customer books a flight from point A to point B, right, there will be n number of events will be happening during this completion of the journey, starting from the ticket booking and reaching to the destination, right? And there could be multiple scenarios when a customer travel from source A to source B, like even seat change can happen, right? You booked something and then there could be a seat change event, and many other events can happen. So that company wanted us to build a big data solution which can actually give them a 360 view of the entire journey or the entire itinerary of a customer who traveled from A to B, because on daily basis they were capturing a numerous amount of data, terabytes, petabytes, from different vendors, even from their website, whatever, let's say, happening, for everything they had the data. And this resultant solution which we provided them, it was definitely based on some complex logic, complex big data processing which we were processing daily, so that their customer service agents can see the entire itinerary of any customer, and how this will actually help that company to basically serve their customers in a better way, and basically giving the best experience to their customer. And why that solution was able to give best experience to those customers, let's say I am a frequent traveler of any XYZ airline, and some random day when I was traveling, some unwanted events happen, right? And for that I feel I should be reimbursed, or I should get some kind of refund from the company. So for that I will definitely try to reach out their customer service, their support, and I will explain my situation. But how that customer service agent can respond to those customers, he or she should definitely know what all things happen granting any sort of compensation, she needs to verify whatever you are saying, whether it happened or if there kind of any information gap. If everything is matching, everything happened according to the customer, obviously that request of refund can raise to the leadership, and after the approval, that refund can be provided to the customer. And obviously this kind of service will make customers always happy, and obviously your customers will be loyal towards your airlines. So now I hope you guys understand the big data part in a clear way, and also in the real world how these kind of companies, big tech companies, are leveraging the big data part in order to improve their business, their growth, their customers and everything. So every aspect is really important for these kind of companies. And also I have also talked about some interesting case studies. These kind of case studies will definitely give you a better vision, and it will also generate some level of spark in your head, so that you can deep dive into the big data and understand how things are actually working and how these companies are trying to solve some of the complex customer related problems. So that's what we had in this video. So if you like this sort of information about the big data, and if you're a big data enthusiast, then make sure to like this video and also share your opinion. And if you know any interesting case study of big data, mention it in the comment section. We will definitely pick it up in the next time. And if you're new to the channel, then make sure to subscribe as well. So now we will talk about this one, the another technical aspect, like 5 V's of big data. So whenever we talk about the big data, the raw definition is something like, if we have the huge volume of data which cannot be handled by the traditional databases, that is big data. But when we talk about the technical definition, there will be some important lines, there will be some important terminologies we need to throw in front of someone to describe the big data in actual. So here we will be talking about these 5 V's of big data, which is actually important and are like actually the backbone of big data definition. So the first is volume. This is the very first thing. Volume refers to the unimaginable amounts of information generated every second from social media, cell phones, car, credit cards, M2M sensors, images, videos, and whatnot, right? So if we talk about the first V, which is volume, definition is quite straightforward. That means the amount of the data. And every day, as I already said, like whatever activities we are doing, irrespective of the platform, that is the data, that is some entity which is being captured, and that will actually add on to the massive scale of the data. So here these examples, right? Social media, we used to use the Facebook, Instagram, WhatsApp, everything, that is data. Cell phones, whatever we are calling, whatever messages we are sending, images. And same as the cars, right? Automated cars and the car sensors, credit cards, transaction we are doing, images, videos, everything is data. Facebook alone can generate about billion messages. Wow. 4.5 billion times that the like button is recorded, and over 350 million new posts are uploaded each day. Can you just imagine this number? One day, 350 million posts, and just multiply it, let's say 365, 366, and you can imagine that scale of data. That's very, very big. So such a huge amount of data can only be handled by the big data technologies, big data frameworks, and big data ecosystem. Next point is the variety. As discussed before, like when I was talking about the definition of big data, there was one point like unstructured. So big data is generated in multiple varieties, right? Compared to the traditional data like phone numbers and addresses, the latest trend of data is in the form of photos, videos, and audios, and many more, making about 80% of the data to be completely unstructured. Structured data is just the tip of the like iceberg, you can say. I mean, if we know about the icebergs, right, there a huge section will like under the sea, which we cannot see. Structured will be just a tip over and above the sea, which you can see from the some distance, that point. So variety, what actually means here, data can be in any different form, right? It cannot always be in a human readable form. Like if you are taking some notes, right, that is also a text, you can read it definitely. If you are just looking at the row column kind of database, that is also a data, you can just read it. But sometimes there can be a data which you can actually see, you can understand, right? But obviously for these machineries, for the computers, and that will be in different form, right? And even that is actually true for other data, the structured data as well, but I'm talking about the from human perspective as well, right? From the human perspective, the text, the row columnar kind of data will be readable. But if we talk about an image, if we talk about an video, so although we can see it, we can listen the video audio, but if we just try to open it, probably we cannot see what is actually written, right, in the behind or under the hood, what is written. So that is not in the human readable form. That's why it is unstructured, where there is no dedicated or complete structure of a data. Because if you talk about like row columnar kind of data, so it's a very clean, concise, you can just see whatever is written, pure structure, right? Some schema, column names, but there won't be any structure of the unstructured data. Now we will talk about the velocity. So velocity plays a major role compared to the others. Right, there is no point in investing so much to end up waiting for the data. So the major aspect of big data is to provide data on demand and at a faster pace. Here velocity means on the speed that data is getting generated. So the very best example is this social media, right? On social media, every second probably across the globe, like thousands of likes, millions of likes, and the comments and the post videos are uploaded. So that means that data is coming in a very, very fast way, right? Even if you wait for 10-20 seconds, that volume may become really, really big. So velocity actually means here on which speed data is coming into our system. So in coming section, there will be one point where we can talk about the batch processing and we can talk about the real-time processing. So there are two types of data processing as well. Batch means where we actually wait for some time, right? To at least collect some necessary amount of data. It shouldn't be in a very, very smaller format, but there is a decent amount of data which we can actually process. So if we are processing data in that manner, that is batch processing. But what is real-time processing? In real-time processing, as soon as we are getting the data, we are doing something. Okay, just take a very good example. Let's say you are watching a cricket match, right? As soon as the cricketer, let's say, played a ball for the boundary, it's a 4 or 6, your scorecard will be updated. How it is happening? It is happening in the real time. Just imagine a scenario like in the 10th over, that batsman, let's say, smashed 3-4 sixes, and in after like completion of 14th or 15th over, you are just getting that update, right? The update of 10th over. Okay, in 10th over, this guy smashed 4 sixes. So that is not the real time thing. Okay, so this is the example. And another important example, if you want to look at for the real time processing, that is your bank transaction. As soon as you, let's say, withdraw some money from your ATM, right, you will instantly get the message on your mobile that that much amount has been deducted. So how it is happening? That is completely on the real time. As soon as event is happening, you are just capturing and you are doing some transaction and you are doing some kind of calculation. But if you are just collecting the data at till some threshold, that means it is going to be a batch processing. Next is the veracity. So veracity basically means the degree of reliability that the data has to offer. Since a major part of the data is unstructured and irrelevant, big data needs to find an alternate way to filter them or to translate them out, as the data is crucial in business development. So veracity here means in a very precise way, if you want to talk, if that use that data or not, right? If let's say there is a kind of data which cannot even be filtered out, we cannot do some sort of processing on top of it, or any kind of thing, or any business implication we cannot apply, that means the data is not worth enough, right? In order to use for the business decisions or the data driven decisions. So that's why veracity also plays a very, very important role. It is a one factor of the big data. Somehow at the end, it should deliver, it should give some information to us, right? And that's the veracity. Last point is the value. Fifth V, which is the value. Value is the major issue that we need to concentrate on. It is not just the amount of data that we store or process. It is actually the amount of valuable, reliable, and trustworthy data that needs to be stored, processed, analyzed to find the insights. So that also means if you are having the data, it shouldn't be like that whatever you are just getting, you are capturing and you are just keeping with yourself. At that moment you don't know how you're gonna utilize it, but you just kept it. But here also the main point is you should actually understand that what kind of data you are going to capture, and not only capturing that, how you gonna actually bring some meaningful insight of it, meaningful information out of it. That is the important thing. So that's why here, if your data is in such a way, and you have stored and processed the data in such a way that it is giving some value, that means this is a part of the big data, right? Again, if there is something which is not giving you any kind of meaningful insights, probably that shouldn't lie under the big data solution related thing. Like we didn't solve anything, right? In that way, like we had the data, only we cannot call the simple and plain data the big data. When we talk about the big data solution, that means the data plus solution. So if something with the help of data we are getting the information, meaningful information, that means that data is able to give some value to us. So that is the depiction. You can see here it is the pictorial form. Volume means huge amount of data. You can see that scale, growth of the data. Next is the variety, means different formats, data from various sources, right? Nowadays, if we talk about the sources, that was the social media, your cars, your banking transactions, and your image processing related things. Different sources can be there from where you can get the data, and even from the different sources the structure of data will be different. Now value, extract useful data, that is the one thing. Velocity was the high speed of accumulation of the data, on the rate, on the speed we are getting it. Veracity, basically inconsistencies and uncertainty in the data. So if your data is uncertain and inconsistent, definitely that cannot be used for the valuable information and valuable meaning, something you can say. So these were the 5 important V's of the big data. And when somebody asks you the definition and somebody asks you to explain something about the big data, you should actually talk about these points specifically, so that someone can understand it. Okay, what the big data exactly, and how we define it, and what are the different aspects of it. Now we will talk about the real life examples of big data. And real life examples means like in your practical activities or in your day-to-day life, where you can see the use of the big data. So in this slide we will talk about that one. So first is travel and tourism. That is actually true. Travel and tourism, it is one of the biggest users of big data technology. It has enabled us to predict the requirements for travel facilities in many places, improving businesses through dynamic pricing and many more. Dynamic pricing, I hope you guys can understand. So how it happens, right? That's how like these things actually add the values in the company revenue growth. I will just give very simple example of this dynamic pricing. And if somebody has also gone through it and have done some bookings and all, you guys definitely know what dynamic pricing is and how it is adding the benefits in the company's account and how they are doing it. I will talk about that. So let's say after 5 days you want to go somewhere, right? You want to plan your travel, that you will book a flight ticket and you will go somewhere and will stay there for a couple of days. So now it's a 5-day window only you have, and definitely desperately you will be trying your level best to book the tickets. So you will visit different travel website, right? For an example, let's say even like Flipkart, they are also allowing the Make My Trip and GoIbibo, Exigo. These are the companies which are actually related to the travel bookings and all. So when you will log in there, right, you will actually just plan your itinerary, you will put the date, and you will look at the different flights, chartings and all. And at the time even you are not sure enough that you are going to book this one, and you did that kind of activity 3-4 times on the platform. So at least based on your activities, right, that platform is capturing your data, what you are trying to do on their platform. You booked something, and the next step, when you will just log in on that platform, let's say earlier when in the beginning when you were booking your ticket, the rate was 4,000, but now you may see it like a 5,000. So how it happened? Just because of the dynamic pricing. Because as soon as like seats will start filling, they will also increase the fare, and even based on your activity and your desperation, they know like this guy is yes definitely desperate to book some tickets and all, and yeah, they will increase the fare, and that's how like they increase their revenues by that increased fare and all. So how did it happen? Based on your activities, based on your data. And same, let's say I will also take an example of the ride hailing services, right? When you book an Uber, or whenever let's say there is a bad weather and let's say you are stuck at your office, so at least you're in as soon as you book the like ride, and the driver will be allocated or the car will be allocated to you, they know you are at the office, right? You are really desperate to go at your home. So you will, every time you will see those increased fares, and even they definitely know what are the peak hours, right? Let's say if you are a working professional, you are living in a city, so when you will try to book the whenever you will try to book the cab or bike in the peak hour side, obviously there will be some shortage, and based on that automated and based on those automatic things, right? Based on the analysis and based on the prediction, right? Okay, that area there is a shortage of the bikes and the cars. Obviously, when you will try to book, you will see the increase in the fare. That's how the business, the entire ecosystem, the entire model is running. So travel and tourism, you can definitely, like, that was the one single example. You can find like n number of example definitely in the travel and tourism, where you can see these kind of things, and you can see the use of the data. Next is the financial and banking. This is, I would say, maybe this is the most important, and this is the domain which is heavily and very heavily dependent on the data side, right? Because wherever the money is involved, risk factor is very high, and in order to remove that risk, you need to take the quick actions, and in order to take that quick actions, you need the information. So that's why the banking and finance sector is something which I personally think is the most impacted sector by the data, and these companies are using it very heavily. The big data, they are too much into the big data analysis, the improving on algorithms, applying some complex logics in order to get that information quickly and avoiding those risk, frauds and everything. So this that's what even mentioned here, like this sector extensively uses big data technologies. Big data analytics can aid banks in understanding customer behavior based on the input received from their investment patterns. Like that's even happen if we talk about the some finance and banking related platforms. So whenever you provide some information, right, if you want some recommendation, let's say you want to do some investment, so you will provide some details that how much you are earning and what kind of amount you are keeping aside for your savings. So whenever you provide these kind of information, they will actually recommend you some best suggestion that what kind of investment you can do and what kind of different partners you can enroll with them, what kind of benefits they are giving. So this is the one aspect, and that is also mentioned here. So like shopping trends, motivation to invest, and personal or financial backgrounds. But if I specifically talk about the banking, the risk and fraud, I would say the major sector where you will see a very complex use of the data, because they have created those automated risk avoiding systems. So let's say you are sitting here and somebody tried to swipe your card, or duplicated your card and tried to swipe it at XYZ location. So actually they know your behavior, right? Let's say you are someone on monthly basis, you are someone who used to spend, let's say 20k 30k, and every time whatever transaction you have made, that was not big enough. So at least that, let's say, person tried to swipe your card, he made a transaction of 100k. So based on your previous studies, based on your previous transaction, based on your previous customer behavior, the system will actually try to sense it as a like risk factor, right? That somebody tried to swipe your card, and it's a very unusual pattern. Based on your activities of transaction, system will detect it, that is quite unusual, this is a risky, that somebody is trying to do something with this card. So probably you can get a call, you can get a message, and instantly your bank will probably check with you that whether you are someone who is making that transaction. So if not, definitely you can block your card. So that is actually happen in the real time, and that's why I said banking and finance sector is something where you can see a very extensive use of data. They are utilizing for some really cool use cases like risk and fraud. Next we will look at this one, healthcare. This is the important one. Even I talked about in the beginning. Big data has already started to create a huge difference in the healthcare sector. With the help of predictive analytics, medical professionals and healthcare personnel are now able to provide personalized healthcare services to individual patients. So how this is happening, that's why I said like the predictive analytics, how it is happening, because every human bodies, so you might be suffering from a different disease, and somebody else is suffering from a different disease. So based on these facts, right, okay, what is the age of this guy, what is the number of blood cells, let's say, and what is the amount of protein and everything, right? These the typical healthcare related things, they actually know this fact. If you are lying in this age group, probably these are the things you can suffer at this stage, these kind of possible medical diseases you can have, and if something happens, then what kind of medication you need to take care. And how it is happening, that is basically based on the personalized healthcare services, because they know, they based on the facts, based on the analytics, they know, okay, for this age group, for this kind of body structure, for this kind of and for this kind of let's say you can say body weight or any other aspect, and the any other factor you can include, that this kind of medication is required, and that's how we can start the treatment. That should be your diet chart, that should be your diet plan. So that's how the healthcare sector is improving, based on these facts, based on the thing, like we can see, right, the innovative machineries are there in the healthcare sector which are helping to detect these severe diseases. The ultrasound machine, let's say you have, or the scanning machine, the you can say another thing, you can say like the MRI and other things, right? So completely it is dependent the healthcare sector, which is heavily using the big data part. Next is the telecommunication and multimedia. So this sector is one of the primary users of the big data. Again, there are zettabytes of data which is getting generated every day, and to handle such huge data would need something which is related to big data technologies. So telecommunication and multimedia, again, your mobiles, whatever calling you are doing, that is also a kind of data which is happening over the data transmission, data packets. So that is one type of data. Again, it will be captured by these platform and these sectors, and like we are heavily dependent on it. And I can probably talk about one of the use cases where even I worked for the telecom sector. So the use case was something like there were two competitors in the market, right? So for example, you can treat, let's say, Vodafone and Airtel. Okay, so both are the telecom providers, so they have created their different services. So now let's say if they are not capturing the data, they don't know anything about their customer behaviors, how they can actually compete with their competitors. Because to compete with the competitors, definitely you need the data. You cannot actually do these kind of mistakes, right, where you are just completely avoiding your customer. Probably that will lead that telecom partner, and the thing which can happen is like that customer is shifting from Vodafone to Airtel, because we as a telecom provider didn't focus much on the customer behavior. And how we can focus if we are just taking the customer behavioral seriously, and just trying to work on that stream of data, whatever customer behavior is there, and what kind of expectation they have with us. And that's how they can avoid the churn, customer churn, and that's how they can even improve their services based on the feedback and based on the based on the data of the competitors as well, like how they are growing and what kind of services they are bringing in the market. So if that kind of competitive even analysis is not happening, probably they won't be able to survive in the market, right? Your competitor will actually eat your business completely. So if you just want to sustain in the market, you need to keep on improving your strategies. You need to keep on your services. You need to closely observe the customer behavior. You need to observe the customer activities, right? Let's say he's a dual sim mobile. If he's using Vodafone as well, and if use one sim is the Airtel, so which one he's using frequently? So those points can be actually good data points for any telecom partner to detect, okay, if Vodafone is something which that customer is using a lot, or Airtel is something which that user is using a lot, and based on that they can probably come up with some good offer for that user, or if not, they can just try to see why this is happening. So understanding and figuring out why is actually very, very important, and that can be done with the help of the big data analysis. Next, the government and military. I mean, this is also very important, like military part, and every country actually want to grow in this part, right? This is the very important, strengthening their army and their military power, and here even the innovation you can see, right? Very advanced kind of military equipments, the warships, helicopters, and even the missiles and everything. So innovation is going on there. So how that completely is dependent, that is completely dependent on the big data. So automated, let's say, the very good example is like the automated missile detecting systems, right? So how that is actually happen, I mean, we will be having the radar systems, which is actually transmitting the data, and in the airspace we can just detect, okay, if there is any unidentified object is entering into our space. So based on that analysis, data analysis, that can be predicted, and quick action like automated missiles can tackle it, right? So this is one example. And even the government part as well. Government is actually also very dependent on the data as well, right? If they actually want to improve the things related to the citizens, and nowadays, I mean, the very best in the exam in the time of the COVID, the very best example was the, like, in the time of the COVID, the very best example is the Arogya Setu app, right? So that application was actually built in order to just collect the data, right, of the different user, if you are actually, let's say, got vaccinated or not. If you they keep on looking at your data, right, your profile which you have created on that application. So you can even download your certificate, you can book your slot, a vaccination slot from there. So that data actually help as well for the government to just look at that, okay, on daily basis how many vaccinations are happening, and they can, based on that, with the help of that data, they can decide, okay, on which region and which sector we need more vaccinations, and we need to build more vaccination centers. So that kind of data actually helps every time. Data is not useless at all. Wherever, if you are a business, if you are a country, if you are a government, if you are a company, you will definitely need the data in order to run your business, in order to do the growth. So these were some typical examples. These were some technical. These were some sectors. So these are not only one thing, and many other sectors like the your entertainment industry, and again the automobile, the transportation is there, the retail sectors, businesses are there, which are heavily dependent on the big data, and they definitely need it, right, in order to make any kind of important decision. This is something everybody will be looking for. All right, so now we will be talking about the different types of data. So different types of data means uh, in today's world, like in the world of internet, or you can say in the world of the big data, there are different categories of data as well, like where you can see, visualize data in different formats and these things. So this is basically a very higher level of category. Within that, like when you will deep dive into this big data related things, or you will try to code something, then you will find that there are some like specific job, there are some specific file formats as well, which have some different way of storing the data, compression and everything. But this is a basically higher level category, that what kind of data you can expect while working on the big data related things. So the first is the structured one. Structured, I mean, even its name suggests that it would be in the readable format, right? I mean, even being a human, like being a human being, you can actually look at the data, what kind of data it is, and it will be quite structured, well formatted. It will have a schema is imposed here. Schema means like if you have some data, categorized data, so there will be some column names so that you can figure out, okay, this column represent this kind of value or something. So as per the definition, like this type of data can be processed, sorted, analyzed, stored and retrieved in a fixed format, right? It will have a really fixed format. And the most popular is basically this row columnar format, right? Even if you have seen your like Excel sheets where you put some column names and then you create some rows of data. So this is the best example, right? Quite structured, well mannered column is there, schema imposed, and those column names and their data types will itself suggest that what kind of value this column is going to handle. So structured data can be easily accessed by computer with the help of search algorithms, and that's true. Like if you have gone through with basic algorithm, basic data structures related things, so best is the two-dimensional array, which is 2D matrix. So in 2D matrix, whenever you want to access any particular element, it's quite simple, right? Based on the memory locations, you can do it. And how you can retrieve that data, just specifying the row, like which row you gonna point, and after that specifying which column you gonna point, and you will get that value. So similar thing happens with the structured data is itself. If you have a 2D kind of data, like having the row and columns, you can easily get it, access it, and very easy to use. No complex things, right? That you need to write very complex piece of code in order to access the tabular related data or structured data. That's why it's very easy to use. And the best example I talked about your data in the Excel sheet, or if you have looked at the database tables, right, which will be in the column, there will be columns and some rows. So that was about the structured data. Next, we have the unstructured data. So unstructured data, like obviously it won't have any sort of structure. I mean, even it's hard for the human being to read that data and to just understand what is actually written. So this is actually something which can be accessed in a programmatic way. Like your programs and your machine will only be able to just decode and understand it in the binary formats, that what is this data actually. So unlike structured data, like unstructured data is not present in any particular format. That's true. This data is a combination of various different types of data, like text files, images, videos, etc. And it is like usually heavier in size, and that is true. Like the best example is social media. The content we are getting in the social media or from the social media, that somehow holds the unstructured data. And the best example is the audio file, the video files. Because like being a human being, we can like look at, okay, this is a video playing on, and we can hear the audio. But obviously this is not very straightforward because machines used to treat this thing in a different way. Obviously there will be complex programming which is decoding these things, and we are able to hear it in the voice format, or we are able to see it in the video format. But that's not our like plain text, right? If you have a video file, even let's say I will just give you this exercise. Let's say just download any .mp4 file and just right click on it in your computer, and there will be a open with option. You can actually try to open with any text editor, right? Let's say Sublime Text or Notepad. So whenever you will open it, you will see some jargons, right? You will any random character, you won't even able to understand it. So that's why the unstructured data don't have any kind of fixed schema, don't fixed format. So you cannot definitely read it. That can only be understood by the machine itself. So this is about the unstructured data. And best example is whatever we are getting from social media, like the video file, audio files, and other images related things. Next, we'll talk about the semi-structured data. So semi-structured data contains both like structured as well as unstructured information. That is like it may not be present in a particular format, but may have segments that are formatted properly or vice versa. So semi-structured, you can just think like a hybrid model, right? I mean, there will be some sort of structure, some decent structure that is actually understandable by a human being, and like I can understand it what is written there, but it will be flexible, right? It won't have any fixed structure that every time we will be receiving that data, this will be the only structure it should follow. No, it is not going to like that. It is semi-structured because it is flexible. Every time, like if you are trying to impose anything, it is a very flexible structure. You can just apply anything. That's why like it is a mix of structured plus unstructured, you can say. That's why here in the example you can see, right, this is actually XML format. If you haven't looked at the what is different file formats, so XML and JSON format are really popular in and mostly in the web applications. They used to like these formats are being used to just transfer the data from point A to point B. So you can have a look at it. If you have worked on these kind of formats like JSON, XML, you can actually understand, right? If I take an example of very simple JSON, you can add any column, any key value pair at any specific point of time. So that's why like it is flexible. It is not very unstructured that you cannot even understand. But if we compare it with the structured data, in the structure it was fixed, like okay, only 6 columns will be there and this column will hold this sort of value, something. But that doesn't happen with the semi-structured kind of data. So it is understandable. We can understand it, we can look at it as well, and yeah, like very widely used mostly in these kind of web applications. Now we will look at different types of file format. This is very interesting and a very basic fundamental of the big data, right? Whenever I used to suggest someone that what all things you need to study in the big data to begin with and to understand all the terminologies, then these are some really important topics, right? So I'll give you a very simple example, right? Let's say you just want to start with a new field, or let's say even you are working in a company. So folks will be talking about in technical terminologies, right? They won't be just talking any vague word or anything which is not technically used in the industry, right? So if you actually want to work on such kind of projects where you can understand these things precisely, so you should be aware with all these terminologies. And why these file formats are very important, because when you will be working on big data related things, or let's say working on an ETL pipeline, so most of the time these kind of file formats will come into the picture. Each file format has its own pros and cons, and based on the different use cases, like we use these file formats, some has advantage on the compression, some has the advantages on the storage part and everything, right? So just understand this one, just understand this one, at least this part, the file formats, very precisely, because this is very important. So first and very common and very widely used file format, that is CSV, like comma separated values. So this file format is very simple, right? Very simple. I mean to say very easy to use, and it will look like a plain text, right? Even if you will open any CSV file, you will see a plain text written in it in the English alphabets or any other thing. So why this file format is very common? Because again, it is mostly used for the structured related things. Whenever you are building pipelines where you are actually working on structured data, it has a fixed structure or something, then this is a very widely used file format. So CSV comma separate comma means a kind of delimiter which is separating these fields and separating these values. But CSV means that file can also be named as TSV. TSV means tab separated. Okay. So we can use different delimiters. We can use, let's say, cap as well. We can use pipe as well as a delimiter. But these things will, as a common name, they will be treated as a CSV file, because there is some delimiter imposed in order to separate those column values with each other. And these things we can handle in a program itself, even if let's say it is a pipe delimiter or it is a tab delimiter. We can code our things in such a way that like we can pass those values, right? If we are reading a CSV file, we can just provide, okay, this is the delimiter which should be used, and that's how we can categorize our data. So CSV files are most commonly encountered in spreadsheets and databases, like very common example where you can see the CSV files. You can use a CSV file to move data between programs that aren't ordinarily able to exchange the data. So that is true. Wherever like we just want to work on the structured related data, and there is no need to transfer the data, let's say from point A to point B. There, I mean, if it's pure analytical related things, this is the best way. I would say this is the best thing if we have a structured data, and that's how. So if I talk about the pros part, so advantages or pros, you can see like very plain file, easy to use, simple to use. Cons are like they actually take a lot of space, because when you store the things, right, in the, let's say, when we store the things in the serialized way, serialized means in the binary formats, it takes less space. But when we actually store the things in the plain text or plain data types, then it usually takes more space. So that's why in terms of space, they will take a lot of space. And even the compression part is not that good. Compression means obviously like if you can compress your file in order to reduce the size, this is not the good format. But mostly like companies are working with this file format because they have structured data, and nowadays memory is something which is really cheap, right? I mean, in terms of storage, nobody's a lot of concerned about it. We have lots of services, we have lots of commodity hardware, so that we can, at least in terms of memory, we can scale our system at any particular point of time. Now JSON format, this is also a very important format. I mean, again, if you are someone who have worked on the web applications, or so definitely you must have used this file format. So JSON stands for JavaScript Object Notation. It is a text format for storing and transporting the data, right? Transporting the data, I mean, even you can get the complete of a huge amount of data in terms of the JSON itself. And even if you are working in a web application, so there will be APIs interacting with each other. There will be a lot of API calls where you will be passing some parameters or some payloads. So this is the best format like which is being used by the application to just transport the data from one endpoint to another endpoint. So JSON is self-describing and easy to understand. That's what I said. Because when we were talking about the structured data, it was like fixed column names, schema. And here in the JSON, it is also self-describing. It is kind of structured where you can see key values. So key will be actually your column name, you can say, or the field name, and the actual the value which is written in front of it, the actual value for this object. So in the structure format, we were looking like row by row things. So in the structure format, that row was one complete object or one complete structure, you can say. So similarly, when we talk about the JSON format, so one row of that structured data, you can compare it with the one complete JSON object, right? So that's why it is self-describing. Every key value pair, you can even actually understand what is written, what is the meaning of it. Now I will move on to the next one, Avro file format. So the next, these 2-3 file formats I'll be talking about, these are the most important and very, again, widely used when we actually work about the optimized and scalable data pipelines, because there we used to prefer to have our data in such format, because we can optimize the things on the space and storage size, because these file formats provides really good compression, and their way of storing the data also helps like those ETL pipelines to optimize their runtime. So first I'll talk about the Avro. So Avro is a row based storage format for Hadoop. We will talk about Hadoop and this framework and its complete architecture in upcoming slides, so don't worry about that. So just for the sake of simplicity, understand Hadoop is basically distributed computation engine, because this is the big data related things, and in order to compute this, in order to do this kind of heavy computation, we need a large amount of cluster, and we need a framework which can actually process our things in the distributed way or in a parallel processing way, so which is widely used as a serialization platform. So Avro stores the schema in JSON format, making it easy to read and interpret by any program. That's why I told you the previous file formats we talked about, JSON and the CSV. Even if you open these files, you can just understand the data, you can look at it. But when you will be working with these files, right, Avro and others like Parquet, ORC, so they're also file format, they will be storing the data, but if you open it, you won't be able to understand even a single line, because like these files actually store the data in the serialized manner. It will be in the binary formats. Okay, so but they also follow some standard way to store the data, right, in different ways. Like if I can talk about the CSV file format, it was storing the data in the row and column format, right? Now here in the Avro, what happens, as mentioned here, it store the schema in JSON format, because let's say you have, again, it's not like that if you have a structured data you can only store it in a CSV. Even if you have a tabular kind of data, then even you can use this Avro file format, but it will store it in a different way, right? Not just typical CSV file. So what it will do, if it has the schema, that will be stored as a JSON format within that entire Avro file, making it easy to read and interpret by any program. So whenever the program will execute and will read this file, Avro file, because our data is in the Avro file, it know within that Avro file I need to look at one JSON object which is actually holding the schema, and within the Avro file the data will be stored in that format itself, right? So that it is consistently matching with the schema which is in the JSON. The data itself is stored in a binary format, making it compact and efficient. That's what I mentioned in the beginning. When we have the data, right, and if it is not stored as a plain text, then it will occupy less space, because it is in the binary and not a kind of plain text which usually takes more space. That's why it's very compact. And here you can see, right, I mean, I know these things will be a bit confusing for you. What is this block and these things? So just don't worry about it. Just understand this thing as a one important file format in order to use. That's no complex thing. It's just a optimized file format that is being used. But yeah, like understanding of blocks and these things I will definitely talk about these slides when we will study about the Hadoop framework. So row based storage, I mean, whatever data will be there, it will be stored in the row base. So I can just give you one hint about the row based storage, what happens. So in a row based storage, let's say you have 4 columns. First is the ID, second is the name, and third is the address, and fourth is the salary, right? So this one row, you can actually treat it like a 1D array, but which is storing the data in a heterogeneous format, right? So first memory location is occupying data for the ID, second memory location occupying the data for the name, third is for the address, and fourth is for the salary. So this entire row of the contiguous memory location is actually representing one row. Okay, so that, if I just take an example of simple transactional databases, the MySQL, so they used to store data in that fashion, right? One complete row or you can just say like one complete set of contiguous memory location will be stored and will be treated as a complete block. Okay, so here same thing will happen. The first part you can see, right, it will be attached, whatever is attached here, that is actually your data. That is actually the header, or you can say JSON kind of object which is holding the schema. And after these blocks, so you can see the blocks, right, what is within an entire block, what is going to be stored. So count of objects in a block, size of the serialized objects in block, serialized object compressed by specific codec, and 16 byte sync marker. So these, even one block, just it is not only storing the serialized data, it is also storing other information to make this Avro file format more convenient by the program in order to do some inbuilt optimizations. So this is the Avro file format. Now we'll talk about the Parquet file format. This is also very important and again widely used file format. So it is an open source file format available to any project in Hadoop ecosystem. Apache Parquet is designed for efficient as well as performant flat columnar storage. So Avro was actually the raw format. I mean, entire object like heterogeneous, those separated column values were getting treated as a one single block and were getting stored there. That's why it was a row based storage. Now here it is actually Parquet is basically a columnar kind of storage. So columnar means if I want you to visualize the CSV file format. So one column, let's say it is a name, so within that name column, or if let's say it's a salary column, so all the values written in front of the salary columns will represent one kind of value, that is salary, which will be some like integer or float value. So if I just want that, if I want to pick that entire column, right, and if I just put it somewhere, so that means it is a columnar base, right? Here I'm not picking row, here I'm picking complete column and just storing it as a one block. So that is the main reason we call the Parquet file format as a columnar storage, and that actually gives a good optimization while working on the when we work with these kind of file formats, because columnar storage always helps to optimize the heavy analytical queries. Because in analytical queries, what we used to do, we used to work with the columns, we used to work on the aggregation operations on some specific columns. So if they are actually stored in one single block, so it will be quite optimized, because our disk pointer won't be taking much time in order to just traverse all the rows and pointing to that column, then pick the value and aggregate it, right? So that seek time of the disk pointer can be reduced a lot, and that's how these file formats provides a really good optimization. And again, the data will be stored in the serialized way. So in terms of the compression, we used to get a good compression ratio in the Parquet file format, and it's columnar based, which provides a good runtime for the analytical queries as well. So here we can see, right, what all things will be stored if I talk about Parquet file format. So this will be first block related information, then it complete data block, right, within whatever, let's say there are 100 records, right, just 100 records stored in a Parquet file format. So record 1, which will be again data, this will be complete block for the data. Record 1 serialized record, then again record 2, which is serialized. Now at the end it will be a footer, again some metadata related to the data block. So that these things will be actually main things will be to understand by the program itself, because those libraries, they actually know how to read these file formats, and these things are actually coded there itself. Now we'll talk about the ORC file format. This is also one of the very widely used file format, and ORC actually stands for the optimized row columnar, right? So it's stored as a column. Here we can see, right, if efficient compression is stored as a column and compressed, which leads to a smaller disk reads. So it is like row columnar based, but the optimized way. So it has its own way of storing the data, which actually gives good compression, right? And fast reads ORC has a built-in indexing mechanism as well, so that indexing is basically nothing like, you can say, memory addresses or a kind of simple file of the memory locations where your actual records are stored. So that indexing always helps in order to just access the records in a very quick and efficient time. And also apart from that, it is storing other values like minimum, maximum, and other aggregated values, which actually helps again in the analytical queries proven in large scale deployments. So this is, I think, as far as I remember, file format. Like Facebook uses the ORC file format for 300 petabyte of data deployment. This is quite big. This is really, really big. So I'm not really sure, because I know Hive is a one kind of framework which was built by the Facebook itself. So Hive is more optimized when we work with the like ORC file format that is suggested and tested. That's why I'm saying, because these things are written on paper, has been tested a lot. Like if we are working on a Hive framework, so Hive is again nothing, just a kind of big data framework built on top of Hadoop. So in Hadoop we had to do lots of coding in order to do the distributed task, but Hive is just kind of wrapper written on top of the Hadoop, and basically to help the analyst who are comfortable with the SQL queries, because in Hive we use it like a pure SQL based things. Whatever logic we just want to use in order to manipulate the data, we write it in the form of SQL, and that's start getting executed. So that's how this is also one of the file format which is quite efficient, quite compact, good compression. So you can read some good articles and blogs where you can find the comparison between the Avro and Parquet and ORC. You can deep dive into it as well, like what kind of compression ratio and what other pros and cons are available for it. But just in order to move ahead, these things were important to discuss, like what kind of different file formats are available in the big data. So CSV, JSON, Avro is there, and Parquet is there, and ORC is there. Now we will be talking about ETL processing. This is again the important and the backbone of the entire big data ecosystem. ETL processing, at the end, whatever we want to do in the big data related things, that is the ETL related stuff. So we will try to understand about the ETL processing concepts, what it is, and what kind of things we use to do in a ETL processing. Okay, so first, ETL actually stands for the extract, transform, and load. Okay, so we will talk about these points one by one. What is extract, what is transform, and what is load. So extract, first we will look at the technical definition, and then I will also try to explain it with the very easy example or easy you can say theory. Few businesses rely on a single data type or a system. Most manage data from a variety of sources and use a number of data analysis tools to produce business intelligence. To make a complex data strategy like this work, the data must be able to travel freely between systems and apps. So here extraction actually means, obviously, let's say you are working as a company, so you will be having some systems, right? You will be having some sources where your let's say customer data or your transaction related data is getting stored. Okay, and nowadays not only databases, there are a lot of things where your data is getting stored. So database is just one single aspect of it, right? Your entity, you can say, one single aspect. And because in the market we have what you can say the distributed file systems as well, right? We have cloud based file format as well, which are quite scalable, fault tolerant, where we can store our data. And that's why here it is being said, right, the data can come from a variety of sources. Some of the companies will mostly rely on a one kind of source. Let's say they are getting the files from some servers, they are getting files from some databases. But if you are working on complex problems, then obviously based on my experience, I have seen in those kind of cases we might be bringing the data from different sources. So data from different sources here, I mean, again, it can be your database, it can be your file system, it can be even API, it can be something or a streaming platform which is continuously sending your data. And that's why extraction here at the end means how to get that data, right? How to bring that data from some point XYZ or some source, right? So that is extraction. Because if you want to build something, if you want to bring something meaningful from your data, you need to just collect it, right? First, the first step, the first phase would be to collect it. And when we talk about the data pipelining and ETL processing, so whenever you will write these kind of pipelines, your first phase or the first step would be to get that data. Because you can get it in any of the form, right? We will be talking about those forms as well in the coming slides, what kind of different ways or what kind of you can say different strategies that we use to process the data. One is the batch processing and another is the real-time processing. So in both of these strategies, there are different ways and there are different mechanisms to pull the data from the sources. So extraction, that is the actual meaning of extraction, like to get the data from source X so that we can bring it into our system. And after that, we will be doing the next phases, like the second phase will be the transformation and the third phase would be the load part. So before data can be moved to a new destination, like the last part, it must first be extracted from its source, like wherever it is residing, we need to extract it. And that obviously needs to be done with the help of the like programs, or even there are some frameworks which used to help us in order to just create those pipelines where we are bringing data from the sources. In the first step of the ETL process, structured and unstructured data is imported and consolidated into a single repository. So there is nothing complex to understand. It's just we extracted and now it is available for my program. So that program you can simply treat like a just a temporary repository for your data, because it actually know where it is not like that it is storing data. Your program is storing data, although it will be stored on the commodity hardwares. But just think that now since you have written the ETL program or data pipelining program, so your program knows from where to extract that data. And that's why we are saying that once we extracted it, that is present for a single or consolidated repository in order to do the next steps. Raw data can be extracted from a wide range of sources. That's what I said. It could be anything, database, simple server, file, any other file format, or any other file storage system, and APIs, whatever. From where you can just get some response in the data, you can just extract the data from there. Now I will talk about the next step. Next step is the transform. So transformation means now based on the first step, we got the raw data in our program actually now knows that what is my raw data. And next thing, since we are concerned about the insights, and those insights are not already present within the raw data. I mean, we need to apply some rules, we need to give some logic to our program so that it can apply it on the raw data. And based on the business rules, we will be getting the transformed data. So applying those business rules is the very simple definition of the transformation. Like if you are just doing some manipulation based on the business rules, or you are doing some steps which can help you to get the transformed data and to get the meaningful data, that is the transformation part. So during this phase of ETL process, rules and regulations can be applied that ensure data quality and accessibility. You can also apply rules to help your company meet reporting requirements. That's what I said. Let's say you got the very basic example I'm giving to you, that let's say your manager asks you or your company asks you that, hey, can you please build a report where we can actually look that every month how much amount or how much sales amount we have collected, right? Very simple use case, that if you have a complete data of your system till date, right, you can just get it, and it will be in the raw form, right? There will be record by record things. It is not aggregated data, because your business or your manager wants you to give him a report where the data is aggregated. Like he wants only 2 columns, let's say, or let's say 3 columns, this year and month January, let's say 2021, and January, how much sales we did. So simple 3 columns he needs, which is aggregated on the year wise and the monthly wise, and whatever sales we made during that month, I just need to sum it up. That's the simple use case. So from the raw sources and the databases, we are getting the raw data, which is the transaction by transaction, because there will be one date column. On this date, okay, this transaction was made. So you can extract year from it, you can extract month from it. So you are doing these steps, right? These transformation, you pick that date column, you just try to extract what is the year, what is the month. The next step you will be doing the group by, right? And the third step would be you are just based on that every group you are taking a sum of it, and once that is done, you will just store that data to somewhere else, right? So applying those business rules actually happens in the transformation phase, or we actually call it as a transformation. So along with that, there are also other things. We cannot always trust our data as well, right? Trusting your data means because we also know this quote, right? Garbage in, garbage out. So sometimes even from the source side, let's say there could be some garbage entities in the raw data as well, which is not meaningful for us, or it cannot add any value into our reporting. So our task should be to just filter out those things as well. Like we should only work on the meaningful data which can help us to generate those reports. And even sometimes we just want to standardize it as well, and other cleansing related things. So we will look at these things. So cleansing part, like inconsistencies and missing values in the data are resolved. So this is also one of the phase. If we know that from the source data there are some specific columns which are very important, so we need to actually be really careful about those columns. We cannot just entertain those records where the values are missing in those columns, right? That means something wrong with that data. So we need to handle it. We need to just do some pre-checks and that cleansing part where we can find the inconsistencies there, and if we think that shouldn't happen, so we can report it to the source team as well, that the data is quite inconsistent, and like we won't be able to move ahead with that for our final reporting and all. Next is the standardization, means formatting rule are applied to the data set. That's what I said. Whatever business rules we will apply it. Deduplication is also one of the important thing we used to do, like when we work with the transactional data or any data, right? We just want our reports to be very accurate, and again I said we cannot trust our incoming raw data. So redundant data is excluded or discarded. Let's say if we think that there are a couple of records which may repeated, like which are repetitive in the source, so we can actually just apply this deduplication option, and with deduplication transformation, which will, based on some keys, it will try to just extract or discard those records which are completely duplicated. Next is the verification, like unusable data is removed and anomalies are flagged. That will be like you will be able to do it if you understand the business use case very, very correctly, right? And you understand what all columns and things are going to help you in order to generate your reports, right? So unusable data is removed and anomalies are flagged. Next is the sorting. If we just want to work on data in some specific order, we can sort our data and other tasks, right? Any additional operation rules can be applied to improve data quality. So these things, like whatever manipulations you are doing, even a single, let's say you just want to derive one new column, that is a derivation. That means it will also come under the transformation part, right? So this is the thing, transformation. This is the actual thing happens in the transformation. Now I'll be talking about the load part. So load part, like the final step in the ETL processing is to load the newly transformed data into a new destination. because our source was different. It had a like different way. That's what I mean. It could be any MySQL again, or like S3 or any distributed file system or any simple server. But now once we have the transform data, then we would like to store it somewhere. Store it somewhere means it can be again anything. It can be our internal system. It can be an again a simple database where we have just stored the transform database, and in technical terms we call it as a downstream system. So upstream was our source and downstream is where we are just dumping our data, like the transform data. And from here the actual role of data analyst, business analyst, data scientist will come into the picture, because they will try to process this data, because this is meaningful for them. They will just try to build some report on top of it. It is transformed, it is aggregated, so their purpose is solved at this point. So in the load as well, there are two things which is quite popular in the ETL processing and the big data ecosystem again. So first is the full loading and second is the incremental loading. So I will actually talk about both of them because they are important to understand what is full load and what is the incremental load. So in an ETL full loading scenario, everything that comes from the transformation assembly line goes into new unique records in the data warehouse. Though there may be times this is useful for research purposes, full loading produces datasets that grow exponentially and can quickly become difficult to maintain. So in full loading, what happens? So let's say whatever you have got so far from this from the source, right? You know, every day you are getting full data. Okay, so full data means, again, how can I explain it to you? I'm just thinking for a simple example. Let's say your full load, it can be a simple example of your e-commerce data, let's say, right? It's e-commerce data again. I mean, let's say you have the sales data, everything historical. Every time every day what you want the complete data so far. You want the complete values of the sales made so far. So what you can do, every day you can pull the entire data, right? Let's say it is of 2 years or 3 years of data. You can get it. You can again apply the business rules, and because every day transactions are getting increased, like they are getting increased, and we are just getting it and we are just combining it together. And in the downstream system, whatever previously present, right? Let's say yesterday was some Monday and we did processing. We processed the raw data completely, applied those logics, and then made it available for the downstream system. We loaded it. So that was done. It was till previous day. Now it is Tuesday and we are processing our data again. We did the logic implementation again, and so we cannot just append that data into the downstream system because it will be replication. So what we will do, we will just clear the existing data or clear the existing transform data which is present in the downstream system, and whatever we have computed today, we will just load that one. And in other technical terms, we call it as a truncate and load as well. Full load is also known as the truncate and load. Truncate means whatever is present, just clean it up. Whatever we have processed today, just load it. So that is the full load meaning in the ETL processing. Now incremental loading, which is quite popular and actually is more recommended to do whenever we have a possibility to process our data in the incremental format. That is like really good. So I will take the same example. So let's say how we were doing it in the previous example, full loading, we were just getting the entire data, right? And here we also know that whatever transaction made previously, they cannot be changed, right? You cannot just go and add some value in the sales amount. It will be just like the aggregation will keep on increasing for the upcoming data or for upcoming days. So it would be better, rather than extracting the entire data every day, we will only extract the data for that specific day only, right? Let's say today is Monday. I will only get the data for the Monday, we will just try to process it, right, aggregate it, and will just append it again in the downstream system. So let's say in our downstream system, the data was available till Sunday, right? Whatever we did so far, it was available there, and whatever we have processed new, we just appended it there. So that is incremental. Whatever we are getting every day, we are processing it. Whatever we are getting every time or every next coming day, we are just working on that piece of data. So now here you can even imagine it can improve your ETL pipeline drastically, right? Because when you will be working on full load, you will be bringing the entire data. It can be in the terabytes, petabytes, and that means this is going to take a lot of time for processing, and that cannot be done, and that is not acceptable at all. So there could be some very vague cases, or there could be challenging cases where there is no scope of doing incremental. So obviously there we have to do the full load, but this is the best practice, or this is the best recommendation. Whenever we know about our source data and we see that is there any possibility to bring it in the incremental fashion, we will try to adopt this architecture and work accordingly, because we will have a very small amount of data to process. It will be very quick, very fast. Updates will be done, and it will be available for the downstream system in a very short time, and they can process it. So that is the important part of the ETL pipeline, entire thing, like ETL: extraction, transformation, and load. So why I'm emphasizing on the ETL part, because in the next coming slides there will be one more thing to discuss, which is ELT: extract, load, and transform. So I will be talking about that one as well, and will just try to give you some example so that you can differentiate what is ETL and what is ELT. But before moving on to that, I will just show you one good example that how the entire extract, transform, and load part is working here. So you can see, right, there could be different, as we talked, right, in the extraction phase, the source can be anything. Here you can see the data source is a database, it's a CRM application, it's a web-based event, right? So we can get the data from different things. Now here the transform part, right, staging area, raw data is converted into a fitting form for a data warehouse. So data warehouse can be anything, your downstream system, wherever, whatever you are using to maintain or to just collect everything in your data warehouse. That is the whole thing, right? That is your load part. But here this box is actually representing the transformation part. Like first we extracted, and now here in this part we are just applying our business rules, we are applying our things so that we can convert the data, like doing that deduplication, cleansing, cleaning, standardization, and again some aggregation, group by, lots of operations will be there. And once that transform data is processed by us, and we will load it into this data warehouse. That is again nothing, just a simple, it can be anything, database. Just treat like you are again loading it to a NoSQL database, because those are scalable, and we will be building some reports, and we will be analyzing it with the help of business intelligence tools. Means BI tools specifically for the creating those dashboards and these things. So this is about the ETL process, and I hope whatever we have discussed so far, it related to the ETL, be it the extract phase, the transform, and the load part, and other things. I hope it would have helped you to understand it. And the next thing I was talking about, right, we will be talking about the ELT as well, and that would be quite interesting to understand, because once I'll talk about the ELT, then I will talk about what is the difference, why they are different with each other, the ETL and the ELT. Alright, so in last topic we talked about the ETL processing. It was basically extract, transform, and load. And now we will be talking about the ELT, which is nothing but like extract, load, and transform. So first I'll just show you the diagram that how the normal process looks like in the ELT, and like why it is little bit different from the normal and traditional ETL processing. So here, if you can look at the diagram, steps are quite simple, right? The meaning is same. Whatever we were doing in the extraction, whatever we were doing in the load, whatever we were doing the transformation, everything is same. It's just way of execution and way of applying the things, and basically to solve different purpose. That's it. So here you can see these are the sources. Again, it could be anything, database, CRM application, web events, or anything. So extraction step will be there. And extraction means we have extracted the raw data. So in the ETL processing, what was happening next after the extraction? It was transformation. Like we will be applying some business rules on top of it. So here what we will be doing, we are not going to apply any business rule. Whatever we have extracted, that means it is actually outside our system. Outside means, just suppose this is the boundary and data is residing outside this boundary. So in ETL processing, first step is to bring that data from this boundary to this boundary, because this is our area and this is our system. So once the things are available in our system, then only we will be able to do some analytics on top of it, or like any kind of reporting, any kind of business intelligence. So bringing that data into the system, that raw data, here you can see, right, this load arrow, that means raw data, prepared data. It don't get confused that prepared data it is transformed or something. No, like it will be just raw data. And in the last step, what we will be doing, we will be applying our business logic and business needs, whatever you can say, right? Or just apply the logic and it will give you the business insights or meaningful output, anything. But now I will explain why it is a bit different from the ETL processing. So in ETL, what was happening? We have written a, let's say, program or application which is bringing raw data, right? And now what it is doing, it is just applying some business logic on top of it, like filtering, cleaning, cleansing, deduplication, everything. It has completely changed the shape of the raw data. So just think for a scenario, like now you are very limited. Okay. You brought something in your system, it was completely raw, and then you applied your own logic and transformed it. So next time, let's say there is another use case which comes in. So you need to write a different application which will do the same step again, like bring the raw data for that use case. Then you are applying the business logic. So in ETL processing, the common thing you can actually think of is the raw data, right? But at every time the dynamic thing is the transformation. You are applying the transformation. So why just to repeat that step again and again, like to bring the common point into the internal systems and then applying transformation and then loading the transform data into some downstream system. So here in the ELT processing, it is actually beneficial for the large number of and variety number of use cases where you actually know that this is the source data, or it would be this historical or raw data would be beneficial for lots of and multiple use cases. So you can just keep it in your data warehouse, whatever the services you are using, you can keep it there. And on that part, after the loading data into the data warehouses, you just need to apply your own logic, right? So common point is stable with you in the warehouse. On top of it, you are just applying the business logics and it is serving different use cases. So there won't be any extra step again to bring the same data into the application or into the warehouse again and again. So that is the whole purpose of having the ELT into the picture and in the big data ecosystem. And it's quite handy. It's really useful when we need to serve like so many large number of use cases with the same kind of data. So that's the good explanation for that ELT. Now we will jump on to another important terminology or the concept in the big data ecosystem. And this is not just only for the big data ecosystem, because scaling is something which has become a really important part of any kind of product somebody is building. Be it in just take an example of any customer facing application. If let's say you have created a food delivery application, you have created a streaming application like Hotstar, Netflix, and any kind of e-commerce platform like Amazon, Flipkart, Walmart, anything. So they have a really huge customer base. So customer base, you can even think of like every minute or every second there will be thousands and like lakhs or millions of transactions are going on. So, and like every single machine has its own capacity, right? When you actually write or create any application which is capable of handling the millions of user requests at a single time, then you can just imagine that is not going to be handled by one single machine, or or with the help of monolithic architecture. So monolithic means you have everything on a single machine, right? And uh, whenever you just need, you are increasing the capacity of the machine, or like just a single component, everything is running in a single component. So that is not is actually accepted when you are working on such kind of large scale applications or large scale systems. So scaling, that's why, has become a really important part. And here in big data, as we already know, we will be dealing with the terabyte, petabyte, exabyte of data. So in order to process it again, that cannot be done by one single machine. It will be a completely distributed environment. So we will be talking about those terminologies as well in the coming slides. But first, I'll just try to explain what is scaling. And mentioning and talking about these terminologies is really important, because then you will be able to connect the dots when we will be talking about the in-depth concepts of the distributed computation, storage, or anything. So we have actually two type of scaling, vertical and horizontal scaling. But before that, I think now you can understand what scaling means. It is just scale your system based on the load, or based on the user request, or based on the volume or anything, right? If that is increasing, means you like your system is also getting scaled, right? If earlier it was handling 10 million requests, so your system should be capable enough to handle the 50 million requests as well, and on a specific point of time. So that is actually scaling, like scale up, scale down, right? Whenever there is increase or whenever there is spike, you are scaling your system, like making it big. And whenever there is a less number of requests or interaction, you are also narrowing down your system, because everything will add some cost, right, in your system. If because you will be using some machines, you will be having some on-premises system, you will be having some cloud system, and for everything you need to pay. So if even if you are unnecessarily using a very big system just for handling, let's say 10,000 20,000 requests, that is obviously like that doesn't make any sense, and you will be losing extra money for that. So scale up, scale down, two important concepts. So here again, in if we talk about the scalability in the technical definition, so scalability describes a system elasticity, right? If you rubber band, if you have seen the rubber band, definitely like you just stretch it, it expands, and you just like release it, it will just change its shape. So while we often use it to refer to a system's ability to grow, it is not exclusive to this definition. We can scale down as well, right? Scale down, scale up, and scale out accordingly. Whatever is this situation, we can take the decision, and our system should be capable enough to do that because of the cost factor. If you are running a website, web service, or application, its success hinges on the amount of network traffic it receives. It is common to underestimate just how much traffic your system will incur, especially in the early stages. This could result in a crashed server and or a decline in your service quality. That happens because when, let's say, I'm building my system and I have designed my product. So in the early stage, obviously there won't be like enough traffic. Let's say only 100 user, 200, 1000, 2000, 5000. And a single machine, something like that, can like handle this much of traffic. But you never know, like any given point of time your product may go viral, and there will be huge number of requests and huge number of product purchasing, or anything can happen on your platform. So at that time, if you are just thinking, okay, how would I scale or anything, probably you will lose your customers and you will lose your quality, and it will it won't put any good impact on the customer satisfaction. That's why your system should be scalable. If it is crashing again and again, it is not giving good user experience, you won't be able to grow at all in the market. So thus scalability describes your system's ability to adapt to the change and demand. Good scalability protects you from future downtime and ensures the quality of your service. That's true, because let's say situation is there, you are now you have now started receiving huge amount of requests, and you just took a downtime of 4-5 hours and writing some script in the backend or adding more servers or anything. Obviously that is not going to work, and it will lead to the like down it will actually downgrade your product and the customer satisfaction part. So now we'll talk about the vertical scalability. So vertical scaling, aka scaling up, describes adding additional resources to a system so that it meets demand, right? So vertical scaling is very easy to understand, because let's say we have a machine, okay? So in a machine, you can even nowadays like add external disk, and you can even add external RAM part as well. So here in with the definition of vertical scaling, you can understand just adding additional resources in your existing machine actually means the vertical scaling, right? Just you are making its size big, that's it. That is the vertical scaling. Vertical scaling describes adding more power to your current machine. For instance, if your server requires more processing power, vertical scaling would mean upgrading the CPUs. You can also vertically scale the memory, storage, or network speed, right? So just adding extra resources in your existing and current machine is the vertical scaling. But also the catch is here, vertical scaling has some limitation, because even for existing machine, right, you cannot go beyond its capacity. You cannot even make your simple laptop to a supercomputer, right? Because it has some limitation, right? This much amount of, or this much at the max RAM you can add, this much max hard disk or external disk you can add. So that's why vertical scaling has its own challenges. You can only just scale your existing machine till its extended capacity, that's it. So just adding extra resource means the vertical scaling. Now we will talk about the horizontal scaling, because this is the backbone of the any distributed computation thing, and even any large scale application, because there this concept actually works. Horizontal scaling, right? Anytime, any point of time, you are just adding the same configured machine n number of times, and it is just serving your purpose. So horizontal scaling refers to adding additional nodes. So here nodes actually means the external machine, right? Just imagine now you are working with one single laptop, and there is any way that you just want to scale your system or scale your work. You can like bring more like 4-5 another laptops and connect it in a single environment or something like that, and just start working on the things. So that's how the horizontal scalability works, right? So horizontal scalability means adding additional commodity hardwares, adding additional machines. So here you can even see the technical definition. Like if you are hosting an application on a server and find that it no longer has the capacity or capability to handle traffic, adding a server may be your solution. So that's what I talked, because if you think first thing, probably based on the traffic and based on the demand, you will think for a vertical scaling that okay, let's say just increase the capacity of the current machine, and it may like handle the situation. But again, it has the like some maximum capacity limit or something, and once even that is not working out, you will think of to bring more servers or more like external machines, so that you can add it in the same network and same zone, so that the load is getting distributed, right? Because very very practical example, right? If you there was a bundle of pencils or bundle of woods, right? If you just want to break it together with the it's just only you. If you are trying to break it, it won't be possible. But if you just distribute 2 to 3 wood sticks to your friends or to your brothers, they just break it. So how was it possible? Because things were distributed and it was easy for them to break it. Okay, so that's the same concept here. It is quite similar to delegating workload among several employees instead of one. This is also one of the practical example when you work on a project, when you work as a team. So there will be multiple tasks, right? Because obviously a single person cannot do n number of tasks, right? Obviously it has some capacity and bandwidth. So same thing, like we can distribute the task to different employees and they can do it accordingly. However, the downside of this may be the added complexity of your operation. You must decide which machine does what and how your new machine works with your old machines. Yeah, these are the operational challenges, right? Because when there is an existing system and you add something new, so there will be a load transfer, there will be configuration changes, you need to also check the compatibility with the existing system network. So those challenges will be there, but that will again be a one-time effort, and after that things can go really smooth, because workload management is very much important, and like these operations related tasks can be done very easily, nothing complex on that. So I hope now you can understand what is the meaning of horizontal scaling. Just adding more machines in your network, in your cluster, or in your like server network. That is the horizontal scalability. Now we will talk about what is the commodity hardware, because in the I talked about in the horizontal scaling, vertical scaling, like adding more machines and adding more commodity hardwares, or we were also talking about nodes. So I'll talk about that one. What is that? So commodity hardware is a low cost system identified by less availability and low quality. The commodity hardware comprises RAM, as it performs a number of services that requires RAM for the execution. So again, very simple to understand. Just commodity hardware means a different or a brand new machine, laptop, computer, which has everything like computation power, RAM and the ROM part and the external disk, so that it can even work as an independent machine to compute the things. Because for the computation we need these things, RAM and the external disk and the CPU part. So that's how you can treat the commodity hardware. They are just nothing, single and very simple terms. They are separate machines which is having its own computation power. Now I will talk about what is cluster, because these things will come into the picture, like when I'll be talking about different things in the Hadoop architecture, or while explaining its hello world program related things. So these things will come into the picture. So let's try to understand what is cluster and what is the meaning of it, what is the technical meaning, how it works. So here we have the cluster definition. Computer cluster is a set of computers that work together so that they can be viewed as a single system. Okay, that's true. So again, just imagine a very large application, right? You are just using it, simply you are using it, and you don't even know what is happening in the behind, right? You don't know about the behind the scenes. You will think, oh, it's quite smooth, right? We have just one single machine and everything is happening very smoothly. And same happens with your normal laptops as well, right? We know it has a like RAM, ROM, CPU and external disk, everything, and at a time you can do lots of things. Like you can even open multiple tabs, you can open notepad, you can open some VLC media, you can watch movie together. Like these multitasking things are happening. So somehow even like if we talk about the computation part or handling these multitasking related things, so something happening in the behind, right, virtually, right, that segregation is happening. But as a user, what we are thinking, it's just one single machine which is doing everything. Okay, and although here if I take an example of the simple machine, computer, laptop, it will be one machine, but at least under the hood it has divided things in such a way that they are running on a single machine. So similarly, cluster means it is a set of computers, set of commodity hardwares, or set of nodes, machines, whatever you can say, that they are connected together but looks like a single machine. The components of a cluster are usually connected to each other through fast local area network. Just very simple example. If you just want to access everything, they are, let's say you have 4 or 5 laptops, if they are connected in a single LAN network, you can actually access, you can make a request and anything very easily. So similarly, just think it from a cluster, right? Very easy to understand. I don't think so it's quite complex to understand what is cluster. It's just you have some external commodity hardwares or machines which are connected, which are actually connected with the same LAN network, and you are just accessing it like a simple one single machine. So with each node running its own instance of an operating system, that's what I said, commodity hardware will have its own computation power and other things. In most circumstances, all of the nodes use the same hardware and the same operating system because of the compatibility, else it would be really hard to manage the things. Although in some setups different operating system can be used on each computer or different hardware, but even if you are doing it, we need to handle things in that way as well, and it will also add more complex operational things or the maintenance part. Clusters are usually deployed to improve performance and availability. We were talking about the scalability. So scalability means whenever we are just increasing these number of machines, right? So here in the cluster, like when we work on a large scale applications, that actually happens, right? We will be having the huge network or huge number of machines connected together, and they are working. And anytime, even if we think now the data is growing, or let's say the traffic is growing, and even let's say initially we created a cluster of 10 nodes or 10 machine only, and if we think now there we need more capacity, we need to add more something, we need to scale, the simple thing is what you need to do, just bring extra machine, add it to the network. That's it. Very simple, and like very quickly your system is up and running, and it is just scaling. It has scaled everything for you. So I will show you the so I will also show you the example of the cluster, how it actually looks like. Very simple. There will be some kind of machine as well, right, which will actually be an entry point for your system as well, right? There will be at least one dedicated machine, and with that dedicated machine there will be other machines as well which are connected together, right? Everything can be accessed in that fashion. So you can see here like root node or that one dedicated machine which is handling the traffic, and with this machine we have connected other you can say commodity hardwares or other commodity nodes, machines, laptops, whatever you want to call. So we will actually call them like a slave node. Slave node means because these nodes are actually helping our system to compute the things, right? At the end, they are also not doing some major management related things, because we have a dedicated machine for that. Because managing the things is not very like a very tedious task, or even let's say tedious in terms of the, let's say, handling a very large volume of data, because just accept a request and transfer it to somewhere, and the slave nodes will be the actual one who will be doing the computation related things on a large amount of data, and storing it and computing it and then delivering the results. So these will be the one who will do the computation part, and root node will be the someone who will actually accept the things, manage the things, manage the entire machine or the slave nodes connected to it, and then delivering the results. So that was about the cluster. I hope now it's very clear, simple. Just set of nodes or set of machines connected in a local network will be known as a cluster. Now we will talk about this part because we have talked about the cluster. Cluster means, again, you can treat it like a distributed environment, because you are having one machine which is acting like a master or acting like a root node, and then you have other machines which are added to it, and they are working together, right? They are working together in order to just compute the things and making sure everything is there. Now I will explain what is distributed storage. and after that we will also talk about the distributed computation. So yeah, this is important concepts as well to understand or to deep dive more into the big data ecosystem, because big data, whatever we are doing in the big data, it actually works on two concepts: the distributed computation, and another is the distributed storage. So think for a example, or think for a situation that you have a 5 petabyte of file, right? And as I said earlier, in vertical scaling you can only have some limited storage, right? You can only increase the machine's capacity till some valid point, or till its extended point, not beyond that. So in order to store that huge amount of data, obviously the challenge is it cannot be stored on a one single machine, right? And now we already know the concept of the cluster. So at least we know this thing, at least we know this thing, that we can actually create a cluster of multiple machines, and that will actually work like a single machine for us from the user perspective. But under the hood it will be a completely distributed system, right? Because there will be other machines which has their own storage power, storage capacity, computation power. So cumulative, we can use the entire storage system in order to store our 5 petabyte of data. Okay, so in distributed storage, this happens, right? When you make a request to the root node, or to in a cluster, basically when you make a request to store the data, right, in a distributed environment, so your entire file, which is of 5 petabyte, it will be divided into smaller chunks, right? Smaller pieces, right? It won't be a very big piece, let's say not even in the GBs or TBs. It would be very small, right? I will also talk about these things, that why smaller parts and what kind of advantages it can add, right? So when we will be talking more about the distributed computation and the Hadoop architecture, you will be able to understand it more, like how the or what is the meaning of dividing the entire file into smaller pieces. But here you can just think like your file has been divided into smaller pieces, and let's say you have 100 node of cluster. So 5 petabyte of size you have, and let's say it is divided based on the fixed size. Let's say you want to divide your file into a size of 512, like 512 MB size. So that's how it will be divided, and let's say 20-30 small parts has been created for the 5 petabyte of data or the file. And now those smaller parts will be distributed among these slave nodes or these storage nodes, right? So these like, just don't think that all the data is going to store on a one single machine or one single node, because we have already made the partitions, we have already made or we have already divided the entire data into smaller pieces, and those smaller pieces will be residing on to the different slave nodes. And why we are comfortable to do that? Because it is a cluster and everything is connected in a single network as well. So even whenever I want to see the complete data, I will just make a request to the root node that I just want to see the complete data. Now it is the responsibility of a root node to figure out that okay, this 5 petabyte file was divided into like 20-30 pieces, and where it is stored, because these kind of management related things a root node used to do, like for a specific like huge amount of data or file, how many partitions were created and how many divisions we did and where they are stored. So just capturing all that metadata related things is actually done by the root node itself, right? That's how we call it master, because it is managing all the things. So now I think you can understand. Just think like this is one slave node, this is another, this is another, this is another, this is another, this one, right? So they will be these slave nodes. So let's say your input data 5 petabyte of file was divided into 30 pieces. So let's say 3-4 pieces will be stored here, 5-6 pieces will be stored here, 5-6 will be here, then again 2-3 partitions are here, or 5-6 partitions are here, and so on, right? So that's how it will be. Like even one single machine, you won't be able to find the complete data, because it is a cluster which looks like a single machine. So at any specific point of time, you can see that my entire data is stored in this machine, but under the hood it is actually divided. So if you just want to relate with a practical example, so just think about your money, right? Right, and you have, let's say, like multiple accounts in different banks, and let's say you have a 10 lakh rupees. So and you don't even just to optimize the risk, I'm just taking a very practical example. Let's say you think if I'm putting the entire money in one single account, so someday because of any fishy transaction or anything, somebody can steal all my money. So in that case, let's say you have in total 5 accounts in different banks, and since nowadays everything is connected with your like SSN ID or Aadhaar kind of thing, right? So at least you know, and even the government know that this guy has 5 open active accounts because it is related to your Aadhaar. So everything is managed with that help of your Aadhaar ID and everything. Okay, but just think, like those 5 accounts, treat your 5 accounts as a external commodity hardware, and now you have a 10 lakh rupees which you actually want to distribute, right? You don't want to keep it into one single machine. So let's say you just made 5 parts of it, and you can even divide it in an uneven manner as well. It's not necessary that okay, if I have 5 commodity hardwares, I'll just divide the size by the number of accounts I have. So just 10 lakh rupees, so you divide it into 2 lakhs, so 5 accounts means 2 lakhs. I'll put 2 lakhs in each account. So you did that, right? You just saved, or you are just putting your 2 lakhs in every bank account. So you can relate that thing with the same example here as well, right? The storage nodes. So your 10 lakh rupees is equivalent to the 5 petabyte of data, and here you are actually managing the things. If I'm talking about the money, okay, how and where I need to put the money, and in which account how much money. But here in the computation world, or the world of the computers, that will be handled by the machine itself, like the root machine. It will take the decision that okay, how many divisions I need to create, and where I need to store for the efficient access and for the efficient storage and everything. Those actions will be taken by the master as well, because it is very smart enough to take that decision. But here we are taking that decision. We divided the money, we are just putting it in different account, and since access is in our hand, at any specific point of time I can just get all my money back whenever I want. Just you need to visit your bank and just get that money. Like your 10 lakh is always in your hand, right? It's not like that if they are divided and they are stored in different bank accounts, so you have lost your money. No, that is not the case. It is your money which is just distributed, and you have the full access on those things. So distributed storage works like in that way. So now whenever we talk about large scale application, we also need to take the concept into the consideration, which is fault tolerance. Fault tolerance, what does it mean? Because these are machines, right? And you cannot think that if 24/7 like your machine is up and running. I mean, you cannot guarantee for anything. There can be some unforeseen circumstances that your machine got failed, your cluster got failed, anything, let's say, happened. Okay, because there may be chances of failures. We need to take it into the consideration. So things may fail as well, right? Your entire system or entire machine even may get crashed because of any random reason. Okay, so what will happen in that case? Okay, very common question, and important question as well, because here I will explain it, right? Let's say your 5 petabyte file was divided into 5-6 pieces, let's say sorry 20-30 pieces. So in each slave node we know let's say 3 partitions here, 4 partitions, 6 partitions, 8 partitions, 2 partitions, something like that are stored. Now because of any reason, let's say this machine got failed, right? The node 4 or 5, this machine got failed because of any random reason. So now what will happen? I mean, your data is completely lost. You cannot get it back like by any mean. So this is definitely a failure scenario, and if we are not handling it, that means we are losing our data, and we cannot compromise on that. Data is important for us because we need it. We need to do the computation, we need to do the analytics on top of it. So we cannot compromise on that part here. That point is completely understood, that if we have the data, it is stored in a distributed fashion. There could be a failure scenario that our machine is crashed and we are losing our data. So what could be the better solution for it? And the solution will be actually treated as a technical definition of a fault tolerance. Means if you are making any system, or if you are working on a logic, or you have designed anything, any thought which is preventing our system from the failures, and even if let's say failure happened, then just we are not losing anything, right? We are actually, even let's say the system got failed, and we are able to start with the same point where we left and where the thing got failed, that means our system is completely fault tolerant. So how this can be achieved in a distributed storage? With the help of replication, right? Replicated fashion. This is important, right? This is important to understand, and don't worry about that. In the coming slides there will be more detailed diagram where I'll show where the different partitions are stored, so that you will be able to imagine it, how that replication is happening, right? So but here I will also try to explain. Let's say 5 petabyte file was divided in 30 pieces, and just assign some number to those pieces, right? So that you can try to imagine that, okay, what are the partitions created and where they are replicated. Okay, so just assign a number, like for partition 1 just give the number 1, and for partition 2 give the number 2. Just index it in that manner. So let's say our first storage node, this is our slave node 1, which is storing 3 partitions: partition 1, partition 2, and partition 3. Okay, and so on. We can think about other partitions are stored in such manner in the remaining slave nodes. And now at any specific point of time, this node got failed. That means we are now going to lose our data. So in a distributed engine, whenever next we'll talk about the distributed computation part. So obviously we will be having some frameworks which actually provides these things. So the logic will be, whatever we have stored here, we stored 3 partitions here, 1, 2, and 3. So we will also create replicas of it, means same copy, and we want to store that copy in same machine. We will store that copy in different machine. So original parts or original partitions 1, 2, 3 will be stored here, and its replicated part, like same exact copy of partition 1, partition 2, and partition 3 will be stored in different nodes. Let's suppose this node and this node and this node. Okay, so it's, and everything your master actually know everything, your these kind of metadata related things, your master know it exactly. So even in the case of failure, if this machine crashes, right, so that means like our system won't be able to access it. Whatever was stored here, it won't be accessible, but we are safe because we have replicated our data. Partition 1 will be here again, like its copy is here, its copy is here, its copy is here. So even if this machine gets crashed, our master know how can I get back that data, and that is the beauty of replication, and that's why it is very important. And the concept of replication actually made things very simple, and made things very easy for the like fault tolerant systems, and a very important concepts to understand. Just one small challenge is not only one, there will be two challenges, or people treat it like a disadvantage. So let's say replication, I mean, what you can do, you can only create one copy, right? Let's say I had one partition, okay, and partition 1, partition 2, partition 3. I will just create one more copy of it and will store it in different other slave nodes for the fault tolerance, right? But you are even more concerned that no, there could be a blunder, a situation as well, that entire zone or entire data center is crashed or something like that. So in that case, what you will try to do, you will not only have one copy, you will try to have at least 2-3 copy, which are somehow stored in different nodes in a random way, so that at a specific point of time, if something happens to an entire data center or entire zone, still you are safe, you can get back your data. So that is actually replication factor. You can configure these things anytime in your framework if you want one replication factor, 2 and 3. So replication factor 2 means 2 copies will be created for every partition and will be stored in a different and random data nodes, or the storage nodes, or you can say the slave nodes as well. So that's how the replication part works. And again, I would say this is a very important concept. And the second disadvantage I can talk about is obviously the first disadvantage, because here, if we are increasing the number of replication factor, that means it is adding the extra storage cost. Okay, extra storage cost, because if you original your file was 5 petabyte and now you have decided that along with the original copy I will have 3 replicas of it, so just multiply it 5 into 3, that means your entire volume which you are actually going to store in your distributed storage system will be 15 petabyte. Why? Because data is important. You cannot compromise with the failures, you cannot compromise with the data loss or anything. And nowadays, the way the technology has grown, memory commodity hardwares are very cheap, right? So that's why companies and enterprises can invest on the storage part. They can bring new machines because those commodity hardwares are very cheap, but data and information is really important, right? So in order to make that kind of fault tolerant and amazing systems, we need these replication factor as well. So just to finish it off with the distributed storage, it is usually especially used to refer to either a distributed database where users store information of a number of nodes, or a computer network in which users store information on a number of peer network nodes. So that's what about the distributed storage. I mean, I have actually explained it in a very in-depth manner, just to make you understand what actually distributed storage, what is the meaning of fault tolerance, nodes, replication, why we do it, and what is the advantage, disadvantage of it. And in order to add the one more disadvantage of the replication factor, it will be extra maintenance as well from the master node side as well. It will be extra overhead on it, that it needs to decide, okay, where I need to store this much of replications and other things into the system. But that's okay, that can be done. But fault tolerance is really important, and we cannot compromise on the data loss part. Now I'll be talking about the distributed computation. These two are again the backbone of the entire big data ecosystem, or whatever frameworks have been built so far. The distributed computation and the distributed storage. So distributed storage here, first we will look at the technical definitions, and then I will also try to explain it with the simpler words. So distributed computation, like distributed systems, are a group of networked computers which share common goal for their work. So just that cluster we talked earlier, that you can treat it as a distributed computation environment, and along with that just like distributed computation plus distributed storage, because you have a cluster, you have external commodity hardwares which are attached together. It is giving you a feel of distributed environment, and those machines even will be used for the computation as well as the storage. So that's why when we talk about the cluster, we we will actually name it like a environment which is able for the distributed computation plus distributed storage. So the term parallel computing and distributed computing have much overlap because we have these two concepts in the real world. We have heard about the parallel computing as well. We have heard about the distributed computing. So we will look at both of the definitions, and we will also try to understand the difference between these two. So the same system may be characterized both as a parallel and distributed. The processors in a typical distributed systems run concurrently in parallel. Nevertheless, it is possible to roughly classify concurrent system as parallel or distributed using the following criteria, which we are going to look now. So in parallel computing, what happens? All the processors may have access to a shared memory to exchange information between processors. So processors, again, here we had the computation, like we had the commodity hardwares, right? And obviously they will have the computation power like CPU and all. So when we do the computation, definitely we will be working on some data, we will be working on some information, right? And there could be a scenario that or just a very common example is like multiprocessing thing, right? Multiprocessing means you are running multi processes, right? Multiple processes, and they are actually working on same piece of data or same piece of information, something. So the concept here is like, if multiple processors are actually working in a fashion that they are accessing the shared memory, right? Just a dedicated place or dedicated memory where all your processors are pointing and just exchanging the information, getting the information, computing with the help of the shared memory. That means it is the parallel computing, right? Multiple processor, shared memory, and if computation is happening in such fashion, that means it is the parallel computing. Now if I talk about the distributed computation, so each processor has its own private memory, distributed memory, which is the concept I'm going to talk like, and in this manner actual computation happens for the big data related things, right? So in the big data related things, it won't be a parallel computing, it would be a distributed computing, because every machine will actually compute its own thing, whatever is stored in its local memory, right? It will try to compute that, and it will produce the result there, and then it will transfer it to the master node for the like, or other nodes where the actual aggregation or other things will happen. Information is exchanged by passing messages between the processor. So even there is a need, let's say we need some information from another data set or another data partition, so that will happen over the network itself. There won't be any concept of the shared memory, and that's how the distributed computation work. The individual machine will have its own storage power, computation power, and it will do the computation related things for its own assigned things. That's the whole concept behind the distributed computation. And I will also explain it with the help of this diagram as well. It will be more clear to you. So this diagram actually depicts the concept of the parallel computing, because here this pink bar, right, which is actually pointing to the memory, and these are the processors, right? And here you can see these processors are actually pointing to the shared memory, and that's how the parallel computing is happening. And now if I talk about the cluster or the distributed environment, so you can see, right, just these boxes are individual machines or those commodity hardwares I was talking about. So that machine will have its own processor and will have its own memory, it will have its own computation power, and they are actually connected with a local network, this machine, this machine, this machine, and this machine, and that's how the entire you can say distributed computation is happening. So that is the whole concept behind the parallel computing and the distributed computing. So please don't get confused because in the big data world, we are not relying on the parallel computing. We are actually much more relying on the distributed computation. Parallel computings may parallel computation may come into the picture, but not often, probably in different scenarios. But we will be focusing on this one because frameworks are built in such a fashion that they are doing the distributed computation. All right, so now we will be talking about the problems with the traditional approach of data processing, because we have jumped into the distributed computation, distributed storage. So before distributed computation, what was in the picture, which was like the traditional way of data processing, and what was the major challenge with that? So we'll be talking about that one. So the first challenge is basically storing the amount of data, like storing the huge amount of data. That was the biggest challenge, because in like 15-20 years back, I mean, there were no the advancement in technology so that memory storage can be made cheaper. So that was the bottleneck. And I mean, if you have seen some pictures on Google, right, in earlier days, like even 20-30 days back, so when the things were like, when we had to store even 20-50 MBs of data, it was quite big disk kind of thing. But nowadays, technologies has quite changed, and it is even like just small chip which can even store very big amount of data. So that's the path we have covered so far, and that's why the memory storage is quite cheap nowadays. And this thing is so this thing is quite resolved. Storing this huge data in traditional system is not possible, definitely. The reason is obvious: the storage will be limited only to one system, and the data is increasing at a tremendous rate. So memory storage is one thing, and when we add this part with the horizontal scaling, like you can actually scale your system, and even you can increase your storage power of scalable system till any point, right? But if you are dependent on one single machine, that is very, very hard, as I already mentioned in the previous slides when I was talking about the vertical scaling, because every machine has its own capacity and limitation, and we cannot go beyond that. So second problem is storing heterogeneous data. So this is also one of the challenges. Like now we know storing is a problem, but like just a part of the problem, the like storing huge amount of data, since we discussed that the data is not only huge, but it is present in various format as well, like unstructured, semi-structured, and structured. So you need to make sure that you have a system to store all these varieties of data generated from various sources. So that's what I mean. If we are previously here in this first problem, we were talking about only the storage problem, like just okay, we have, let's say, only plain text files or something. We were only concerned about that, and it had a, let's say, kind of format which was able to, which like we were able to store, and it was doable. But nowadays, as we are in the world of internet, where we have different sources of getting data, the media files I was talking about, videos, audio files, then structured data, semi-structured data. So we also had to come up with the kind of technologies which can actually store these kind of heterogeneous data. And not just only storing, also fast access also matters a lot here. Like accessing means your data will be stored in terms of the zeros and ones in somewhere in the memory location. So how to retrieve it in a fast way, so that there is no lag or there is no very huge latency. So these were the challenges, and nowadays with the help of growing technology, these kind of challenges has also been removed. The third problem is accessing and processing speed. This is also one of the challenges with the traditional approaches or traditional data processing way, because there was no major concept of horizontal scaling, and like things were quite dependent on just vertical scaling, right? Scaling the system till some point, and then just depending on that. So nowadays, let's say we are able to process the data of 1 terabyte or 1 petabyte. It will probably take couple of minutes, couple of hours. But if you want to imagine this situation 20 years back, it could have even take months, days, right, to just process that 1 terabyte or petabyte of data. So those were the challenges, and those were because of the lack of the, and or not lack, basically the ongoing process of the ongoing advancement of the technologies. So as soon as we face the challenges, obviously people started working on the different workarounds, and that's how the good projects or good open source and technical frameworks came into the picture in the world of big data. So in next coming sections, we will be focusing on those parts, and yeah, that would be our main agenda, and that would be our main focus point. So these were the challenges. I mean, very straightforward, nothing complex to understand. It was just a storage problem, and then storing heterogeneous kind of data, and then obviously the distributed computation were the challenges with the traditional data processing. Now this is the backbone of entire big data ecosystem, the Hadoop and its evolution. This was the you can say first concept or first official framework which was released for the distributed computation and storage. So now we'll shift our focus about understanding the Hadoop as an ecosystem, its architecture, its different components, their understanding. We will be deeping dive into it, and yeah, we will be also covering some demonstration part as well, like even at least writing the hello world application, so that you can get the feel of working with the map reduce code. So if you are enjoying this part and it is just generating more curiosity in yourself, so make sure to like this video and subscribe the channel. And let's move on to the technical definition of Hadoop. So it is a framework that allows you to first store big data. Like it is actually removing the challenges we talked about the traditional data processing. First challenge was storing the data. So this helps us to store the big data in distributed environment. In the previous slides, I talked about distributed storage, how that entire cluster look like, how the replication happens, and how your file will get distributed in smaller chunks, and that's how things will get processed. And a distributed environment so that you can process it parallelly, and that actually makes sense, right? If you have everything located at one place, then obviously you won't be able to get that parallelism, and you won't be able to process the entire data in parallel ways. You have to just focus. Somehow you need to bring that entire data, let's say 1 terabyte 1 petabyte, into your system, and then you will be able to process it. So Hadoop actually help in these things. It is working like a framework which helps to store big data in the distributed environment, and also helping the developers to process this data in the parallel mode. So now we will be looking at the evolution of Hadoop, like how it came into picture, what was the thought process. So this journey is also quite good. The evolution, it is very meaningful. So in actually 2003, Doug Cutting launches Project Nudge to handle billions of searches and indexing millions of web pages. So the problem statement he actually came up with, it was not related with the Hadoop or parallel computation. It was just he wanted to focus or wanted to try to solve a use case where search, right? I mean, we work on the Google search. As soon as we type something, there will be millions and billions of results in front of us, and it happens in fraction of seconds. So that kind of use case he was trying to work, like how to do or handle the billion of searches and indexing millions of web pages. So this number actually looks big, obviously, so the volume would also be quite big. So later in October 2003, Google releases a paper with GFS, Google File System. So just remember this word when I'll be talking about the Hadoop component, then you will able to relate it what GFS and what the component, one of the popular component of Hadoop relates with each other. So GFS means Google File System. So file system is just nothing, anything which has its own way of storing the file, you will just call its own file system. So let's say even in our machine or laptop, it's a normal or plain file system where you just copy everything and it just treated as a file. And in GFS, like Google File System, it will have its own way to store the data. It can be like whatever you are sending, whatever file you are trying to save, it is not storing in like its original manner. Probably it will just split it and divide it in multi parts, and then will throw it here and there over the cluster. So in 2004, Google releases papers with MapReduce as well. So 2003, so first part was to handle or to just work on the distributed file storage side. So for that one, GFS was there. Now 2004, since now like the in 2003, this problem was somehow solved, distributed storage. So next was how to do the parallel computation, because that's main reason was to distribute the file on different nodes of cluster, just to like we can get the parallelism, we can get some parallelism. So in 2004, Google releases papers with MapReduce. In 2005, Nutch used GFS and MapReduce to perform operation, right? So Nutch project, which was for the billions of searches and indexing millions of web pages. So with the help of these two research papers and methodologies, they build a system which was a kind of like obviously combination of GFS plus MapReduce, and tried to solve this problem. In 2006, Yahoo created Hadoop based on GFS and MapReduce. So actual origination of Hadoop started in 2006. With the help of this concept like GFS and MapReduce, this framework was built, which is named as Hadoop. With Duck Cutting and team, basically Duck Cutting, you can actually call him as a father of Hadoop. He and his team built the entire Hadoop system. You will be surprised if I would tell you that in 2007, Yahoo started using Hadoop on a 1000 node cluster. 2007, 1000 nodes of cluster. This is very, very big. I have actually worked for multiple companies, and their cluster size won't even cross 20 nodes, 25 nodes. That is just for the data processing for even very huge volume of data or something like that. So 1000 node cluster is, you just imagine this number, how big that cluster would be. And they did it in 2007. Later into January 2008, Yahoo released Hadoop as an open source project. Now it is under Apache Software Foundation, and they are maintaining it. In July 2008, Apache tested it for 4000 node cluster. This is insane, and this is a very crazy number with Hadoop. And in 2009, Hadoop successfully sorted a petabyte. The first, like with the Hadoop framework, they tried to solve the sorting of petabyte of data, right? So just try to think. Now I think this is the right time where you can relate with your practical learnings, that when you actually give any programming challenge, right, or any competitive programming challenge, and if there is a question which is related to array or very large number of integer, right, so there will be some constraint that your array size could be something like 10 to the power 6, 10 to the power 8, or anything. Why? Because that even that volume, like when you try to write a logic, okay, it's any good logic and very competitive logic, so it will improve your time. But if you are following a naive approach, you will be getting the time limit, because there is a obviously the naive solution you have opted, and it will take time, and even the data volume is quite big. So 10 in front of 1 petabyte of data, those numbers like 10 to the power 6 array elements is actually very small. So just imagine how big this data is. And Hadoop actually, with the help of Hadoop, this was the first use case they tried to solve. Like, let's test it, how fast and how well it can sort the petabyte of data, how it can sort it. So it actually took 17 hours to handle billion of searches and indexing millions of web pages with the help of Hadoop as well. Moving ahead, in December 2011, Apache Hadoop released its version 1.0, which was public, and after that enterprise and companies started using it. Later in 2013, version 2.0.6 was available, and it is improving a lot day by day. And after the Hadoop, there were a lot of very, very good frameworks which were built on top of it, and they under the hood they are using the same methodology, distributed computation and distributed storage. So now we'll be talking about the Hadoop architecture. What is the complete architecture of Hadoop, how it looks like, and its different components. We'll be talking about that one. So this is a very high level overview, just to so that you can understand the complete picture, right? You can understand the complete picture, how it looks like from a very higher level. And then in the next sections we'll be dive into the every component, and we'll be explaining about each and every part. So before actually jumping onto the master slave architecture of Hadoop or Hadoop architecture, just I would like to make you understand one thing. Like if you try to do a processing with simple machine, or let's say in your laptop, what happens, and when you try to do it on a cluster, then what happens? So there are two things actually. When, let's say, just try to think of a simple Python program. All right, you have written one Python program, and let's say in your Python program, what you are trying to do, you are trying to read a simple text file which is very small, let's say 2 KB, 3 KB, and some text written on it. So what will happen, as soon as you will go on your Python, as soon as you will go on or your terminal, you will execute your Python program. So behind the scenes, what happens, your Python program actually brings that data, because in your code you would have written those lines like read this text file from this location, and then execution will happen. So in this situation where we have a standalone machine and we are writing the things in a traditional way, we have a set of program which is running, and it is reading the data, it is bringing the data to itself, right? So this happens with the traditional approach or with the traditional mechanism. Like here in this situation, what happens, data comes to the code part, or actually you can say your code or actual programs reads the data. Reads the data means just call it to the inner execution part of the program, and then actually do the computation part. But when we talk about the distributed environment or the distributed computation, so based on the logic of data distribution, data smaller chunks of that huge volume of data is available on different nodes, right? If you remember the previous slides where I was talking about distributed storage, there were different slave nodes. There was one root node which was working as a master, and with that root node there were other slave nodes were connected, and we were calling them as a slave node, data node, worker node. There are different synonyms for it. So our data, like 1 petabyte of file, would have been divided into 20-30 smaller pieces, right? And those smaller pieces will be stored in different slave nodes, so that we can maintain the replication, we can maintain the fault tolerance, and we can also maintain the data distribution in well manner. So there what happens, our program will go to the master node first, the root node which was managing everything. So our program will go to it, and that master node or that root node actually send our program to different data nodes. So in the traditional approach, what was happening, we had a simple Python program which was just pulling the data into itself and trying to compute it. But in distributed environment, what is happening, our data is present on different data nodes, but we are sending our program to different data nodes, right? So every piece of program is same, right? And that will be available to all the slave nodes, because our smaller chunks of data are present on the different slave nodes. Okay, so every program, like, because we have just send it to different data nodes, so that will just try to compute the result locally, right? So let's say 30 in the beginning, 1 petabyte of data was divided in 30 pieces, and those were stored in different slave nodes. So same, the root node, what it will do, it will actually send the same code to all 30 partitions, right? And that piece of code or that piece of program will start executing that respective piece or that respective chunk of data, and whatever result will be there. So simultaneously all the 30 partitions will get computed by the same piece of program in local machine or in local slave node, and whatever will be the local output, they will send it to the root node, and or like on the root node part, entire aggregation will happen and we will get the final result. So this is the very high level understanding I just wanted to give you, that how traditional things actually works when we start doing the computation, and how the things happen on the distributed cluster, or basically in the Hadoop ecosystem. So now we will focus on the Hadoop architecture. So it has actually three layers or three main components. So first is the storage layer, because I talked about this one, right? Hadoop actually provides two main important things. First is the distributed storage, and second was the distributed computation. So storage layer, the name of the storage layer component, or we call it like HDFS. So like now you can relate it. GFS was Google File System, HDFS is Hadoop Distributed File System. And second layer is the resource management, basically, which is Hadoop Yarn. So this is nothing, because just think from that perspective, right? If you have 100 node of cluster, 1000 node of cluster, and every node is actually working like a commodity hardware which has its own CPU and memory, RAM, everything. Okay. So, but whenever we submit a particular job, right, particular program, it will be processing some specific amount of data, and in order to process that data, it will need some resource, and that resource is nothing, basically the how much memory this entire job will take, and how much CPU it actually requires, how many smaller, or how many processes or threads will be created for this one. So these kind of decisions, scheduling, and making sure the resource are available for this job execution, allocating those resources. So for that we have a resource manager in Hadoop as well. What it has a very simple, like looks simple, but very important task, that resource management. Just accept the job and try to figure out what kind of resource does it need, and allocate it properly. So this is second component, and third component is the map reduce part, right? The core libraries, or you can say core program methods basically, or the functions which help you to write the distributed computation program, right? Or distributed application. So three components. First is storage part, which is HDFS. Second is the resource manager, which is Yarn. Third is the map reduce part. So now let's first talk about the Hadoop features. What are its different features? And then we will be talking about the different components of it. So first is Hadoop is open source. It's an open source project, which means its source code is available free of cost. I mean, we don't need to pay any kind of license fee, or we don't need to pay any amount for it to use these frameworks. It's open source and managed by the Apache Software Foundation. We can just download it, and we can set up the things on our on-premises system, or even as well as the cloud systems, right? So it's free of cost, open source project which can be used. Second, Hadoop cluster is highly scalable. As I said, it supports the horizontal scalability. Today, let's say you are working with 5 node of cluster. If you are expecting huge amount of data or a huge spike in the volume, you can add more machines in your cluster, and you are done. Your system is scalable. Hadoop provides fault tolerance. That's what I talked about. Fault tolerance in terms of the storage. You won't be losing your data at all, because its distributed file storage system is quite durable. It supports the replication. That is the main fundamental, and that is the main fundamental of doing the replication. It gives you the fault tolerance. Apart from that, it also do the smart replication as well. I'll talk about that one in the coming sections. What that smart replication, so that if something even happens to let's say even one country's, the data center in one of the countries is completely down because of any natural disaster or something, still your data will be there for you. So how it is doing it, I'll be talking about that one as well. So Hadoop provides high availability. So high availability means whenever we are talking about the distributed system or system which are very very much needed for the customer, right? And if you have created a project which is used by millions of customers, so uh, you cannot tolerate this part. Your system is down for 5-10 minutes, you will be losing, I mean, millions of dollars, right? For the revenue or for the stock price or everything, right? If your system is down. So Hadoop actually provides the high availability as well. But now at least you should think from one perspective, because Hadoop has a kind of master slave architecture, because there will be one master root node which is managing all the slave nodes, and the computation will be happening on the slave nodes. So in high availability, what happens, Hadoop actually provides you different mechanism, different kind of mechanisms or different kind of strategies, so that you can set up your Hadoop cluster in such a way that it is highly available. Because if we just only talk about the traditional architecture of Hadoop, it is master slave, and master will be treated as a single point of failure, because if something happens to the master, your entire system will be the down, right? So there are other strategies and concepts as well, which helps the Hadoop, or which helps the organization to set up their Hadoop architecture in such a way that it is highly available. So next point is Hadoop is very cost effective. That's true. Like Hadoop cluster consists of node commodity hardwares like horizon 1000 node of cluster, 4000 of node of cluster. You will just only need to pay for the commodity hardwares, and nothing again for the license approval, license related, or any enterprise extra cost for it. So that's why Hadoop is quite cheap and cost effective in that term. Next is Hadoop is faster in data processing. Definitely for the batch data processing, batch part where we are actually trying to process data in batches, right? First we will try to collect some data for threshold basis. Let's say we will wait for data to be become like 1 GB, 1 TB, 1 petabyte, then we will start processing it. So for the batch processing kind of system, Hadoop is quite fast. But nowadays there are also other popular frameworks which helps or supports the batch processing. Along with that, it also supports the real-time data processing as well. This is one thing. Hadoop stores data in distributed fashion, which allows data to be processed distributely on cluster of nodes. Thus, it provides lightning fast processing capability to the Hadoop framework. Hadoop is based on data locality concepts, means it is popularly known for its data locality feature, means moving computation logic to the data. That's what I was talking about, moving computation logic to the data, not move data to the logic. So this is the technical definition of that part which I was explaining. That what happens in the distributed computation or a distributed environment, you actually send your logic or your program to the data, not bring the data to the logic. Hadoop provides feasibility. Like unlike traditional system, Hadoop can process unstructured data as well, which is the actual ask during that time, because we had a heterogeneous kind of data, structured, semi-structured, unstructured. So Hadoop is well sufficient to do that kind of data processing as well. Now we will be talking about different components of the Hadoop. So in a higher level overview, we first talk about the HDFS, right? Hadoop Distributed File System. So first, now we will be talking about this one. What is HDFS, and what are different and even its smaller components. We'll be talking about that one. So HDFS stands for the Hadoop Distributed File System. It provides for data storage of Hadoop. HDFS splits the data unit into smaller units called blocks here, and store them in distributed manner. It has got two daemons running, one for the master node, which is name node, and other for the slave nodes, that is data node. So here now the part is that is HDFS. So here I'll be explaining this part, that how HDFS is actually storing the data and what are these things are written. So as I said, it's a distributed environment, right? It's distributed file storage system. So whatever incoming data is there, or whatever incoming batch data we have, it will first divided into a smaller piece, right? And that is not random, actually. That is configurable, because when you will set up the Hadoop in your system, you can define that size, right? Let's say I have a 1 GB of file which actually becomes 1024 MB, and now I decide that my block size, basically here you can see, right, HDFS splits the data unit into smaller units called as block, right? So my 1 GB file will be divided into smaller pieces, right? Let's say if I decide that default block size in Hadoop should be 128 MB. So 1024 divided by 128, it would be something like 8, right? 8 parts will be there. So 8 parts means 1024 MB, like my 1 GB file got divided into 8 parts, and those 8 parts are nothing. We will call it as a 8 blocks. Okay. So even dividing means whatever data is there, that also got divided. Like let's say your 1 GB file was containing 1000 lines, right, as a input text. So 100 200 lines will be in one block, and another remaining 100 200s in another block, and so forth. So that's how that entire data will be divided. Okay. And those physical storage units, we will call it as a block, right? Because 1 GB file which is actually present in my laptop, and that will be stored on a physical memory, the actual disk part of the entire HDFS cluster. So this is the definition about the block and the understanding. Now when we talk about the entire Hadoop architecture and like entire Hadoop system, right, which is present, which is kind of master slave, there will be some background processes as well, right? It's not like that Hadoop is just a simple library, we imported it and we started coding it. It's a complete system, it's a complete cluster environment. So whenever we have these kind of systems, obviously there will be some background processes which should keep on running, because those are the actual logics and those are the actual things which are taking care of these parts, right? I mean, interacting with the data nodes and working closely with the resource manager, and just making sure that whatever job has been submitted on the Hadoop cluster, I need to divide it in such fashion. I need to send this piece of code to this data split or something. So that's how it will be decided, and that's how when we talk about the entire HDFS part, right? So it has actually two main components, name node and data node. So now, since we have moved into the technical part of the Hadoop, so earlier in the distributed architecture, or when we talked about initially about the Hadoop architecture, so we called the entire cluster as a master slave. So what happens now when we will talk about the Hadoop technically. So root node is known as the name node, right? And whatever commodity hardwares we have which will actually do the computation part, those will be known as the data node. So data node, why? Because they are the actual commodity hardwares which will be storing these different or smaller units of the data, which are known as blocks. So our blocks will get stored on those slave nodes, which is technically called as the data node. And name node, again, our master node, which will actually take care of the main part, like the metadata information. Because when we talk about the big cluster, we are not the only one who are working on it. There will be other teams as well. So they will be having their own data, their own files, and they are even, let's say, using the same cluster. So name node actually does this metadata related metadata related part, and just taking care everything is running fine on the cluster side, just taking care of all the data nodes as well, because these are physical machine. Sometimes they may also get fail, right? So name node should keep a track of each and everything, what all data nodes are working actively in the cluster and what all nodes are dead if there is any case, so that we can get notified and we can take the appropriate action to activate that data node again. And again, name node, the main part is like metadata handling part, which block is stored in which data node, so that whenever someone submits a job, right, so that that job or that logic can be sent to that appropriate piece of block which is stored on the data node. So here now we will be talking about this one. HDFS has a master slave architecture, the daemon called as name nodes run on the master server, and like this is a background process basically, and with the help of the background process we call even that master node as a name node. It is responsible for namespace management, which I was talking about, the metadata related things, and regulate files accessed by the client. Data node daemon runs on slave node. It is responsible for storing actual business data, right? Actual business data, like whatever data we had, those physical units and the blocks, those will actually get stored on the data node part. Internally, a file gets split into number of data blocks and stored on a group of slave machines, which we are actually the data node. So as soon as we'll get the file, it will divide it into the data blocks. So again, this parameter is configurable in the configuration file. When you will set up the Hadoop in your system, this is configurable. It can be 128 MB, it can be 64 MB. So in different versions of Hadoop, that block default block size was different. So as far as I remember, in Hadoop 1.0, they had a default size of 64 MB block. I mean, if you haven't configured it and you are storing the file on HDFS, then by default it will just try to divide your entire file size with the 64 MB, and it will create that number of blocks and will store it on the data nodes. And after or in basically Hadoop 2.0 or versions which are greater than 2.0, the default size is 128 MB. So that is also configurable. And probably after explaining about these components of HDFS, I will talk about one interesting question as well, which is kind of related to interview question as well, that how this block partitioning can impact the distributed computation, right? If I'm dividing my file by 64 MB and if I'm setting my block size of 120 MB, then what will be the impact on the entire computation and all. So I'll discuss that one. Here we have talked about the name node manages modifications to file system, like whatever is changing, if any block size got replicated somewhere else, and wherever things are getting stored and whatever is actually getting changed on the namespace side and the file structure part and the folder management side, everything will be taken care by the name node. So this data node serves read write request from the file systems client. Data node also creates, deletes and replicates block on demand from name node. So that's how it is done. The replication part I was talking about, and basically these data nodes, they do the main part, right? Accepting the data read request, and whenever we are writing something, right, the actual data will be written on the data node. So handling those read write request and working on it, that is actually done by the HDFS part and actually the data nodes. Now just look at this diagram, which actually makes more sense. Okay, so makes more sense how this diagram is quite easy to understand. Again, it's some you can say the master slave kind of architecture. So this is our name node, and here you can see these data nodes, and these small circles are nothing basically those blocks, physical blocks of different files, right? Don't think that these are the number of blocks which only for one file, but for the sake of simplicity, if you want to understand, so let's say this is the original block, and if the replication factor is set to 2, So same replica of this partition will be stored here, which is stored here, and it is stored here. So these are the data nodes, and these nodes actually stores the data in their local disk, right? And this is name node, which actually handles all the namespace related thing, metadata related things, and all other things, right? Just instructing the data nodes for the write request, replication part, and taking care of all the data nodes. So what happens here, you can see this term heartbeat, right? So every time these data nodes, the Hadoop has been designed in such a way that these data nodes keep on sending some heartbeats, right? A kind of simple signal, right, after a few seconds. And using these signals, or basically heart beats, name nodes keep a track of all the active and dead nodes in the cluster, right? So let's say this name node is not hearing any kind of signal or any kind of heartbeat from this data node since 1 or 2 minutes. So what it will do, it will mark it as a dead node, and before marking it as a like dead node, whatever was present here, like whatever data was present here, it will just interact with other data nodes, and whatever was stored here, that will get copied to other data nodes, right? And like on our resource manager, we will be able to know that if we will be able to know that if any of our data node is dead or alive, because we can see these kind of stats on the resource manager itself. So this is secondary name node, and this is HDFS client. That client could be anything. I mean, your laptop or any application program which is actually interacting with the name node, or let's say just HDFS client means treat it like your local machine from where you are sending a request, okay, to the name node. That secondary name node is actually placed here for the you can say recovery part, right? Because this is somehow related to the availability, not high availability, because there is another concept of standby name node. But for the simplicity, we will focus main on the secondary name node. So this secondary name node is placed here because name node here works as a single point of failure, because Hadoop is a master slave architecture. And obviously name node is maintaining some metadata, right? Namespace related thing. So what happens, on time to time basis, whatever metadata it has updated so far, right, it keeps on doing the checkpointing. Means whatever updated in last, let's say 1 minute, that piece of information, it will share it to the secondary name node. So what we can say, that somehow name node is keeping the backup of the data, I mean to say whatever metadata, namespace related data name node is keeping, it is just taking a backup of that metadata to this secondary name node. That's why we have named this as a name node as secondary, means which can be treated as a backup. So let's say because of any reasons we had to start our name node or anything, so it can take a help from the secondary name node, because the backup was maintained to the secondary name node, like the latest basically it can, name node can pick the backup data from secondary name node and can resume its operation from that point itself, because it was doing the checkpointing, all the latest changes in the file system and file block related information was stored here. We restarted it and we just took back the information from the secondary name node, and everything is back to normal. Okay, so this was the basically pictorial notation of entire cluster, distributed cluster, where we have a name node, HDFS client, data node, secondary name node. Now we will be talking more about these things in depth and its technical definition, its technical terminology. So we'll be talking about that one. So why standby name node? As I already talked about this part, right? For the high availability thing. So here in the diagram, right, it was a secondary name node. So if you remember, when I was talking about secondary name node, it was not acting like a active or just a proxy for a name node. It is working like a backup point. Whatever name related metadata will be here in the name node, that just get copied to this one. So let's say because of any reason our name node is down, we will just terminate it, and we will copy the latest checkpoint file or the file metadata related file from here, and will spin up the new name node so that it can act like a master. But here main purpose is to talk about the why standby name node, because I talked there will be two concepts, secondary name node and standby name node. So both active and standby name node use a shared directory, and standby name node sync through that directory from time to time, so that there must be no delay in activating it if the active name node goes down. So the drawback with drawback with this one, the secondary name node, was that there was a time lag, because it's not a very simple process, because file will be there, the checkpointing file will be here. So as soon as your name node is down, what you need to do, you need to just take some downtime means you need to ask for 30 minutes, 40 minutes or 1 hour something, in order to spin up a new machine, copying everything from here to here, and again setting up the things on the name node side. So that will take some time. But when we talk about the production system, we cannot actually tolerate, or we cannot give this much amount of downtime. So just because of the high availability part, we have a concept of standby name node. It is just like a replica of the name node, which works like the active name node, and the standby name nodes works in active passive mode. Active passive means if the original name node is active, this standby name node will be on standby, or it's not active, but it is observing what is happening for the name node. That's why it is mentioned here. Both actually access the shared directory. So if I have the name node, I have a standby name node. If they are just pointing to the same memory or same location, that means both are in sync always. So even if there is a case that this name node got down, the original one, it will just take one command to fire, like just activate standby name node, and your entire server is up again, right, within just fraction of seconds. So that's the advantage of having the standby name node, and it gives you the high availability in the system. But the main factor is that the block reports are not written in edit logs. They are stored in local disk space. But that is fine. I mean, this is again a concept for the report logs or anything. Means we have the concept of block. So the metadata related to it needs to be written in the edit logs for the fault tolerant or all. But at least our server is up, and the next syncing process with the data nodes will actually help the standby name node to understand about the entire cluster, and everything will be up to date. So syncing with shared is not enough to avoid this conflict. Data node has the address of both of the name nodes, and they send the block reports or the heartbeats, right? So here, if you remember, right, I was talking about this concept, heartbeats. So continuously these data nodes keep on sending the pulse or kind of heartbeats basically, right? Or you can say even block report, just kind of token or message passing something, so that this name nodes understand, okay, these are the data nodes which are still active and working. So in the high available architecture, what happens, these data nodes do not only send the heartbeats to name node, they also send the heartbeat to the standby name node. So that's why even it will take only fraction of seconds, and your system will be up again and quickly. Blocks in HDFS, I think in very high level overview or technically I have talked about it. What is the physical block, or what is the meaning of block in the HDFS? So it is nothing but the smallest unit of storage, because there will be a large file we have, let's say 1 terabyte, 1 petabyte, and when we will store it in the distributed file system like HDFS, it will be divided into smaller blocks. Okay, and different versions of Hadoop has a different or default value for the block size, but we can actually manipulate it. We can set it or configure it by our need. So let's see what happens here. it is nothing but the smallest unit of storage on the computer system. It is the smallest contiguous storage allocated, right? Those blocks I talked about, they will be like contiguously stored. In Hadoop, we have a default block size of 128. This is, as far as I remember, it is Hadoop 2.x versions, and for Hadoop 1.x versions, it was 64 MB. One should select the block size very carefully, right? Now, if you remember in the previous conversation, I talked about that. I'll just point out on a one very important question, or the impact of the block size, so that you can prepare it, because this is one of the interview question as well. So let's suppose we have a 1 GB of file, right? We have a 1 GB of file and we need to process it. Just treat it like a big data problem. So by default, let's say there is by default, let's say we have configured that the default block size will be 512 MB, right? So if we have a file of 1 GB, which will be equal to 1024 MB, so in this case only two partitions will be created, 512 plus 512, right? So only two partitions. And now let's say we will start our process, right? The computation process. So this process has two advantages. First advantage, less overhead on the name node side, because name node take cares the every metadata related thing, file metadata related thing. Like for this file, there will be, let's say, 10-20 partitions, and this partition will be stored on this data node, or this partition will be saved on this data node, these things, right? So name node has to manage lots of metadata related thing. But now here name node will have only two partitions to deal with, and it would be less overhead on the name node side just to maintain those metadata reports. But it will be an issue for the performance. Why? Because when we talk about the distributed computation, we used to run it like we actually want our system to run in a parallel mode, right? Smaller chunks are executing together, and we are getting the result quickly. So now just think, we have only two partitions of 512 MB size. So we can only create two parallel tasks, right? Which is still not a good performance. In terms of the good performance, this is definitely not the good idea, right? Having only two partitions. So this is the disadvantage, and as I talked about, it will be a less overhead on the name node. So that is the advantage. Now suppose if we have a default block size of 128 MB, right? So in total, in this case, there will be in total 8 partitions, right? 128 into 8 will be 1024 MB. So this is actually good. I mean, obviously there will be some overhead on the name node side if even the file size is very big, but that's fine. I mean, main for us, the performance matters a lot. We need the results in the quick time. So earlier when the file size was when the block size was 512 MB, we were only having two partitions for 1 GB of file, but now we have 128 MB of default block size for 1 GB file. So we will be having 8 partitions. Now 8 partitions means 8 parallel tasks, and they are computing it. So we will be getting the data in much faster way, right? So that's why this point has emphasized here. One should select the block size very carefully, because it has the impact on the performance, definitely. So this is just the explanation. If we will be having a block size, then what will be happen? But on very higher level overview, this is the point, that HDFS, or the blocks in the HDFS, is the smallest unit of physical storage, and our data will be kept and divided in that way. Now we will be looking at the other part. So replication management, I already talked about it, that replication, why it is important. In order to provide the fault tolerance, right? Fault tolerance means there shouldn't be any kind of scenario that if our system is failed because of XYZ reason, then we shouldn't lose the entire data. And that's the main importance of having the replication management in place. So to provide fault tolerance, HDFS uses a replication technique, in that it makes copies of the blocks and stores it on different data nodes, right? Let's say this is the partition 1. So some copies of partition 1 will be created, and this box is one data node. And since in order to provide the fault tolerance, obviously if we are just storing all the copies in the same machine, we won't achieve the fault tolerance, because what will happen if this entire machine is down, we'll be losing our entire data. So the copy of one, you can see, right, it is copied here, replicated here on this machine. So that's how the replication factors works. It basically helps to get the more advantage on the replication. It helps us to get the more advantage on the fault tolerance side. So by default, this value is configured, or this value will be set as a 3 by default when we will set up the things in the machine, or we will try to execute the MapReduce program. So by default, the replication management will set up this value to be 3 in the configuration file, but we can again change it. But we also need to make sure, right, this is not making too much impact. Again, let's say if we make the replication factor to 10 or 20 something, it will be a big burden on the name node side as well. But that is not even recommended to get the fault tolerance, because even if we are standard on a standard, if we are making 3 or 5 partition 3 or 5 replication, that is good, and we will be getting the good fault tolerance there. And even the cluster, the Hadoop system is itself very smart, that it understands where to actually replicate the data, so that like we are getting the efficient replication and the fault tolerance part. Now, what is rack awareness? This is the actually important as well. So rack awareness is actually related to the data centers part, right? Because obviously when we talk about the clusters, it will be a base. It will be actually collection of machines, right? Commodity hardware, and so these machines are nothing. Obviously, will be connected to our local network as well, right? Then only because of that they will be able to communicate with each other, right? Because in the entire cluster, if you remember, I talked about that data nodes communicate with each other in order to do the replication parts and all. So this entire cluster is nothing, basically a set of machine, right? Set of commodity hardwares which are connected with the help of the local area network LAN. So if you know about something in the networking, right, we have a like concept of switches, right? There will be routers, switches, and local area networks and all. So when we talk about a very large cluster, so in order to set it up, there will be a concept of switching. So with the help of one switch, there will be, let's say, 4 or 5 machines will be connected together. This is a root, you can say, the master switch as, right, and these are the switches here, this one, this one, this one. So there will be less possibility at least to face some failure on this root switch side. But let's say what happens if all the replicas, let's say this is partition A, okay, partition A, and we are replicating its copies to those data nodes which belongs to this rack 1. Rack 1 is nothing, all those machines, commodity hardwares which are connected to a dedicated switch. That means they belong to a rack, right? If you put something, you open a rack or you open a drawer, if you place something in that one, that means they belongs to a same rack. So same concept here, these all data nodes or commodity hardwares are actually connected with this dedicated switch. So dedicated, this switch means they belongs to rack, dedicated rack, we will call it as a rack. This one rack 2, this one rack 3. So let's say we copied one partition here. Let's say we have the 3 copies. So one is here, one is here, and one is here. Just imagine a situation that entire this switch is faulty or something happens to this switch. So your entire rack is down, right? You won't be able to access any of the machine which is here. So that means it is also a risk in order to lose the data, and that's why the concept of rack awareness comes into picture. I mean, when the replication will happen, so the system, the architecture will itself decide that in order to achieve the great fault tolerance mechanism, I won't only replicate the copies in the same rack. Instead of, I will copy the replicated part into different racks, right? So even let's say this rack is down, this rack is down, so you can see, right, the replicated part of block A is actually present here, so that can be accessible, right? So this is the concept of rack awareness, and one of the solid mechanism to achieve good fault tolerance in the Hadoop itself. All right, so now we will be talking about the map reduce part, the main the backbone of the distributed computation side. So far we are clear on couple of things. The HDFS, what is HDFS? Distributed file storage system, and we also talked about yarn as well. So it was nothing, just a resource manager. Now the map reduce, the actual logic or the concept which helps to do the distributed computation part. All right, so distributed computation, here why it is a distributed computation, because we will be having a set of machines which will be known as a cluster. Our data will be divided in smaller partitions, and those partitions will be stored on these commodity hardwares. And now the only task is remaining, that to send our code to these data nodes so that the processing can happen there, and those local computed results will be aggregated at the end, and we will be getting the final output. So the last part which I talked about, like sending the code to those data nodes, that means the execution part has started, or the mapping has started. So on a very simple terms, you can just think it like that. We had something like a piece of code, we mapped it to this node, this node, this node, this node, this node, and they are doing the computation. The original computation is happening on that part, right? And now whatever results they will be computing, so those are individual results, right? But when we talk about the final cumulative results, these data nodes will be sending the data to some dedicated point, right, within the system itself, and the aggregation will be happening there, and we will be getting the final output. So this is the very high level overview of the map reduce concepts. But now here I'll show it in a more technical way, and we'll be talking about different steps in the map reduce part. So map reduce in technical terms is a programming framework that allows to perform distributed and parallel processing on large data sets in a distributed environment. So that distributed environment is our cluster, and parallel computation means because we will be having smaller chunks of data on these machines, so jobs will be running in parallel. Map reduce consists of two distinct tasks, right? Map, that's why it is named as map reduce. So two major tasks it needs to follow, the mapping and the reducing part. As the name suggests, map reduce, reducer phase takes place after the mapper. Obviously very like common sense related things. First mapping is happening, then the reduce part, the actual aggregation is happening. The first in the map job, where a block of data is read and processed to produce key value pairs as intermediate output, right? So this is also again a very high level picture of the map reduce task. So this will be input, this will be our input, means do not think like that it will be a single file. Input means we are reading from a dedicated cluster. Just think like this is a combined one cluster. So once we start reading, so these map, right, these maps are nothing, the executional programs which are running on these slave nodes, right? Here to picturize in a proper way, right, we have actually combined it one single box in order to name it like a map task. So just think, let's say you had a 1 petabyte of file, and based on the block size it was divided in 30 partitions, right? So in order to process those 30 partitions, we actually need to create those 30 tasks, right? And those 30 tasks are actually what they are, mapping tasks. So this is 1, 2, 3, because every block, physical block, will be processed by the code itself, right? And these things will run in parallel, one by one. Sorry, not one by one, in parallel means on different machines. Okay, so this is the entire part of map. And the thumb rule of the map reduce framework is that the map function will produce the output in the form of key value, right? Everything here will happen in the form of key value, right? First part will be mapping, which will create some result, and as I already talked about, reduce part will be more concerned for the aggregating the things. So in order to aggregate, it should definitely know that these are some values which belongs to the same key, else it won't be able to aggregate it at all, right? So that's why the concept of key value came into the picture in Hadoop ecosystem, that this even this will accept the map function will accept the input in the, you can say, key value format, right? The way the program or the way its library is built, once it will start reading the data from the cluster, by default it will read it in the form of key value. Mechanism is there which basically, even you can provide that what should be the key, but if it is not there, by default it will think something, right? Let's say position of line or these kind of things as a key, and the entire value mapped to that line as a value. So it read in the form of key value, and it delivered the intermediate result. Intermediate result is the local computed output by every map task, right? Because this will compute something, this will compute something, this will compute something. So in this part, right, which is this white part, so this is nothing, this is the intermediate result, because the computation is not complete yet. These are the individual results. Now the reducer part will take place. This will what it will do, it will accept these intermediate output created by map task, which is in the form of key value, and based on those keys and value and whatever function, whatever transformation we want to apply as an aggregation, it will do that. Let's say we want to do the summation, so based on the keys it will apply the sum function and will aggregate it together. And here in this red box, the final things will be combined together, and we will be receiving the output in the desired location or even the terminal, wherever you want to print it. So this is the entire working mechanism of map reduce methodology or map reduce section. And now we will be talking about these parts, right? Its individual parts. These are actually the sequential steps, you can say, in the map task, and there will be a couple of sequential steps within the reduce task as well. So here in this picture we saw this part, the big box of map task and big box of the reduce task. But here in this as well, within the map task there will be some sequential steps which needs to be followed, and here in the reduce task as well there will be some sequential steps which needs to be followed. So here first step would be the record reader. I mean, reading the data actually from the external disk or wherever the block or the data is stored. So the recorder transforms the input split into records, right? It parses the data into records, but does not parse record itself. It provides the data to the mapper function in key value pairs, right? This record reader is actually method written in the library itself. What it will do, it will point to the external block which is stored in the data node, and it will read it, right? And it won't do anything. It will just it won't do any sort of operation on the original data or anything. It will just create a key value part for the map or intermediate task, right? Now after the record reader part, there will be the actual map thing. So in this phase, the mapper, which is the user defined function, which like we need to write, like within the map function what we need to do, right? There could be a different logic. Let's say we read some line from the text file, right? And we want to split it, right, in the entire line based on some delimiter, based on some key argument or anything, right? That's why it is a custom part, that what we need to do in the mapper related things. So in mapper, which is user defined function process, the key value pair from the record reader, it produces 0 or multiple intermediate key value pairs. I mean, if it received something, it will definitely generate, if we have applied any user defined logic in order to generate the key value pairs. The decision of what will be the key value pair lies on the mapper function. Whatever we will define, based on that key will be generated, and based on that a corresponding value will be generated. The key is usually the data on which the reducer function does the grouping operation, right? Because that's why this key argument is very important for the map function to generate, so that it can be consumed by the reducer in order to do the aggregation operations. And value is the data, like the actual data which needs to be delivered and which needs to be presented to the user. So record reader, first step within the map task, the map part within the map task, then the combiner. The combiner is actually a localized reducer, right? Localized reducer which groups the data in the map phase, because within every map task, right? Within every map task, the computation will happen on the record by record, right? It will be in a kind of loop, and that record by record, you can say, computation will be happening. So in that way, within this map task, there will be a subset of key value pairs will be generated. So the combiner, what it does, it actually within this map part, right, which is, that's why it is named as localized. Just think from one map part, that this is one map function, it will generate some key value pairs for the block size or for the partition which this map task was processing. It generated some key value pairs, and this is a kind of pre-intermediate data which then got aggregated here itself, right? Aggregation is not like, don't think that the actual aggregation or operation is happening. It is just like, let's say we have a key value pair like 1 comma a, then 2 comma b, then 1 comma c, 2 comma d. So whatever values which belongs to the key 1, right, they will be distributed here and there in the like memory. So just to put it or to combine it as a one single entity is the actual task of the combiner. That's simple thing. Don't think that the some sort of aggregation, sum or anything related, this will be happening on the combiner. The combiner will just try to bring all the common keys together, so that all the corresponding values for that key are together. Now the partitioner. So partitioner pulls the intermediate key value from the mapper, right? Mapper intermediate, within the mapper it actually created something, and from the mapper it splits them into the shards, like one shard per reducer. So here, in order to decide by the Hadoop system, let's say how it will decide that how many map tasks I need to create. On average, on our as a standard process, what happens, one block size actually treated as a one input split. Input split means the entire piece of data which will be read by one single map task. So if we have a 30 partitions, that means 30 map tasks will be created. And for the reducer task as well, like based on that, let's say how many reducers we have defined, right? That for the aggregation, how many reducers can be there, right? So that will be decided here. And I mean, let's say we had some result or intermediate output by the mapper. So based on that key, right, and based on that key, so how I can actually explain you is here. So let's say there are some values 1 2 3 keys, which are actually keys. Let's say 1 2 3 will be here, and some record this mapper task placed which also generate key value pairs like 1 comma a and 2 comma b and 3 comma c. This mapper task also created some values which is like 1 comma z, 1 comma k, 1 comma m. So you can see, right, the key is common, right? 1 comma a, 1 comma z, 1 comma k, right, which is actually processed by these mapper tasks locally. So in order to just see that how many values, or if I want to, or if I need to sum anything, so for that corresponding value key, for that corresponding key part which was 1, it needs to be present on one single reducer. right, in single reducer. Or just think from a very simple perspective that all such kind of keys, right, just try to relate it with a practical example, that you just want to count that how many t-shirts do you have for the of the black color, right? And within your home you have 4 5 6 almiras, and in each almiras there will be some number of black t-shirts are placed, right? So those are just those almiras, you can actually treat them as a key value, where key is almira 1, right, and key is almira 2, something like this. And within that almira, right, within the almira we can have actually different kind of t-shirts as well. So if I just want to calculate that how many black t-shirts I have, okay, so and how many t-shirts I have for t-shirts for the red color, and how many for the green color, so you will be actually combining, or you will be actually aggregating the things based on the almira as a key, right, and just taking the total count of the red t-shirts you have, right? So this is the simple process here. And reducer, uh, again on a very simpler note, don't get confused that what it does, because it generated some output, those outputs will be local, but when you just want to present the collective results, you should have everything at one single place for that to sum up the things or to add everything, right? So that's how it will be, like the output of the mapper task or the intermediate key value pairs will be consumed by the reducer task, and the next processing part will be started, which is nothing, just doing the aggregation in the reduce part. So within this reducers task we will be having some intermediate steps, so I'll be talking about that one as well. So this is the simple here, I mean, just to wrap up the things related to map task. So partitioner was again, it will see that we have a, let's say, key value pair name 1 comma a. So 1 is key. So depends on the number of reducers, it will use some basic hash kind of mechanism. For key 1, it will divide by some value, and whatever hash value has been generated, and based on that, and that those hash values are nothing, just you can say the IDs of the reducers, and based on that the partitioner will decide that I need to send this key value pair to this reducer. So this kind of hashing and sending, or deciding for a record or for a key value pair that where you actually need to go on the reducer side, that is the actual work of the partitioner. Alright, so after talking about the map task, we will be talking about the reduce part, right? Two phases, map part and the reduce part. As we saw, there are like couple of steps within the map step as well, like the input format, then the map part, then the combiner, then the partitioner. Now here in the same fashion, reduce itself, right? This is the actual big box of the, you can say, the map part and the reduce task. So within the map there were a couple of steps. Similarly in the reduce task there will be certain steps it needs to be followed, and here are these steps. The first step within the reduce task will be shuffle and sort, right? So from the map task we know this part, map will receive input in the form of key value, right? And it will also generate the intermediate output in the key value format. And since it's a distributed environment, right, so you should always treat it like that all the keys will not be present on one partition, right? Let's say it was a 1 petabyte of file and it got partitioned into 20-30 partitions. So it's not necessary that, right, all the values related to that specific key will be in the specific partition, right? It can be present in, let's say, first partition, then its other value will be present in the 11th partition, and those partitions are itself distributed among the slave nodes, right, on different locations. And in the map phase, what is happening, we are sending our logic or the code part to these partitions or to these data nodes where the actual processing will happen in the local mode, right? They will be computing the output in their local part. If this is a specific slave node, whatever partition it was storing, it will just generate the output for that one. So that was actually being done by the map task itself. It did that, it prepared the intermediate output, and now this intermediate output will be consumed by the reduce task. So what is this shuffle and sort? So in data analytics, mostly times it is all about the data aggregation, right? The important and common operations, right? You will be just probably joining and aggregating, right? Calculating sum for a specific months, years, or some specific, let's say, product. Okay, so you need to aggregate it. So in order to get the complete aggregation, you actually need all such values which are mapped with specific key X at one place, else you won't be able to combine it together. Okay, so that is the main purpose of the shuffle and sort part here, because here the intermediate result will be lying on this part. Okay, so this shuffle sort part, what it does, it actually just shuffles the intermediate data. So shuffling means sending the intermediate result to these reducer task, right? Within this reduce task, these reducer operations. So based on the number, right, based on the value of reducers, means the partitioner will decide that which record will go on to which partition based on the key value. Like it will use the key and will do some hashing algorithm in order to produce the reducer ID. Okay, so based on that it will be done, and that is actually the shuffle part. And then sorting means first we just shuffled it, and then sorting in means we are just placing all the values in specific order and then doing the aggregation part. So we'll take a look at the technical definition. So the reducer starts with shuffle and sort step. This step downloads the data written by partitioner, right, to the machine where reducer is running. So intermediate data will be produced by the partitioner of the map task, and then shuffle part, it will actually just shuffle these intermediate data. And shuffling means sending these data from here and there, which were stored in different partitions, to the specific reducer. This step sorts the individual data piece into a large data list, right? Shuffling was done, and within after doing the shufflings, the queue within the local machine keys will be stored some here and there. So in order to do the aggregation, we just need all those values mapped to a specific key at one specific place or in one specific contiguous memory locations, right? So this step sorts the individual data piece into large data list. The purpose of this sort is to collect the equivalent keys together, right? Whatever keys we have, so that they are collected together. The framework does this so that we could iterate over it easily in the reduce task, right? Because once we will have all the values for a specific key, it would be easy to do these aggregation operations. This phase is not customizable. Obviously it is inbuilt, like we can write our own combiner, we can write those custom logics for the combiner and map task, but this is something which is obviously built in the Hadoop framework itself, their own logic, and it cannot be modified. The framework handles everything automatically. However, the developer has a control over how the keys get sorted and grouped through a comparator object. So this is nothing, just a custom way. Like we can even provide our own sorting mechanism here within the configuration, right? As far as I remember, by default it uses the quick sort to do the sorting part, but we can also pass our own sorting mechanism and comparator object for doing the sorting part. That part can be done, but rest of the things related to shuffle and sort are the fixed, they are not customizable. Now the reduce part. The reducer performs the reduce function once per key grouping, right? So this is the actual part which will do the aggregation part, right? Since now we have all the values related to specific keys are together, and now there will be a next step where we need to apply some function, right? It could be a sum function, it could be let's say average, mean, median, min, max kind of function. So applying those functions to a specific specific key, right? Group of values for a specific key, and that is the actual work of the reduce part. So the framework passes the function key and an iterator object containing all the values pertaining to the key, with like all the values which are belonging to a specific key. We can write reducer to filter, aggregate, combine data in number of different views in different ways. So here the meaning is, let's say you have the keys and their corresponding values, and now like you can take a control of it. Whatever you want to do any aggregation, if you want to just do, let's say for a specific key, you got some negative and positive values, right? So you only want to take a sum of positive values. So first you can apply the filter part, then you can apply the summation part. Once the reduce function gets finished, it gives 0 or more. Like if your according to your logic, if there is possibility to generate any data, then you will be getting some key value per output. If not, then it will be returning any, like it won't return anything. Like map function, reduce function changes from job to job. Obviously it depends, as it is the core logic of the solution. So map and the actual reduce. So mapping, like how you want to generate the key value, that was the core part of the map task, which was customizable and user defined function. And here in the reduce task, this is reduce part is actually the core, right? Where you will write your own custom things, that how you gonna filter, aggregate, and you want to generate the output. So this thing actually happens within the reduce part. Now the output format, again similar to the input format in the within the map task, right? Because input format will decide that in which fashion you are accepting the input in the map task, right? If it is going to be a key value, then what will be the key and what will be the value. So similarly, output format will decide that where you gonna write your data and in which way you want to write the data, right? If you, after the reduce part, you want to make something else as a key and then value, and where you gonna write your data, so that will be handled by the output format part. So this is the like actual definition and work for the map reduce. And just don't worry about it. I mean, probably you are looking for more simple example here, and that is like about to come. Once I'll finish the theoretical concepts related to the resource manager, then I will show you a hello world kind of program for the Hadoop application, and that's a simple word count problem. So there I will be showing you all these steps, right? What happens in the map part, what happens in the reduce part. So you will be able to relate, right, each and every step with that example, and that will also, we will also try to write that hello world count program and in our demonstration part, right? So just wait for some time. In the next coming sections, that will be the example we will be looking for. And but before moving that, we will cover the last part, which is actually related to the resource manager. So we'll be looking at that one. And here like on a higher level, right, you can see this entire flow diagram which depicts the entire map reduce computation thing. So HDFS is split. I mean, this will be so we have a two concept, right? We have a block and a split. So block is basically we call it as a partition or physical partition, right, which is stored on some disk part. So here HDFS is split means this is logical partitioning of the input data, right, which is nothing, basically getting passed to map in the form of key value pairs, right? So different partitions will contain different key and values, right? And if you are trying to solve a common problem, so let's say there is a key X, one record for key X will be here, and let's say one record for key X will be here, right? So because it's a partition and distributed data, you shouldn't consider it like that all the keys will be at one place within the input split itself. So now it was passed to map, and map did something, right? Its own mapping logic and all, and it produced these intermediate result. So you can see the this is key 1 comma value 1 key k and value k. Key 1 also present here, value 1 key k value k, then key 1 here again and value 1, right? So you can even see that key value different, this value, let's say 2, this value can be 3, this value can be 4, right? And now at the end, what you want, you just want that what is the total summation for the key 1, right? So here value was 2, and here value was 3, and here value was 4. So 4 plus 3 plus 2, that is 9. But this is the local computation. This was produced by this specific map task. This was by this one. This was by this one. So you need these intermediate results to be present at the reducer, right? So here shuffle and sort aggregate values by key. So this is actually by mistake not a map. This is the reduce part. So it is what it is doing. It is like key 1 intermediate values. So this is the intermediate value of key 1. This is the intermediate value of key 1. This is the intermediate value of key 1. And they are all present at this reducer, right? Because like whatever key using this key 1, the partitioner will do some hash mapping kind of thing, and it found that based on the value return value of hashing algorithm used for the key 1, the reducer 0 ID was generated, and that's why we need to send all the records, intermediate records which belongs to key 1 to this specific reducer, so that now all the intermediate values related to key 1 are present on this specific reducer. And that was done with the help of the shuffle and sort part, because shuffle operation will pick these intermediate results from different intermediate results and will put it on a one single reducer, and within the reducer this sorting part will be done so that all the values related to one specific key are placed at one contiguous memory of location, so that aggregation can be done. And after that the final result will be evaluated, like final value for the key 1 and final output value, which was the summation, and the result was 9. So that's how the entire architecture of entire map reduce part is working. Now let's look at the yarn, yet another resource negotiator. So I talked about 3 important components in the Hadoop architecture. First was the distributed storage, which was HDFS. Second, which is the actual core of distributed computation, which is MapReduce. And third, this is very important because we will be working on the cluster, right? Cluster of 100, 200 and 1000 nodes. And that's the very basic of computer science itself. Like even if you have a machine, right? So in your laptop, right, when you run different tasks, right, different applications, so your operating system itself take care of this one, right, scheduling these tasks so that multitasking is happening and everything is running smooth, fine, right? They different applications will occupy different memory and they will need different amount of RAM to execute their things. So operating system is actually managing all these things. But when you are actually talking about the Hadoop architecture and framework, so there should be also something which can do this management, resource management related thing. And here this yarn plays an important role. So yarn actually the resource manager. If you are working on a huge amount of cluster and you have a very big size of cluster, then resource manager services or yarn services will actually take care of all the things, like from the start till the end, right? From the starting means like as soon as you submit your program from the client, it could be anything, your host machine or anything. So it will accept that application, will figure out that where the required data is stored, and actually it will look at how much memory and how much computation power this application needs, and will try to allocate these much amount of resources for the specific application, and then even it will keep an eye on it, right? Computing its log, scheduling it, and then monitoring it, and if something happens in between, then capturing the error messages and these efforts, right? So one these efforts is specific to the application, but along with that it also needs to manage the entire cluster. So it will take care of all the jobs which are running on the specific cluster. So allocating those resources, communicating with each other, everything, this is the actual responsibility of yarn. So yarn, yet another resource negotiator, is the resource management layer of Hadoop. The basic principle behind yarn is to separate resource management and job scheduling / monitoring function into separate daemons. Daemons here means simple like services, right? Because when we were talking about the Hadoop part, right, the HDFS related thing, so there were two components, name node and the data nodes. So let's say you have 100 commodity hardwares and they are completely empty. They cannot do anything unless you provide some mechanism on program to them, which is actually taking the action. So it will be the program which will be taking the action that, hey, machine, this is the task which you need to do, right? So these tasks are nothing, obviously, programs written in the framework library itself. Okay. So whenever we set up a particular framework, we need to spin up these services, right, on a specific. Let's say I have chosen server A, which should act like a name node. But how this machine will know that I am working as a name node? So there will be a specific piece of program which we need to like configure, and which we need to execute on that machine, right? That's why it is known as the daemon. Daemon means which is actually running in the behind and guiding that empty machine, that this is your role and responsibility. So name node actually one of the daemon, and the data name node will be running or let's say in any of the server. If you have executed your name node service, that means that a specific server is working as a name node, and wherever on the different servers you have executed the data node daemon, that means they are working as a like your slave nodes, right, where the computation will be happening. So similarly here in order to maintain that entire cluster, right, in order to maintain and just take care of the entire cluster, scheduling, monitoring, everything, there should be some specific services, right, which should be running in the background so that they can accept the application execution step, and then can communicate with the remaining slave nodes of the cluster, right? So there are some daemons in the daemon or background services which we need to spin up when we will be setting up the yarn in the Hadoop ecosystem, right? So in yarn there is one global resource manager and per application master, right? So resource manager will be one daemon service which will be running in your cluster, and that will be a communication point, right, for your application and among the data nodes or the slave nodes we have. And for per application there will be one specific like daemon will start getting executed, named as the application master, right? So application master is nothing, just a representative for your application, right? Let's say you are an entity and application master is something kind of your representative, which will actually talk to this resource manager and will ask for a specific number of resources so that the computation can get started. Inside the yarn framework we have two daemons, that's what I talked about. Resource manager will be the first daemon, and a node manager, this node manager will actually will be actually executing on these slave nodes, right? Because they are the someone who actually take care of the computation part. So this daemon will be running on those systems. The job of the node manager is to monitor the resource uses by the container and report the same to resource manager, right? So every system, right, every slave node has its own CPU, RAM, and these things available with it, right? So there should be some service as well, right, which should even capture the resource availability within that machine as well. So node manager does the same, right? And it keeps on reporting, and it keeps on sending the reports to the resource manager that on this machine this much amount of CPU and RAM is left, and based on those stats, resource manager will take care of the action that how much memory and how much resource I can allocate to a specific application. The no, the job of the node manager is to monitor the resource uses by container and report the same to resource manager, the resources like CPU, memory disk, network, and so on. The application master, which I was talking, right, it actually works like a negotiator and a representative of your application, negotiates resources with the resource manager and works with node manager to execute and monitor the job. So that's the overall thing happens within the yarn as well. And here this is the actual state or kind of flow diagram for the yarn. So this will be the service resource manager which will be running on the cluster. It will be accepting the requests from different clients. Clients are nothing different machines and different request which will be sending their application, distributed application, to get executed over the cluster. And here node manager, you can see this box is nothing, basically this box is your simple slave node, right? And these container, app master is basically specific to any specific application, and container is the actual black box where your entire execution will happen, right? So within the specific machine, these smaller containers will start getting executed, which will be doing the computation part. So this is one box, this is like one slave node, this is another slave node, this is another slave node. So within every slave node, this node manager service will be running, because it is monitoring the capacity of this specific machine. And since there can be n number of applications, so n number of master as well, right, for different applications, and they can spin up on any of the slave node, right, which is available. Similarly, container within the this machine on box, the container will be running, which will be doing the actual execution part, right? So this is the overall picture of the yarn cluster here. And now we'll be looking at the different parts. This is the more detailed part of the different components in the yarn itself. So first component is the scheduler. It is responsible for allocating resources to various applications. This is a pure scheduler, as it does not perform tracking of status for the application. It also does not reschedule the task which failed due to the software or hardware errors. The scheduler allocates the resources based on the requirement of the application. So scheduler means it's not like that it is taking care of everything, that if your job gets failed, then retrying it, and then looking for the preemption, starving conditions. No, it doesn't work like that. Its task is quite simple in a yarn, that just estimate the capacity and the memory, CPU, RAM, etc required by the application, and just allocate it for the specific application. Application master negotiates the first container for executing application master, because application master is also kind of daemon or executable program, so it needs some environment to get executed. And first basically container will be spinned up on any of the machine available, and within that this application master daemon will start getting executed, and it tracks the resource container status. Like for your application, let's say 20-30 containers were allocated, so it will work along with the node manager to keep a track of those containers, and based on that to keep a track of the running execution status of your application. And here obviously what I mentioned in the previous point, monitors the progress of the application, like it is still in the running state or completed, finished, cancelled, killed, whatever is the status for your application. And the node manager is yarn's per node agent. Per node Like if we have a data node, so in one machine there will be one node manager service is running, which is taking care of all the capacity estimation and the resource available in one data node and the slave node, and take care of the individual compute node in the Hadoop cluster. Now, features of Yarn, we will be looking at what kind of features Yarn has. So multi-tenancy, like Yarn allows a variety of access engines on the same Hadoop data set. The access engines can be batch processing, real-time processing, iterative processing, and so on. So multi-tenancy actually means, right, it can be used with any kind of distributed computation engine, right? So Hadoop is one of the example for the distributed computation engine. Now in the market there are many more. We have Spark as well, Apache Spark, we have Apache Flink, right, and many others. So it is compatible with these ones, right? Even if you have written a Spark application, you can submit it to the Yarn and it will do the same thing for that one, right? If you have written a Flink application, you can submit it and it will do the same for that one. Cluster utilization. With the dynamic allocation of resources, Yarn allows for good use of the cluster, right? That's the beauty of the Yarn, because it keeps a track of all the available resources. And let's say you submitted your application, right, and this time your entire cluster is busy, right? All the resources are occupied. So what will happen? Yarn won't cancel your application, right? It won't say that hey, our cluster is occupied, we won't be accepting your application. What it will do, it will actually put your application in the queue, right, waiting queue, and it will keep on checking, right, that as soon as the required amount of resources are available which was required by your application, it will instantly put your application from queue, waiting queue, to the running status. So that's why the dynamic allocation is the actual importance of the Yarn, because it keeps a track that this is the number of resources available till now, and if the job execution can be done or not. Third point is the scalability, and any data center processing powers keep on expanding. Like Yarn's resource manager focuses on scheduling and copes up with every expanding cluster processing petabytes of data. So same, I mean, since Hadoop itself a scalable system, and same way Yarn as well, right? Its main daemon service is resource manager, which keeps on keeps on looking at the entire capacity and resource of the cluster. So even in future, if you add 10, 50 or some XYZ nodes in your cluster, so it can instantly capture the new resource capacity and allocate the jobs accordingly. So again, it's scalable in terms of that. Compatibility. MapReduce programs developed for Hadoop 1.x can still run on this Yarn, and this is without any disruption to process that already work. So the concept of Yarn actually came after the Hadoop 1.x versions, like it was introduced in Hadoop 2.x. So what was the drawback of the Hadoop 1.x version? There are only two components: the distributed computation, which is MapReduce, and distributed storage, which is the HDFS part. So in 1.x version, what was happening? This part was also being taken care by the MapReduce part itself, right? The scheduling, the execution, resource allocation, and these things, which was a kind of extra overhead on the MapReduce, because they had to take care all these things, and it was not adding value in the faster execution. So in the Hadoop 2.x version, they came up with the with this concept of Yarn, that we can remove this extra overhead from the MapReduce part, like just create another layer of the resource manager, and so that MapReduce can only focus on the computation part. And that's why Hadoop 2.x got popular because of this one. And but they also supported the backward compatibility for Hadoop 1.x as well. It's not like that if you have written any application using the Hadoop 1.x version libraries, then you won't be able to execute on Yarn. So that's not true. They have provided that kind of compatibility as well. So these were the theoretical part for the entire you can say yarn, MapReduce, HDFS. Now it's the high time to talk about the word count example of MapReduce, which is the important, really important. And after this example, I can just guarantee that if you have any doubt related to the map, reduce task, HDFS, storage, anything, after this example, everything will be cleared in a very simple, straightforward way. So this is the our hello world program for the Hadoop application, and which is nothing but a word count application. So first let us understand like how a MapReduce work by taking example where we will be having a text file named as example.txt. So text file like plain text where you have written some paragraph or anything. So here what it does, this text file actually contains 3 lines only. Deer, beer, river, car, river, deer, car, beer. So this is your input file, text file. Just imagine it like, right, since this is very simple example. So imagine this is a 1 petabyte of file, and that's how these different sections will be divided onto different in the form of blocks, and they will be stored on different slave nodes. All right. So here you can see, right, these 3 partitions. This is the first line, second line, third line. Okay. So this is nothing for the sake of simplicity. What you can think that these were the actual partitions which were created, right, and were stored on different data nodes. And as a one is an input split, we will be treating one block will equals to one input split. Okay. And in the input split, what happens? Basically preparing the key and value. So here key is just nothing. You can say the starting location of this line within the text file, right? So that will be the key here, and the value will be the entire text line. Okay. So this is our entire value, and key will be starting position or the starting memory location of this line within the text file. Okay. So this is your one input split or one block or one partition. You can say this is your another partition, this is your another partition. Now the part was the mapping task, and in the mapping what does happen, it accepts the key value as an input and do some mapping related things and generate intermediate results in the form of key value. So here mapping is happening, right? So within the mapping, what we did actually, we just did because it is a word count, right? So word means deer is one word, beer is one word, car is one word. So in an input file or in a sample text file, how many times a specific word was occurred, that is the actual end use case we are trying to solve. So here, this was the input line. What we did a split on this space, right? Because there is one space after word. So we did a split, and what we did after the split, these 3 will be the individual text, right? And what we can do, we can create a pair like this, right? For every splitted value, we will just create another kind of pair, deer comma 1, like we will just add one value in it. Okay. And why we did it, we will get to know in the later results, right? So we did it, we actually just created this mapping, like after doing the split, just make this kind of pair for every single entity after the split part. So deer comma 1, beer comma 1, river comma 1. So this thing actually is happening for one specific partition. So this is the actual local computation, right? So for the simplicity, suppose this happened on slave node 1 and this computation happened on the slave node 2. This computation happened on the slave node 3. Okay. So these are the local computations. And here again, if you remember, I was talking that different keys can be present on different slave nodes because data was partitioned. So deer comma 1, here now we will be treating deer as a key and comma 1, this one as a value. Okay. So key which is named as dear, it is present here as well, it is present here as well, it is present here as well. So mapping task is done. It has produced this one as an intermediate result. And now in the sorting phase, right, so this is this border line. If I draw some border line, so before this one, this is related to the map task, and after this one, this is related to the reduce task. So in the reduce task, first thing was like doing the shuffling and sorting. So here you can see shuffling means just bringing data for a specific key, right, which is present on different slave nodes to one specific reduce task. Okay, so here you can see beer is one of the key, right, which is present on different slave nodes. So shuffling, what it did, it checked, okay, beer key is available on how many number of slave nodes. So it is present here, it is present here, it is present here. Okay, so what we will do, we will just bring it at this place. Okay, so this is again by here, I think this is again by mistake. It shouldn't be like dear one here, it should be car comma 1, car comma 1. So just ignore it for the time being. Means you can even figure out from here like beer how many times it will be repeated here. So this is the part here, and the number of times beer keyword was repeated 2 times only. So in the shuffling, just based on the key value key part, it checked and it just assigned it to a specific reduce. So beer comma 1, just ignore this one, that only these 2 values for these 2 intermediate result for key beer just pulled from the intermediate result and are placed here. Same for the car. Here in the input, right, car was 1, here car 1, car 1. So at least 3 times it will be there, and same thing you can see here like car 1 comma 1 comma 1. For the deer, it is 1 time here, 1 time here only. Okay, so 2 times you can see it here. River as well, right, 1 comma 1. So after the shuffling, this happened, and when the shuffling happened, it didn't actually just placed all the related values in front of each other. This part was done by the sort, right, sort part for a specific key. Since all the values are available in this local reducer, so sorting, it will just club all those values together and will put it in our contiguous memory locations. And now the reduce, the actual aggregation is happening here, and in this aggregation what is happening, we are just doing the summation of all the values which is present here. So summation doing like beer 2 times, 1 plus 1 plus 1 3, deer plus 1 plus 1 2, and river 1 plus 1 2, and this is our final output. So that's how the entire flow is actually working here, and this is the simple execution part of the word count problem. And I think after this one, like most of the things will be clear to you, that how splitting was happening, what is the input split here, what is the block here, what is happening in the mapping, what kind of output it is generating for the key, and then how those keys are getting shuffled, sort, and what is the happening in the reducer part, and then how we are generating the final result. So that was all about the word count problem as well, and here it is the very detailed explanation, and I don't think so I need to repeat it again, because everything I have explained here itself, that how entire division and everything is happening. So probably you can just you want, if you can pause the screen and you can read all these statements from here, and you can even understand the things theoretically. But to understand in a pictorial way, I have explained all the theoretical part here. Alright, so now we are at the end of the entire session, and in this part we will be covering the demonstration part, like how to run a basic map reduce application. And this is the example for the word count part, and in the previous slides we actually talked about it as well, that what is the entire process in the map reduce, different tasks of it, what happens in the map part, what happens in the reduce part. So now I will be talking about the practical example, so that You can even see what kind of output will be generated, and how to pass the input parameter and the output parameter, these things. So I'm gonna talk about that one. And just to make the things very easier and simpler for you, I'll be following a set of instruction to set up the Hadoop in the local environment. And I will be talking about different setup environment as well. And most of the things I have already set up in my machine, in my laptop, but I will also again go through with those steps, and will clarify that what you need to download, what you need to set up, what kind of variables you need to set up, right? And we will be doing this map reduce sample exercise in Python. Like our mapper code and our reducer code will be in the Python, and it will read a simple plain text file, and there's some text is written, and it will try to do a word count for that. So that is the simple problem statement here. So first let's quickly jump on to the set of instructions which we are going to follow. And this is the set of instructions, right? We have mentioned here. So just read this line, like Hadoop is supported by Linux platform and its flavor. So let's say you have a MacBook, so in it also provides, like, gives you the environment for the terminal, where you can simply just use the Linux commands and all. And if you are, let's say, using Ubuntu itself, right, you can set up these things very easily. If you are using, let's say, a Windows laptop, so there you can actually download a virtual box, and there you can set up the Ubuntu, and you can practice all these kind of setups there. Okay, and these are the some pre-installation related setups that before doing the actual installation of the Hadoop in the local setup, what should be the pre-installation things, like prerequisite for it. So here the Hadoop as a framework, right, it is built using the Java. So obviously in order to run different services of it, and different you can say daemons of it, right? We talked about different daemons. It needs the like JVM part, and Java virtual machine, where it can execute its Java related packages, so that your Hadoop is up and running in your system. Okay, so that's how, but before that, these are the important steps we need to follow first. So first is like before installing anything, you need to be a super user, right? So for that you can run this simple command, sudo su or su simple, and you will type your password, and you will be working as a root user there. After that, this is something like we need to set up the SSH part. So why SSH part? Because when I was talking about the entire distributed cluster, right? So when you work in a cluster, there will be some machines, right? And they will be connected with the local network. So if one machine is want to talk about to different machine, like another machine, so there should be secured shell communication between them, right? And that happens with some private and public key exchange, and that we need to set up, right? In our machine itself. So these are the steps which you can follow in order to set up those or in order to generate those public private keys in your system, and that can be used for the SSH part, because different services will be running. I'll be talking about that one. Just think that we have the name node, we have the data node, and we will be having the resource manager. They will be running on different machines, but at the end, in a distributed environment, they need to communicate it with each other. So in order to talk to with each other, they should be able to send communication and log into another machine, right? And that can be done with the with the help of secured shell. So these three steps, like, you need to follow. Just completely follow these steps. I mean, you can tune the problem. If you face any kind of problem, you can just again definitely Google it. But if you are following these written specific sets as it is written, I don't think so you will be facing any kind of problem. So first run this command, then this command, and this command. That will be done. After that, what you need to do, again, I said, like, Hadoop is completely built on Java. So Java should be there, right, in your system. It should be pre-installed. So first, what you can do, you can actually try to run this command. I mean, just let's say you have some laptop and you just want to verify whether Java is set up in your laptop or not. So how you can do it, you can just run this Java version, right? And you will be able to see it. Let me just zoom it a little bit. The Java hyphen version, right? So this is the version we have, right? JDK version, and since it is already set up in my machine, right? So it is already here, so we are good on that part. And let me take you back here again. So if let's say it is not set up in your laptop, then what you need to do, these are the actual steps which are mentioned here you need to follow in order to download the Java, and even steps are mentioned to set up the like path variable, environment variable in your system, right? So what they have mentioned, like just download this part, like click on this one and try to find this one. And sometimes what happens, right, since these articles are old, so whatever, let's say the link they have mentioned, probably they are deprecated and they are not working. Okay, so what you can do in that case, you can simply do this thing. Let me show you, like this one, just copy. They ask you to copy this part, right? Or to download this part, you can simply just whatever they asked you, you can just come here and type here, and you will be just following these whatever is the URL, I mean that is for the download part. So whatever file they have exactly mentioned here, you can just download it manually itself from there. And that's how, like once let's say you download it, it will be in your download folders. Then you are just following these simple steps, move into your downloads folder, do ls, you will be able to see this file if it is downloaded successfully. And there you need to actually run these commands. So this is basically a zipped version, right? Kind of tar file, right? So you need to just extract it, whatever is stored here, all the executables and everything. So for that one, this is the command. As soon as you will execute it from this zip file, this actual content will be out of it, right? And now it is here for us. And again, like you need to move it the some root directories, right? Like in Linux we have root directories, something like /opt/etc/usr. So we need to move and copy these files there, right? So that this can be used by the environment itself. So again, you need to work like a root user here. So just do this sudo su or simple su part, and you are here still in your downloads folder. So what you can see, right, after doing this tar extraction, this will be the actual file you will be getting. You actually need to copy this one to this location, like /usr/local. So this is done. Like you have downloaded the complete Java package here in your system. But to make it accessible and so that all the executable programs can find it in their environment, we need to set it up in a path variable, right? This is a very common thing. I mean, let's say you have downloaded something, and from your terminal, if you type, let's say Python, so it just directly redirects you to the all executables of Python or the compiler, and your like code is getting executed. So how it is happening? For that, like we have just created up like kind of path variable. We have set up a path variable. That's why our terminal is able to recognize it, right? If I don't set up these path variable, so if I type, let's say Java something, some file name, executable file name, my program won't be able to execute it, because the terminal itself don't know where my Java is installed or where the executables of Java are placed, right? So that's why we need to set up this path variable, and where we will be setting up this path variable, and that is basically the .bash rc file. So I'll show you the bash rc file, and what we actually need to set up these two files, these two path variables, Java home and it's like indication for its executable, which is are in the bin folder. So let me just open this file for you, and let me show you what's the content here. Okay, so yeah, you can see here, right? Here, whatever is mentioned. So we had to set up Java Home and this one. So you can see I have installed it like /usr local opt. I have installed in that way, and /content/home. So this is the actual path for the Java where actual executables of Java will be placed. That is /content/home part. And since Java home/bin, now it is pointed. Currently it is pointed. So if I type Java on my terminal, so I will be able to see those options. So here, let me show you that what I am telling. So that's what, like the Java -version Java. If I do this -version part, so why my terminal is able to return these values, that what is the version of it and what is the runtime environment and these things, because the terminal itself able to recognize it. And how it was able to do it? Because with the help of that path variable, and that's why we need to set it up. And when we will set up the Hadoop, so there will be some configuration files in the Hadoop itself, which will be looking for this specific Java home path variable, because as I said, to run the different daemon processes of Hadoop, it needs the JVM part where it will be actually executing it. So it should be able to find it. That's why we have set it up in the .bash rc file. So after the bash rc file, what they have mentioned, since let's say we mentioned it, these path variables in the bash rc file, so they won't be accessible until and unless we make them activated, right? We need to activate them. So for that, we need to do this, like source this one, and those variables will be activated. After that, these are some alternatives, like in order to create the kind of soft links, so that like you can run, and those alternatives will be installed and created for you. Now our main point is to focus on this part, like downloading and installing the Hadoop part. So first, like before talking about this one, I'll talk about the different modes of the Hadoop, like the way we can install it in our system. So first, definitely the local or standalone mode. Second is pseudo distributed mode. Third is fully distributed mode. So I talked about, I think, distributed mode. This one, fully distributed mode, is quite clear and very straightforward, that we will be having a set of different machines or those commodity hardwares which will work like a complete cluster. All right. And we will treat them as a complete distributed cluster, and everything will be running on different server, right? We will be having one machine for the name node, we will be having different machine as a data node, we will be having one machine for the secondary name node, then for one machine for the standby name node, then machine for a resource manager. So it's completely distributed. Every daemon, a specific daemon or process which has their own responsibilities, is running on different set of machine. And pseudo distributed mode, what happens, like those daemons, like everything will be in your laptop itself, like you will set up your things in your laptop. But what happens, since we have different backend process which we need to run, like the name node and the node manager, the resource manager and data node, right? So these are the some backend processes which we need to run. They will be running as a different process within a single machine, right? So how it will feel like that my machine is itself like working like a distributed environment. That's why it is named it pseudo distributed. I mean, not completely distributed, but somehow looks like within one single laptop there I have created different daemon processes, right, which are working on different workspace area, and they are like working together in order to give us the feel of the distributed environment. So the way we will be setting up this Hadoop in our local machine, so that will be actually a pseudo distributed mode. But also there is one mode like local and very simple standalone mode. I mean, if you don't set up anything or you don't mention any extra path or variable, and you just trigger the Hadoop processes, so they will be running in one single JVM, right? Then they won't be running as a separate process. So this setup mostly used for the testing purpose and all. But pseudo distributed is something which will be trying to do, so that it is giving us a feel of the distributed environment. Right, so what's the step they have mentioned? Like, we will be looking for this specific Hadoop 2.4.1 version. So again, what you need to do, you need to work like a root user. So first run this su command, and then switch to this directory cd/usr/local, then run this command wget and this complete path. So again, I said sometimes these paths won't be working. So if let's say this is not working, then you can simply download this one manually. Just copy this one, come here and type this one right here. As soon as you will click on it, so like you can see this link right where it is available, and probably you can click on the tar, like download tar.zz, right? And this is the actual thing they are also looking, tar.zz. So not, if this part is not working, you can manually download this one from here, and it will be available in your download folder. Again, since it is a like the zip kind of part, so we need to run this tar command to to extract the content which is available in the zip file. And once it is here, then what we need to do, since we are already in this directory, right, /usr/local, so we will be moving this one, right, the entire content which has came out after running the tar one, which will be this one. Like, move this one into this simple Hadoop folder, right? So just simply straightforwardly follow these steps, and I don't think so you will face any kind of problem, because I have also followed these straight steps, and it is working fine in my setup, right? So this is done. And after, like, Hadoop is also something, and there are some specific commands for Hadoop as well. So in order to execute them and in order to use it, the way we set up a path variable for Java, in the same fashion we need to set up the path variable for the Hadoop as well, right, where actually we have downloaded and all the executables of Hadoop are residing, right? So how we can do it? Again, we need to open that .bashrc file, and since we copied here, right, /usr/local, and within this one there will be one folder like created Hadoop. So this will be the actual location, right? This will be the actual thing where all the executables of Hadoops are present. So again, until unless if you don't do it, so the way like terminal was not able to find the Java, where Java, or if you type anything related to Java, it won't execute it because it was not able to find the Java home path. Similarly, Hadoop won't be working until unless you set up this one in your bash rc and then activate it using the source command. So again, I'll show you this step, that what we need to do. So I'll open vim.bashrc. You can see this part, right? Hadoop home usr local Hadoop, and then this part, right? So like, you can even pause the screen here and try to just copy these one. Although these things are mentioned, but if you think something is missing there, you can just copy, or you can just refer the names here and what path variables you need to set up, and you can do it in your laptop itself. So now our Hadoop home is also set up, and if I close it, and now if I run, let's say, Hadoop, so this is the way to cross verify, right, if Hadoop is successfully set up in our system or it is installed or not. Like, just Hadoop version, I mean, if your terminal, this terminal is able to recognize it, right, it will be simply like return this one, like what version is installed or anything. But if there is missing, in most of the cases, right, we used to do some mistakes with the path variables and all. So just set it up carefully, and I don't think so you will be facing any issues. So first, like, we need to add that path variable in .bashrc, and first after that we need to activate it, right? That's the important thing. Until and unless that won't be working, like Hadoop commands for us. So source /bashrc, it is like we need to hit the enter, and all the path variables will be activated. And now if I run this one, like Hadoop -version, right? All right, so it should be this one, right? Hadoop version. So it is like Hadoop 2.4.0, and this because it was able to identify it because we have set up this path variable. Okay, so this is the point here. And also yeah, probably I'll talk about this one in the next thing. So Hadoop, we are good. And after that, they have talked about this example, like running the example MapReduce code in order to verify if MapReduce services and Hadoop is working fine or not. So just ignore this part. We will be jumping on to the actual things, like installing Hadoop in sudo distributed mode. We need to make these changes, right? We need to put these changes in our system, and that's how it will be done. So again, if you have followed those steps, above mentioned steps correctly, again you simply need to copy these remaining path variables. Again, just come here, your bash rc, you can see right from this line to this line. I actually copied it from here and pasted it here, and those path variables are set for us. And again, I need to make them activated, so just run this command. And then we need to do some configuration related changes, right? We need to do it, and we will be doing it, right? So for that one, first what we need to do, so now if I do a Hadoop echo, right, this one, like Hadoop home, and if I do this, I will be able to get the path like where my Hadoop executables are actually installed, right? So I can do it. So I'll quickly do this, like cd, I'll move into this directory, right? And after that, they have mentioned like just go to this folder within this one, etc Hadoop, like cd etc Hadoop, right? And there what they have mentioned, there is a file Hadoop env.sh, where we need to just like initialize this Java home variable with where the Java is actually is installed in our system, right? Now let me show it to you what is stored in that config file. So vim.hadoop env, right? All right, just a second. All right, okay, something I missed. Hadoop env.sh, right? So come down, and they said the Java like export Java home. So the two things we can do, right? Since in our bash rc file Java home variable is already set up, so referring dollar this one means this Hadoop env.sh actually bring the path value for Java home from the .bash rc itself. If let's say it is not configured in your version which you have downloaded, here you need to set up the actual Java home, like basically the location where your Java is installed, and that will be done because your Hadoop environment should be able to identify where Java is installed. So that's how it will be done. Then there will be one file like core site.xml. What you need to do, you need to copy whatever is mentioned as it is here, and we need to copy it into the core site.xml. This is the file. I have already copied it, right? Just copy it here, and just right quit means you have saved your changes whatever you have made here. And after that, there will be another file hdfs site xml. So hdfs site is, this one is basically for the name node related thing, for the data node related thing, right? So there will be services running, right? Name node, data node. So name node, what it does, it used to maintain the metadata for file system where the blocks and your file is stored. So it will be storing it somewhere, and since it is everything is running on single laptop itself, right? So that means service or the process is running in my system, but it will be writing into the some folders which are available in the like laptop itself, right? So that's how it is going to work. I will show you that how I have configured it. So in the hdfs site xml, we need to just copy these properties, right? Just copy this complete section and edit or just add it in the hdfs site xml, right? So here, if I come, so first is DFS replication, like replication factor we talked about, 1, 2, 3, we can mention here. Then dfs.name.dir, like which folder in my laptop name node service will be using to write its content, like to store metadata related thing. So what I did, in this location, like this is the location in my laptop, USR, Shashank Mishra, desktop, and on desktop there is folder named as Hadoop, and within that I created one folder name as name node. So that means when my entire application will be running the MapReduce code, it will able to identify, or when like I'll start the those daemon services, name node, data node, everything. So using these properties, they will be able to identify that where name node will be storing data in the folder which I have created in the laptop, and where data node will be storing the data. So you can even create any custom like in your desktop you can create some folder or anywhere, wherever like you want your name node service to write its data, and wherever you want your data node service to write its data, you can create and just mention that path here. So file colon, it means the file system of your local machine, right? So that is the meaning here. So HDFS setup is done. Now yarn, this is for the resource manager. So again, just copy this one, and there is one file named as yarn site XML. Just mention this configure property here and you will be done. When we work on a like complete production level things, this is something which like IT teams used to handle. They will, like, you raise a request, they will be setting up the things for you, like everything end to end complete Hadoop setup. There is a specific job profile name as a Hadoop admin, right? So what that like person used to do, it will completely take a handover of your Hadoop related things, admin related, like managing all name node, data node related servers and everything. That guy will only provide you the actual IP addresses where your name node is, where your data nodes are, where your yarn is, and you can just mention those IP addresses and where your services are running in your code, and you are done. But here we need to learn these things as well, like what all files or important files where we need to make the changes and everything. So core site HDFS related to name node, data node, yarn, this configuration file related to the resource manager, which is yarn here. So we made the changes right? And then there is again MapRed, like MapReduce, when it will be running, then which framework it will be using. So that will be yarn. So we have a one MapRed.site XML as well, not this one, sorry, MapRed site XML. Okay, just a second. So all right, first what we need to do, this one, I think this was not set up, so we will be doing, okay, we have this one. Let me just copy this one to this one, simply running this one, and since I need to do it for this one, it is done. Now if I do a map red.site.xml, so here it will be this, and yeah, MapReduce.framework.name, yarn is here, right? So that is already copied. Great. So this is here, and now this is part also done. Cool. So we are almost here. Everything is set up now. We are on our way to start those daemon processes and all. So first, like JPS, let me check one thing. All right, nothing is running in the background. So before starting anything, right, just come out, like cd root, just come to your main or like home folder, wherever your working directory was as your user, you will be coming to that. And here what they set, like HDFS name node -format. So set up the name node using this one, like your name node will be ready. The service won't be in the execution mode. It is just like we are cleaning up, right? Name node, let's say you are starting a fresh setup in your machine, so we need to actually clean it up, and that's how it will be started as an initial point. And since I have already done it, and I can probably do it again, and no worries on that part, let me do it. So HDFS, like this, we haven't started any service yet, right? So JPS is one of the command which will let us know like what all services, backend services we have started for the Hadoop, right? So I have run this JPS command, and here you can see, right, nothing is like in the background, and these are some orphan processes, so nothing to worry about that. So if I just do it, right, HDFS name node, so it did something, and it is asking that whether I do want to clean up the things or not, and we did it, yes. So now the name node part is completely set up, and everything is set up here. So this is like there are two ways to start. There are two ways to start all the services, right? So let's count that what kind of services we talked about so far. So name node will be the one service which will be working as a master. Data node will be the one service which will be working as a slave node. There will be a service resource manager which will be working for the yarn. There will be a service which will be like the node manager, which runs on the each data node, like for the resource management and all, right? So these are some different services. So if we just want to start the name node and data nodes, because they are related to the like distributed storage part, like HDFS, so we can execute this start-dfs.sh, so it will start those services. If we want to start the yarn, we can run this service, and we can see like all these services running. But let's say if we want to start all the services in one single go, we can do it very easily. For that, like we have a simple command. Let me just show you that what is that. So first I'll take you to that location where our Hadoop was set up, right? So Hadoop, and if I do a ls, so if I go into the bin, right, and here in the if I go to the sbin ls, so if I go to this one, you can see this, right, start-all.sh, and there is another shell script which is stop all.sh. So if we execute these services, these shell scripts directly, they will initiate all the backend processes for us. We don't need to like just run, or we do not execute them one by one. So this is the thing here. I'll come out from here, since we have already mentioned the Hadoop home path there. So if I directly run this one from here, right, simply like from my home location, start all.sh. So now you can see, right, localhost starting name node, like our name node service is getting started, then data node service is starting, and let's wait, then the secondary name node service is getting started here. After that, daemons related to yarn, which is resource manager, got started. Now as I said, we can see all these running services. So you can see name node is here, secondary name node is here, node manager is here, resource manager is here, and again let me just do it. All right, so we have these services here. Now let me just quickly run this part. Let me quickly check this one, like so for again JPS, what is the data node logging? Data node is also there, and okay, all right, okay. So we are name node, secondary name node, resource manager, node manager, these are running, these services are running one by one, we can see. And next So in order to interact with the or to just install anything in HDFS, so HDFS is a different file system like distributed file system we talked about. So it's again a like different file system. Let's say in Linux we have a different file system, how we are executing and how we are running the command. Simply let's say writing cd l /home something, right? And we are done here. Similarly, in order to access the HDFS file system or to store anything there, to create anything there, we have this command, right? HDFS DFS, and after that simple -ls, and this slash is basically for the root, because in HDFS everything will be started from the root. So now let me first do it this way, right? So this is some warning, we can ignore it. So right now there is nothing. So first what we will be doing, we will be just putting some file here, right? HDFS DFS -mkdir, and we will create one folder in the root location. Slash means root here in Linux. So input right means we have created one folder. So HDFS DFS folder is created and we want to verify it, right? So how we'll be can do it? HDFS DFS -ls and input, or we can do it this one, like what is present in the slash root. So we can see this one, right? Slash input. Now this is done, and what we will be doing, also I will take you to this home folder Hadoop, and here I have some files, right? I have already created that mapper.py and reducer.py. Even jar is available. Name node folder is created, data node folder is created. So what I'll be doing, I'll be copying this words.txt file into this HDFS location, so that I can run my MapReduce code and it will show us some output for that one. So let me just show you what is present in this file, right? In the words.txt. So this is again a plain text file which is containing some words separated by a space, and it will be used for the this part. It will be used for the word count problem. So how we can do it? Simply HDFS DFS -put command should be used to copy data from local machine to the HDFS file system. And local machine, not local machine, basically local file system to the HDFS file system. So -put, this is our file, and where we want to put it, we want to put it into this location slash basically root in the HDFS and then input folder, and it will be copied there. All right, something wrong. Warning, HDFS file input only be replicated to 0 nodes. Okay, some issue with the data node, looks like JPS resource manager name node, and why some issues with the minimum nodes instead could only be replicated to 0 instead of there are 0 data nodes running. Okay, data node service is down somehow. How it can be looked. All right, so something wrong here. Let me quickly look into it. Okay. Start. Let me first again stop all these services, and for that we can use this one, stop -all .sh. Okay, so first let's stop these services, then we will look what the issue with the data node. All right, stopping these services first. All right, let me quickly check JPS. Okay, no background services are running. So let's try this one. I mean, if after using this one, if we are facing the issues related to data node, we can debug more that what is happening, because here it is showing that starting data node, started name node, but then why data node service got killed in the background or not even started, we can look into it. All right, name node started. Secondly, name node is not getting started. So let's quickly debug it. What is that? Why it is not running? We did the complete format part. We did the name node formatting. That was also fine, and we can just resolve it. Data node logging to this one dot out, starting data node service not starting. Okay, let's copy this one. There are excluded, and we will come here to check the error. All right, let's debug it as well quickly. Following this one HDFS map reduce what they have mentioned. Stop Hadoop and clean up temp file. Okay, I think this is step 2 name node. You can see data node. This is, I think, not there are 0 data nodes or no data nodes, so let's look into it. Yeah, these are the challenges as well, so I think it's good as well that we've just faced that error, and we'll be able to look into it, how to fix it. What can be the challenge? This is the main point. Okay, all right. Again, look at this one, master. For this guy, master is running here. Let me check. Stop RM HDFS. Alright, so it is telling me like I can first clean up my data node folder where the actual content I was storing. Okay, let me try that. JPS. Alright, so sh stop all dot sh, because sometimes related to caching and that it happens, right? So let me do it. So where my data node folder was, I will show you. All right, so here the data node folder, right? So rm-rf, and this is the data node, right? And if I do it now, so data node folder is gone here. Now I can quickly create the data node. So mkdir data node is created, and now I think I should again run this command here, the cleanup one. So let me do this cleanup again. dfs complete format, and again yes, name node. This is done, and okay, this was also mentioned. All right, let's try this one again. I hope we don't find that error. So start -all dot sh. Name node is starting, data node is starting. Earlier it also showed like it is starting the data node, but probably it was not started accurately. So let's check that out. JPS. Cool. So data node here, this one, we can see this service. So all the relevant services which we wanted. So resource manager, node managers, secondary name node, data node, all the services are up. And here what they mention, like where we can check the like after all these services are running. So using this URL, we can see the simple web UI for like looking at the DFS, like the local storage. But if we want to see the yarn, where our yarn is running, so if I click on this one, So this is the simple UI for the yarn, right? If you remember when I was presenting that PPT, so there like you can see every detail about your entire distributed cluster, which will be mentioned in your yarn itself, right? So like how many jobs are submitted, pending, running, completed, how much memory, let's say you have a 100 like the entire capacity of your distributed cluster is 100 GB, how much it is being used, how much it is left, how many active nodes means how it actually helps to populate this UI, those heartbeats, like yarn communicates with the name node in order to just see how many nodes are active. Let's say there were you had a cluster of 10 nodes and only 8 nodes are working, so we will be able to see all the details. And once the job also gets submitted from the terminal, that will actually come here for the execution, like yarn will take care of the resource management related thing. All right, so this is done here, and now let me run this command again. Since we we format our name node, so those things which we created earlier like slash input, those will be vanished. So hdfs dfs hyphen ls, let me do this root part. So you can't see anything here, right? So again I need to do this mkdir slash input. This is like input folder is created. Now I want to copy that words.txt, so hdfs dfs hyphen put and words.txt within the input folder in the hdfs location. So now it will be copied, right? We this time we didn't get any error. hdfs dfs hyphen ls, if I do it for the input, we can see here that words.input has been copied to the hdfs location. Now this is ready. I will quickly show you how we gonna run the mapper and reducer part, like map reduce code. So it's in Python. So here I, like when I was talking about the map reduce thing, so there were two components of it. There will be mapper part and there will be a reducer part. So mapper and reducer are always two things which are customizable. Okay, those will be user defined things, and I will show you how things are done in the Python. So I have written a like mapper.py and a reducer.py, and we will be using these two functions while submitting our like map reduce code. So first I'll open the mapper.py, what is happening in the mapper, what are the code there, and then I'll open the reducer part. So vm mapper.py. So here I have imported this sys1 and for line in system.in, because for this piece of code, the lines, right, which are written in the words.txt will be coming as a standard input, right? And this entire piece of code, what it will be doing, just treat it like this piece of code is running on different partitions which are available on different data nodes. It will compute its own like whatever partition or whatever data is available on that data node, like just read it as a one single line one by one and doing this mapping part. And we will look at what it is doing in the mapping. So it read one line, whatever is written, and doing the line dot strip, I mean just removing those starting and removing starting and ending spaces. And after that it is doing the split on the, by default it will be on space, right? So what will happen, let's say there were 10 or 15 words written in one single line. Those will be now created or divided as a list of words, right? Because it has been separated and split function has been applied on that line. So that line will be as a simple string, plain string, which is words basically separated by space, and split function will divide it and will return us simple, you can say will return us a simple list which will be containing the words. And after that what it is doing, it is just iterating this list and picking words one by one. And what it is doing, printing like something doing it, right? What it is doing, creating a kind of pair where what will be happening word, I mean what, let's say it found Shashank, then it found Mishra. So what it will be creating, Shashank comma 1, Mishra comma 1. Okay, so that's how it is generating 111. I mean, when I was explaining, you can totally relate it with the word count explanation I gave you in the previous section, right? How the intermediate output was generated by the mapper. So this one is actually treated like an intermediate output generated for the reducer part, because a mapper will generate the output in the key comma value. So here word mean whatever is present in the line, those will be treated as a key, and value, which is 1 here, will be treated as the numeric value for that one. So these kind of intermediate outputs will be created. So that is the simple functionality for the mapper code. And now I will show you what is in the reducer part. So here in the reducer, you can see what it is doing. Whatever is coming to it in the form of you can say the intermediate output, it is doing a very simple thing like word comma count, because from the intermediate output it is reading kind of a pair, right? Bracket some Shashank comma 1. So this is the way of this is the simple way of generating the output or reading or assigning the values in Python. So comma 1, right? I mean, it will be a kind of pair, right? So what it did, it sliced it. So word will be assigned in this variable, and whatever value was written for that one, it will be assigned to count variable. And what it is doing, trying like count for that one, whatever was the total count for that one, it is actually trying to convert it into the integer, because that whole thing will be received by the reducer as a plain string, right? So word should be treated as a string, and that one that should be treated as a numeric one. Then we'll be able to do the summation and aggregation. And after that, what it is doing here, right? Simple, you can also see we imported some packages. Current word, in the beginning it will be 0, then current count equals to 0, and word like we will assign it. It's just a simple logic that we are just iterating on intermediate outputs which we have received in the form of key comma value, and we are iterating it here and here, just doing a summation, right? Let's say you have some pair, right? Bucket of pair in the same fashion, Shashank comma 1, let's say written in one slip, then Shashank comma 1 is written on another slip. You just figure out, you collected all those such slips where like Shashank comma 1 is written. So every time, let's say you are doing the iteration and you want to take a total count, local count of the word, some specific word, you can just try to match it, right? This is the simple logic. I mean, very straightforward. If the current word is equals to the word which we have seen previously, then current word for that one, we should increase the frequency of it. And if not, then that should be printed on the screen, and current count should be the equal count which we have seen so far, and current word should be the word which like not match, because now we will be counting for that one. And after that, we will, like when we will be out for this loop, we will just print it on the terminal, or I mean writing things into the output file that will be taken care by the Hadoop library itself. So here, this is in the Python, this thing is very straightforward. Again, you can just stop this screen and you can read the entire code and try to understand how it is working. And when you will be writing it and you will be looking it into more closely, it will be like more understandable to you. So how it is being done here, simple mapper and reducer, this treat it like a two functions we have created, customizable. And now let me just come out from here. Okay, now our task is to basically run this program and see that from the input file, the word file, we are able to get the entire count for that one or not. So for that one, to perform the entire map reduce thing, we need the actual Hadoop library, right, which contains all the important things. Because you remember, right, in mapper there were a lot of tasks, in reducer there were a lot of tasks. So in order to do all these things, we need a jar file, right, which will contain all those necessary function. and like will do the computation for us. And here with the help of Python, like when we write the MapReduce in Python, we just need to focus on two things, right? The mapper and the reducer part. So how we are now going to execute it, that is again very straightforward. So I will show you that what is the command for that one and how we can actually execute it. So for that one, again let us look at run execute it from the Python. So this is done, and I hope it is clear too as well. Execute MapReduce in Python, right? We will look at the command. Okay, so MapReduce execute Hadoop jar. Okay, we will be looking at this one, not this one, whatever was the part. So the simple command is Hadoop jar, this one file, not the mapper, reducer input output. I think this is the entire command to run the, all right, not this one. All right, so how we can do it here? Simple part is the command Hadoop command to run MapReduce in Python. Okay. Very simple command it should be. Or it just, what was that? I'm actually just missing the values. It was like Hadoop jar, I think mapper, Hadoop jar, how to run a jar file in Hadoop. No, it was run MapReduce code in Python. Okay, I think that command should be in tutorials point itself. Yeah, it should be here actually. This is the command. Yeah, this is the command. So it should be like Hadoop hyphen input hyphen output hyphen mapper reducer. All right, so basically you can cut this part. I mean, from where I was on this terminal and I was saying that how we can now execute it, and just cut this exploration part for the command, and I will just simply write the command here for the execution. So you can cut it from that part, and like, so that this thing is not visible, like how I got that command part. So Hadoop jar, and here first I'll show you that I have this jar downloaded. Again, you can just simply copy this name in your terminal, in your browser, and you will be able to download this jar file, because that is needed. This is for like running the executables and run the MapReduce code using the Python, because this jar is containing all the important like intermediate processes and methods which will be accepting function reducer as a function, and completing the whole MapReduce related thing. So the command is Hadoop jar and Hadoop streaming. This is the jar, and hyphen mapper is basically our mapper.py hyphen reduce is equals to reducer.py and hyphen reducer reduce.py and hyphen input is basically our input file path in HDFS, which is words.txt, and slash output. So here you might be thinking that slash output is something which we didn't create at all right earlier, and why basically when we pass the or when we try to execute map reduce code, so this one will be automatically clear. This whatever output path will be mentioning, that will automatically be created by the Hadoop itself. So that's why we didn't mention. So this is the Hadoop jar. This jar we are passing, this is Hadoop executable command. This is the jar it need to look for. This is the mapper function, this is the reducer function, this is our input file, and this will be the output folder where we'll be writing our code. So let's run it. Oh, all right, something happened. Wait, something I missed. Required, it should be Hadoop I think hyphen jar. Wait, clear, let me clear it. Hadoop jar, it should be hyphen input hyphen output mapper reducer. What is missing then? Alright, this is weird. Missing required option. Oh, okay, what I was missing, I missed this part. So output, like hyphen input, then input path, hyphen output, then output path. So this will be the folder name actually. So now let me run it. So this is getting executed here, right? Map 0% completed yet, reduce 0% completed yet. Wow, something got failed, application failed, execute exemption from container, executed, kill application. What happened? John client, vacation from container, job run application not am due to for attempt execute with this one, exception from container launch, exception code run command, container launch something while submitting the application. All right, nothing to worry about. Let me just try to reset it. Okay, something came here and it quickly, like you can see here, right? This application came here but got killed. Now let's debug it, why that happened. It is exception from the container launch. Let me copy this error. Let's try to figure out what happened. Exception from container launch, exit. I have installed Hadoop input output, and you are giving local file as input, word count program HDFS. So we have given the HDFS location, that's not an issue. Hyphen, okay. So this is something related to yarn exception from container launch. Let's look at this error. All right, so this one also is having the same sort of error. The issue seems to be specific. No, our part is not related to yarn. Kill this one, container launch. Okay, I think this is, let me do it again. Since this is one, we are submitting the job on yarn itself, right? Let me try that out. If it fails, it will fail for yarn as well. And if we simply are not submitting, because that is something which might take time to debug that what is happening, job running in process, local error, stream, exception from container launch. Yarn. Okay, this is the yarn manager. I think we need to mention this property as well. Okay, this is the HDFS, not an issue. Problem, it was in the map reduce dot site XML. These lines was in map reduce property. Every value inside the tag should have the FN prefix. Okay. No. So I think in this one we should add the name node, and that let me debug it first and then I'll again quickly start from. Alright, so guys, actually I tried a lot of things just to fix that error, which is nothing much related to the yarn. So what is happening there, when I'm trying to submit the job, obviously it will go to the yarn and yarn will manage the things. And since it is the pseudo distributed mode, and again the Hadoop part, the version we are using, those are the older one, and there are some issues related to the library paths or configuration related things. I tried a lot of things which probably not working out at this moment, and that may take some time to fix and to figure out why yarn is actually not able to accept those applications and not able to run it. But that's okay, completely fine. It's not the case that we won't be able to look at the map reduce mechanism, because without yarn as well we can run our application here. So if you remember, when I was talking about Hadoop 1.x or 2.x version, so in Hadoop 1.x version, what was the thing, right? Like there were two components, map reduce and the like HDFS only. So map reduce itself, like a mapper, which is basically was doing all the resource management related thing as well. And even in Hadoop.2x they introduced yarn. So it's not like that if yarn is there then we have to have installed the yarn and set up the yarn to do this thing. That like backward compatibility is there. We can do the like we can execute our job without the yarn itself. All right, so we will be doing that one for the sake of the demo, and to show you how the map reduce thing are working. So just think in that perspective, like the functionalities of yarn, what yarn actually will be doing, and its role and responsibility. And here it's like we are just executing our map reduce code, and map reduce itself taking care of the resource management. That is the simple thing. So don't get confused, we won't be using yarn here because of that issue. And let me just again revise you things like JPS and those services name node, like node manager, data node, name node, resource manager are running. Although we are not going to use yarn, we won't be submitting our job to yarn. And I will show you that because we did that configuration by following the set of instruction, then what section you actually need to comment so that your job is not getting submitted to Yarn. Actually it is using the map reduce for the resource management. So for that, what you need to do, you just simply go that location where our Hadoop is set up, right? And within that there will be like folder etc and Hadoop. And here, right, we have couple of files, and one file was like mapred site XML, right? So if we can see earlier, this property was added, right, mapred, which was basically for the execution resource management, it will use the Yarn. But here I have commented it. So when we talk about the XML format, this is the way to comment out anything. So this greater than sign exclamatory double hyphen, then to end it double hyphen, and this bracket, right? So that's what I did. And now as I will execute the command won't transfer or send my job to Yarn. It will just simply use the map reduce itself for the like resource management and all the computation. So now let's quickly run that one. First, again, I'll go back to the previous directory, and this was the command, right? We had Hadoop jar, this was mapper function, reducer function, this is our input file, and this is our output file. So now let me run it, and yeah, very quickly, very fast, because when we interact with the Yarn, there will be like, it will be a complete cluster, and it will send the job, it will just figure out the resource management. But here everything is managed by map reduce, and it's a single machine, nothing, very simple small job, so did it very quickly. So before let's say, okay, I'll show you the output first, then we will talk about different steps using this logging information, where map was running, what reduce was doing. So we'll look at these things. First I'll show you its output, how it looks like. So again, hdfs dfs -ls. Now let's do it. So we can see earlier we created input, right, where /words.txt was there. Now this /output has created. So let me first show you what is there in the /output. So here in /output you can see underscore success and part 000 something. So what is this part actually? So if you remember, right, when we were talking about the map reduce complete architecture, so I told you that there can be like few number of reduce tasks that is customizable as well. We can also pass that parameter while submitting our job. So let's say there were 20 reducer, so they will be processing the individual aggregation, right? Their aggregation, they will be doing it, and then the final data will be written to the output, right? Then the output folder. So what happens when we do the parallel computation? So it's not like that the entire one single file can be created, but here in this case, right, since it is about the word count problem, everything will be present in the like one partition itself. But let's talk about that data where it is let's say we did we did some local computation, right? So what will happen, like this is one reducer, it process some specific number of keys, right? So there will be some input, there will be some output size as well. So what is happening, simple, this part 00 means this has been written by one reducer, right? Whatever it computed, because here in one reducer all the keys related to some specific words are present there. So its complete aggregation is available with that reducer. So you don't need to worry about that, like some output for that specific key may be present on reducer, because of that step, shuffling, sorting, all the data related to specific word is present on reducer. So whatever some reducer X computed, it has just written into this output folder. So let's say there were 10 reducers running, so whatever they have computed, they will be writing individually into this output location. Like here it is like named as part 000 something, and then again part 001 by another reducer, part 003 by another reducer. That's how it will be, right? So here it is only one part, and underscore success, this is a kind of temporary file the system itself creates, right? And how it basically creates, just once all the reducers successfully write their part, then this will be file, this underscore success file will be created, just a notification that all reducers has done their task, and we are good to go, and we are good to go basically exit the process. So now let me show you the output which has been written in this part. So again, it's simply HDFS, DFS, whatever you use in the Linux word, same kind of commands you can use, like cat, just to display the output. And now if I copy this part and paste it here, and if I do this, so we can see, right, this is the output, right? These were the words present there. So this is their total count, it these number of times, A these number of times, B these number of times, right? So we can see the our output what we wanted to calculate. And now I will just look at this informations what was presented here. So here we will be looking at this one, like total input paths to be processed, like one input file be provided, number of splits, one split was only created because file size was very small. So block, physical block, and then input split, like quite similar things. And here we will look at this one, right? Number of reduce task, like only one will be created, and what is actually happening in the mapper task, right? So map output collector, these are some things which are getting defined, right? And where mapper will write its output. Okay, here like just these are some intermediate things which is happening here. And map task, right, starting flush of map output, whatever map function calculated, that will be written to intermediate buffer. Those intermediate outputs will be read by the reducer itself, right? So till this point, map task executor completed. Here we can see this log, like there the complete map task was done, right? And here from this point, right, reduce task actually took place using shuffle consumer plugin, right, for that shuffling part. And here we can see other things, right? In memory map output, whatever reduce function is doing. And these are the things, right? Merging one sorted segment down the last, merging one segment, merging one file. And here map read task, all the tasks are completed. Here we can see, right, the complete map means 100%, all the map task has been completed, and reduce 100%, that means all the reduce task has been completed. So that's what we had for the demonstration part. I hope it is clear to you. I know the yarn part is something which could have been covered, but somehow that will take some good amount of time to fix and look into what is the issue and what can be fixed. But in coming sections, whenever we'll bring the new video where we can extensively talk about the Hadoop, there we can actually try to set up yarn, and we'll be looking at that example. But same thing, I mean, there is no issue to run your job with the MapReduce itself, because MapReduce itself can do the resource management, which like if we this issue couldn't have take place, then yarn would be the one who will take care all of the resource management. But process would be same, whatever steps we saw here, right, in the logging, that means whatever we discussed in the architecture, same steps has been followed here. So that's what we had for the demonstration part. I hope now Hadoop architecture and its basic programming part is clear to you. So that's what we had in this video. I hope you have like enjoyed this entire session, whatever we talked about the big data, Hadoop and everything. If you did, make sure to like the video, and also if you are facing any problem, just put it in the comment section, even related to the setups and all. We will be helping out with you the answers. And if you have any suggestions, then also put it in the comment section. Share your thoughts, and also don't forget to subscribe the channel. So yeah, we will come soon with another interesting topic related to big data. So till then, bye bye.